हेलो, गुड मॉर्निंग टू ऑल। सभी हमारे जो दर्शक है, मैं सभी के लिए नमस्कार बोलता हूं। मेरा नाम अशोक रूपनेर है। मैं आईसर पुणे से आपके साथ बात कर रहा हूं। टुडे इज अ स्पेशल डे फॉर अस। आज क्या है? वी आर सेलिब्रेटिंग नेशनल साइंस डे। पूरे हमारे देश में नेशनल साइंस डे मना रहा है और आईसर पुणे भी हर साल बच्चों के लिए, टीचर्स के लिए, कॉमन पब्लिक के लिए बहुत इंटरेस्टिंग एक्टिविटी करता रहा है। और ड्यू टू पेंडेमिक दिस ईयर वी आर सेलिब्रेटिंग नेशनल साइंस डे वर्चुअली। तो हमारे डिस्क्रिप्शन बॉक्स में पूरा जो प्रोग्राम का जो शेड्यूल रखा है, जो टाइम टेबल है, हमारे डिस्क्रिप्शन बॉक्स में रखा है। उसमें बहुत बहुत इंटरेस्टिंग चीज़ें हैं। तो पहली तो क्या है कि एटलीस्ट फिजिकली तो यहाँ नहीं आ सकते, लेकिन वर्चुअली हमारा साइंस गैलरी का आप आनंद ले सकते हैं। तो उसका जो डिटेल्स है, लिंक है, हमारे डिस्क्रिप्शन बॉक्स में हमने रखी है। और उसके बाद जो होगा, बहुत इंटरेस्टिंग सेशन हो गए। फन ऑन हैंड्स ऑन साइंस, फन ऑन मैथमेटिक्स, और बहुत बहुत इतने अच्छे अच्छे प्रोग्राम आपके लिए हमने लाए हैं आज। डायनेमिक टॉयज फ्रॉम ट्रैश, ये सभी जो एक्टिविटीज है हमारे इंटायर शेड्यूल में सुबह 10 से, मतलब अभी से लगभग 6:30 तक है। और स्पेशल सेशन भी आपके लिए है। वो क्या है? लेट्स मीट द साइंटिस्ट। अलग अलग जो टॉपिक्स है, जो करंट टॉपिक है, अभी हम सभी को मालूम है कोविड के बारे में बहुत कुछ लोग जानना चाहते हैं। तो देयर इज अ वेरी वेरी इंटरेस्टिंग टॉपिक्स ऑन द कोविड, जो डिस्क्रिप्शन बॉक्स में उसका हमने डिटेल दिया है। और उसके बाद जो है ना, पूरे देश से हमें बहुत अच्छे प्रोजेक्ट मिल गए बच्चों से। बच्चों के साथ भी इंटरेक्शन है वर्चुअली। उसके साथ बाद पैनल डिस्कशन भी है। और एट द एंड ऑफ द वेरी वेरी नाइस अवार्ड विनिंग फिल्म जो है GN रामचंद्रन के लाइव के ऊपर, वो फिल्म भी हम आपको स्क्रीन करेंगे 5 o'clock। तो बिल्कुल हमारे साथ पूरा दिन आज रहिए, आपको बहुत इंटरेस्टिंग चीज देखने को मिलेंगी। तो along with the schedule we have very very interesting information in the description box। उसमें बहुत बहुत अच्छे से बुक्स हैं, एजुकेशनल रिसोर्सेस हैं, फिल्म के लिंक हैं। तो बिल्कुल आप डिस्क्रिप्शन बॉक्स में जाइए और आपको बहुत अच्छा बच्चों के लिए, टीचर के लिए, पेरेंट्स के लिए, जनरल पब्लिक के लिए अच्छे रिसोर्सेस मिल जाएंगे। तो मैं फिर एक बार सभी को विश यू वेरी वेरी हैप्पी साइंस डे। और आज साइंस डे की शुरुआत हम ऐसी करते हैं। जस्ट लेट मी रिक्वेस्ट आवर डीन प्रोफेसर हरिनाथ चक्रपाणी टू गिव हिज ओपनिंग रिमार्क एंड इंट्रोड्यूस आवर आईसर पुणे इंस्टीट्यूट।
Welcome. IISER Pune is a research-intensive educational institute where teaching and research are highly integrated. With nearly 150 scientists and more than 500 doctoral students on campus, IISER Pune works in nearly all areas of science and mathematics. The 5-year Bachelor of Science and Master of Science program, which is a major academic program of our institute, is very unique in that the students carry out a 1-year research project in their 5th year. These academic programs together will help lay the foundation to train the next generation of scientists for our country, while making key advances in the research and development sector. During the past decade, faculty and students of IISER Pune have developed a close connect with the world outside of our institute. One of the major hubs of our outreach activities is the Science Activity Center. The Science Activity Center was established in our campus in 2017 and has hosted thousands of students, teachers and science enthusiasts. One of the unique features of our center is that we use simple science toys and hands-on activities to explain even complex scientific concepts. As you all know, the past year has been very challenging for us due to the COVID-19 pandemic. We took this as an opportunity to engage online with a large number of students and teachers. We did this through our YouTube channel where we conduct. Welcome. IISER Pune is a research intensive educational institute where teaching and research are highly integrated. With nearly 150 scientists and more than 500 doctoral students on campus, IISER Pune works in nearly all areas of science and mathematics. The 5-year Bachelor of Science and Master of Science program, which is a major academic program of our institute, is very unique in that the students carry out a 1-year research project in their 5th year. These academic programs together will help lay the foundation to train the next generation of scientists for our country, while making key advances in the research and development sector. During the past decade, faculty and students of IISER Pune have developed a close connect with the world outside of our institute. One of the major hubs of our outreach activities is the Science. Welcome. IISER Pune is a research intensive educational institute where teaching and research are highly integrated. With nearly Welcome. IISER Pune is a research intensive educational institute where teaching and research are highly integrated. With nearly 150 scientists and more than 500 doctoral students on campus, IISER Pune works in nearly all areas of science and mathematics. The 5-year Bachelor of Science and Master of Science program, which is a major academic program of our institute, is very unique in that the students carry out a 1-year research project in their 5th year. These academic programs together will help lay the foundation to train the next generation of scientists for our country, while making key advances in the research and development sector. During the past decade, faculty and students of IISER Pune have developed a close connect with the world outside of our institute. One of the major hubs of our outreach activities is the Science Activity Center. The Science Activity Center was established in our campus in 2017 and has hosted thousands of students, teachers and science enthusiasts. One of the unique features of our center is that we use simple science toys and hands-on activities to explain even complex scientific concepts. As you all know, the past year has been very challenging for us due to the COVID-19 pandemic. We took this as an opportunity to engage online with a large number of students and teachers. We did this through our YouTube channel, where we conducted a number of online workshops and webinars. I am pleased to note that the number of viewers on our channel recently crossed 1.5 million. Today, we are celebrating the National Science Day. This is celebrated to commemorate the discovery called as the Raman effect by Sir C.V. Raman. As a part of our Science Day celebrations, we have a very interesting lineup of science and math activities. We have presentations on gravitational waves, of course on coronavirus and many other interesting talks. I welcome you all to actively participate in our events and enjoy this year's program. Thank you. Welcome.
Hello everyone, and sorry for that technical error, but it's been sorted. And welcome to this interactive session on this occasion of National Science Day. And I welcome all the participants, audience, and science enthusiasts on this auspicious day. And without further ado, let's start the virtual tour. And I can see in the chat box many students, teachers are very much excited to this new event. So let me introduce to this. So we thought that during this pandemic, it's really hard to go visit some gallery, because if it was a regular day, so people might have went some science gallery, museums. This is a very special day. Okay, we want to ignite young minds to make more engaging and some scientific intellectual things and to ignite them on this occasion. So without further ado, let's start this science virtual gallery, science and maths boards. So during in next 10-15 minutes, I'll just take you to this virtual lab, not virtual lab, but virtual gallery, where we have many interesting hands-on activities, and it's the similar way how we show the gallery to you. So I hope this will be a very interactive and amazing sessions for all of us. Let's start with that. So I'll just share my screen. I hope it's visible. Let me play some sound for you. Okay. So let's start the session. I can just play with that. So this is a virtual gallery. So we'll start the session. So let's start the guided tour. So this is our first reception hall. These are 2 volunteers we have. So this is a help desk. I am very much sure there may be some clapping sound. So we'll just mute the desktop audio. Fine. Okay. So we'll start the first. So you can see this is a physics section. We are going to the physics section, and the first experiment we have here, simple thermometer. And this is a very interesting activity. Many of us who have visited our center, we have shown many times this one. So you can also check our repository. The link may be in the description box. So during this virtual tour, I'm not going to explain each and every activity, but I'll explore the things what we have in our science activity center. So this is a simple thermometer based on air expansion principle. We'll move to the next one. So let's move here to the field lines, magnetic field line concept. Fine. So this is another interesting activity we have documented in our gallery. So yes. Okay. So we have another interesting activity here we called as properties of light, where we have documented many interesting concepts of light, including reflection, refraction, and this is a very interesting hands-on way to explain all the properties of light. So this is also another interesting activity that you can check in our on our website in our sequential photographs. So this is another, we have levitating pen. So this is also another interesting activity which demonstrates the magnetic levitation principle. So let's start with something interesting. So can I have here? Yes. We'll see to the measuring oxygen in the air. So this is also a very interesting activity. Many of times there is a misconception with respect to the air, oxygen, amount of air present, amount of oxygen present in the air. So this is a very interesting activity that you can look, and it can be easily demonstrated in the school, and also during this pandemic you can try at your home. So what we'll do, we'll quickly move to the next section. We'll go to the math section. Let's see what is there. Yeah, we are back. So let's start with this activity. This is a very interesting and my favorite activity. Why tree trunks are cylindrical in shape. So this is also a very interesting activity to know how we can demonstrate some of the mathematical hands-on activity. So we have here another interesting activity, angles and sector using the 2-card circle. This is a very what I can say, a very engaging activity where you can see what you can explain what are the angles, what are the sector, and of course while it's a very regular example to give example of pizza. But if you try this activity, you will really come to know what is the exact angle and what are the sectors and what are the minor sectors, major sectors. All this engaging and all this parameters can be explained with the help of this activity. I have one LED also here, so let me, okay, we'll just rotate it, fine, yeah. So this is one LED we have placed, and it shows all the glimpses of our YouTube sessions that whatever we have taken during the last 6 months. So whenever we'll place this gallery link in the description box, but not right now, but still it is in a developing mode. But soon we'll place this link how we have made this. It hardly takes nearly 3 to 4 months to design this virtual gallery, but it's very interesting whenever the teacher wants to interact with the students. So she can or he can use this such type of interactive session. I have one more interesting fact to share with you. So let me just roam like this. Yes. Yeah. So now we are on the YouTube channel. So let me quickly share some statistics with you. So total this table shows us our achievement in the last 6 months on the YouTube statistics. So we have just make one what we can say poster, something like that, and we have placed in this gallery. So I appreciate all our fans, nearly 1 millions of fans who have encouraged us for this workshops and hands-on activities. So another interesting fact I have here is the guided point. So you can see I have so many points, I can directly go to there. So let me go to the hinge joints in the biologic section. So let's start to going to the hinge joint. Yes. So many of times we have got feedbacks that there are very few activities on biology section. So I assure you that if you visit our Science Activity Center webpage, you will find nearly many interesting activities. You can see entire gallery is of biology section. So you can see we have bouncing end, that is an acid-basic reaction. You can see here we have a pure joint activity. We are also having heart rate activity. And this is very interesting. I'll ask the team member to put the template of this brain cap. It's a very interesting activity, very engaging activity. Another activity, we have gliding and planar slide joints. With the help of very easy cardboard and matchstick, you can explain this type of activities. So let me go where I can roam in this gallery. Okay. Yeah, I'll go from this side. Fine. Let me have some interesting fact for you. This is an elephant toothpaste. That is, it explains the decomposition reaction. So I'll not go in the detail, but I'll explore all the stuff that we have here. So let's go along. We'll go somewhere with the wide view. Let's check how clear view we have. Fine. It's very interesting to. It's just like a video game, but still, we'll play with that. Wait a while. I'll go here with a simple DC motor. It's my favorite activity. Let's start with this. So this is another physics activity that explains the Fleming's left-hand rule, and also we have experiments for the right-hand rule. So of course we have some sections for the feedbacks. So whenever you visit this gallery, please give us some feedback so that we can improve on our skills. And I would like to tell you share you some of the photographs. Sorry. So we have here some of the teachers' photograph. You can see on here. So these are some memorable events that we have with the teachers and visitors to the center nearly 1 year back. So it's a very good to see them back again, we hope. So let's go somewhere in chemistry section again. Okay, I think it's giving me a real feel whenever I visit to some gallery. It's really fun to see the activities like this. Okay, we'll see this card centrifuge, that is separation technique. So you can see on your extreme left hand side there are some information here. So whenever you visit this gallery, there are some links here. So you can directly switch. I'll not directly switch now, but whenever you visit such type of galleries, we'll share the link. But there are some information regarding this activity. For example, this is a card separation centrifuge separation technique. Then if you click to this, this is, see, immediately it changes. So it's very engaging gallery, and also what I can say about this, it's very easy to make also. So you can see demonstrations and workshops of students. So you can see some of the images from our workshops, and what I can do, I can visit some of the directly. So I want here, let me say about IISER Pune, let me introduce that also. So you can see a group photo from one of the workshops. So you can also see this is our center photo, Srimati Indrani Balan Science Activity Center, from where rightly we are connected with you. And I hope you have liked this session. So we thought that okay, if the people are not able to visit the center, we'll have some another method to connect with you. So you can see here. So can anybody type in chat which type of activity they would like to see? So I can quickly go in that. So I'll tell you what type of activities I have. I have 5 caps from a newspaper sheet. I have a same area different perimeter activity. Also I have value of pi. So can I go to, let's see ions. Fine. So let's go directly to that activity. Oh, fine. Yes, we are here. So let's see ions. So this is also a very interesting activity from chemistry section. So it explains precipitation reactions and ion displacement. So this is also very interesting and engaging activity, and it can be done easily at schools, at homes also. So I'll move to the next section. Let's say from where I can go. I can go bright frames. Oh, yahi tha. Okay. So you can see some of the facts we have mentioned here. So it helps you to get directly redirect to our repository where we have documented such type of activities in a very sequential and hands-on way. So let's move to we'll go somewhere math section, and as I'm having mathematical background, I can explain more clearly about that. So let's go to the same area different perimeter. Okay. Same area different perimeter, here it is. So this is also a very interesting activity. Of course, every activity is interesting, but this is my favorite one because when I have tried this activity, I came to realize that okay, perimeters and areas can also be an interesting fact to discuss and have some graphical information from that. When we say graphical information, we can plot such type of activities instead of sheet on a graph paper, because graph paper have already segmented things and already there are some markings, so that can be used for the references. And of course, I think today is the best day to try this activity, newspaper activity. So you can go to our IISER Pune webpage and you can find this activity sequential photos, and today can be a very what we can say. Today we can try this activity actually on the occasion of Science Day, I think. So let me try with something new. So I would like to sorry for the technical errors, because I am switching between the two computers, so sometimes I go to the streaming software also and I am switching to the screen also, but I think we are back. Okay, so I'll just roam in this gallery. so that you are able to see all the glimpses we have here of all the activity sections. Okay, so you can also see some of the photographs here we have on this wall, that is celebrations of the special days. So we have celebrated Children's Day, Teachers Day. We also celebrate, and today also we have a National Science Day. So last year also we have celebrated this day, and there are you can see the crowd we have here. So because of this pandemic, we thought, okay, it's not possible, but we'll not miss the chance. And so we went to this concept called virtual gallery, and I hope you have liked this session. So if you have any comments on this, and if you want to make such type of gallery, you can just write in chat. We'll surely have some of the sessions to how to make this gallery. Okay, so in our coming sessions, we'll try to cover some of the things where we'll have some interaction where we can guide you to make such type of library or such type of galleries in your day-to-day presentation. Okay, so we have one of the comments show value of pi. So we'll use this guided thing and we'll go to the value of pi here again. Okay, yes. I'll just click on there. So value of pi. So let me brief you about this activity. It's really describes the 22 by 7 concept. So I'll leave you here, but you have to go to the sequential photos and figure it out how it works. I can assure you, you will enjoy this activity. So we'll move to the next section. Fine, but I don't want to leave from this hall. Okay, so I'll we'll move somewhere here. So this is another interesting activity made by one of our colleague, that is a folded inner membrane of mitochondria. So whenever the teachers try to say that, okay, you have many activities on physics, maths, but you rarely talk about the biology, and of course we have on chemistry also, but biology section is such a thing that teacher always try to get more and more hands-on activities on biology also. So please visit to our IISER Pune webpage. On outreach section, you can find sequentials and hands-on activities, also in a video and photographs. Both we have documented. So let me introduce to this section that reflects that we have celebrated Teachers Day, Children's Day, and hundreds of students and teachers and members of general public visited the centers on such type of occasions. So it is really fun to play this and to interact you in this unique way. So one last, I'll take one a big what I can say, big round of this hall, and then I'll conclude this virtual gallery section. Yes. So I hope you have enjoyed this activity, and if you have any comments or any suggestions, or if you want to make such type of interactive sessions for your students or for presentations, please let us know. We'll surely try to guide you to make such type of galleries. So let me have one big round of this gallery. We'll have a long way and then we'll conclude it. Okay. So yes. Yes. So I hope you have enjoyed this session, and I'll surely check the chat box after this interactive session, and of course our team is regularly moderating the chat box. So surely we'll try to incorporate all your suggestions in this. So let me end this virtual tour. So what I can do, I can go directly to the guided point and I'll exit from this gallery. Fine, so this is the end, but of course you have to fill the feedback form. So you have to go back and you have to fill the feedback form. I can go back to the starting help desk, and of course you had a feedback form here. So whenever you go, so please give your valuable suggestions to us. Thank you very much, and we'll switch to the next session, that's hands-on mathematics. Thank you very much.
Hello everyone, on behalf of IISER Pune and Science Activity Center, I welcome you all in this virtual National Science Day celebration. So in today's event, we'll be now looking at the hands-on way of exploring mathematics. So usually mathematics is looked at as a slightly boring subject in which you have to mug up a lot of formulas, or a lot of students find it very difficult because they have to just mug up formulas, write things like solve equations, solve puzzles, and that becomes slightly challenging. So in this session, we'll try to look at how we can make mathematics fun and explore it using games or small amount of puzzles that we can have at home. So since it's lockdown going on and we might, a lot of us are stuck at home since almost a year now, we are trying to see if we can use games and puzzles which are available at home to conduct some activities in mathematics. So one of these games which a lot of children might have been playing at home is Uno. So I'm sorry, I try to be in a multilingual mode. मैं थोड़ा सा हिंदी में बात करने की कोशिश करूँगा, थोड़ा सा मराठीत बोलायचा आपण प्रयत्न करूया, and as well as English might be the primary language that I will use for this session. So आपल्यापैकी बऱ्याचशा जणांना उनो हा गेम माहित असेल, आप में से बहुत के लोगों ने उनो गेम खेला रहेगा. So उनो ये जो गेम है, मैं आपको उसका एक छोटा सा वीडियो भी दिखाता हूँ कि उनो ये जो गेम है, तो उनो गेम में अगर आप देखोगे तो इस तरीके से अलग अलग तरीके के कार्ड्स होते हैं. इस उनो गेम में अगर आप देखोगे तो जो 4 तरीके के कार्ड्स आपको यहाँ पे दिखेंगे. ओके, सो यहाँ पर आप देख सकते हो कि ये जो उनो गेम है, सो उनो गेम में 4 अलग अलग तरीके के 4 अलग अलग कलर्स के कार्ड्स होते हैं, रेड, येलो, ग्रीन एंड ब्लू. इस उनो गेम में इन 4 कार्ड्स के अलावा और अलग अलग तरीके के कार्ड्स भी होते हैं. कई बार जिन्होंने ये गेम खेला रहेगा तो उसमें आपको पता रहेगा कि ये ड्रॉ 4, ड्रॉ 2 ऐसे टाइप के कार्ड्स होते हैं. इन कार्ड्स का हम इस्तेमाल अभी नहीं करने वाले, तो इसलिए हम इन कार्ड्स को अभी के लिए साइड में रख देते हैं. मेनली जो हमारे पास ये 4 कार्ड्स है, रेड, येलो, ग्रीन एंड ब्लू, इसमें भी अगर हम ठीक से देखें तो हर एक रंग के लिए हमारे पास 1 से लेके 9 तक के अंक होते हैं, या फिर 1 to 9 नंबर्स आर प्रेजेंट इन ईच कलर, एंड the 1 to 9 numbers are present twice. So 1 से लेके 9 तक हमारे पास अंक है या फिर numbers है, and these numbers are repeated twice. Apart from that, there is 1 0 in all of them. Same is the case with yellow, blue and green, that you will have these type of numbers 0 to 9 and another set of 1 to 9. Now what we can do with these is something which is very interesting. So let's just use one of these sets. For now we'll be just using the red set for doing these type of calculations. So if you have young children at home, which is very young children, they are just starting to learn numbers, what we can do is we can show them how to identify a particular number using the Uno card. So since the numbers are written on the Uno card, a parent or a teacher can show this card to children and ask them to identify what the particular number is. So 9 is 9. 9 is shown with an underline so that 9 and 6 is not confusing. So you can ask them to identify which number this is. So you can see that this is 9. Now this is 8, 7. So right now these are numbers in order, so you might find it very easy to identify. but you can just shuffle these numbers around and then show various cards like this is 9 again, 8, 6, 0, 5, 4, through. So you get the basic idea that you can just show random numbers to children and ask them to identify which particular number is in front of them. अभी अगर आप ये सोचोगे कि ये जो नंबर्स हमें हमारे सामने दिख रहे हैं, ये अलग अलग नंबर्स जो है वो इंग्लिश में लिखे हुए हैं, तो अगर आपको ऐसे ही ये नंबर्स हिंदी में बनाने तो आप एक पेपर पे वो नंबर लिख के उससे भी एक गेम खेल सकते हो. बट कई बार स्कूल्स में देवनागरी या फिर इंग्लिश में भी नंबर्स पढ़ाए जाते हैं. सो इस तरीके से हम इन नंबर्स का यूज करके बेसिक आइडेंटिफिकेशन ऑफ डिजिट्स हम अपने बच्चों को सिखा सकते हैं कि डिजिट्स या फिर 0 to 9 डिजिट आइडेंटिफाई कैसे करने हैं, और एक शफल्ड कार्ड में से उनको आइडेंटिफाई करके दिखा सकते हैं. अब दूसरा गेम जो हम इसके साथ खेल सकते हैं वो इस तरीका है कि अगर हम बच्चों को उसमें से यूनिट प्लेस, 10th प्लेस, 100 प्लेस सिखाना चाहते हैं, सो व्हाट वी कैन डू इज वी कैन चूज अ डिफरेंट कलर. मे बी यहाँ पर हम ग्रीन कलर ले सकते हैं या फिर दूसरा कोई कलर ले सकते हैं. और यहाँ पर हम क्या करते हैं कि ग्रीन कलर का जो 1 नंबर है उसको हमने अभी एक 10th प्लेस पे रख दिया है. अब ये 10th प्लेस कैसे पता है, तो अगर हम उसके बाजू में दूसरा कोई नंबर रखें, जैसे कि पहले हमने 1 रखा था या फिर अभी 3 रखा हुआ है, तो यहाँ पर हम देख सकते हैं कि अब जैसे हमने सिंगल डिजिट का आइडेंटिफिकेशन बच्चों को करने लगाया था, वैसे ही अभी अगर 10th प्लेस पे 1 नंबर रहेगा और यूनिट प्लेस के नंबर्स आप चेंज करते जाओगे तो आपको कौन से अलग अलग नंबर्स मिलते हैं वो हम यहाँ पर खेल सकते हैं. तो जैसे कि ये अभी हो गया हमारा 12, देन दिस इज 14, 15, 11, 17, 16, 13. So what I'm doing right now is supposed to be done by the kid or the student, that they are supposed to identify the numbers with 1 at the 10th place and various digits which are being switched at the units place. Now this is a very fun activity because even though we are learning this as a newcomer or as a new kid, we can know that when the units place is changing and the 10th place remains same, what are the various combination of numbers that we can identify. अलग अलग numbers हमें identify करना possible होता है. अब इसी तरीके से हम इस एक को यूनिट प्लेस पे स्विच कर सकते हैं और फिर 10th प्लेस पे हम अलग अलग नंबर्स रखते जाते हैं. जैसे कि जो पहले के नंबर्स है ना, दिस बिकम्स 81, 91, 71, 91 अगेन, 81, 61, just 1. So you get the idea that when you switch the unit place and 10th place, now you are actually changing the 10th place digit and you can identify what various numbers can be formed here. Now in this particular idea you can see that Uno can be used to identify 10th place, units place, 100th place also. So if I now shift this to 100th place and change the unit place or 10th place, you can form various numbers. So I can make this 155 or I can make 555. That 5 was ulta, sorry. So you can make 555. If you change any one of those digits, this becomes 455. You can change the digits on units place, 10th place or 100th place and form various numbers which the children are supposed to identify. Now why is Uno very interesting? I mean, you can just play this game by writing the numbers on cards, right? But Uno has these colors, so children also tend to identify colors better. So blue का 2 जो है वो अभी 10th place पे है, green का yellow, green का 4 जो है वो 100th place पे है. So these becomes identifying factor for them to identify numbers much better. Now you can also play very complicated games, as in because you have digits, you can give one colored stack to the child and you can keep the other color stack to yourself. So now you have 0 to 9 digits, your kid has 0 to 9 digits, and you can just identify a particular number, say 5. And what you can do is you can ask them that the procedure or the mathematical procedure we are doing is that of addition. So we want to identify numbers whose addition or whose sum will be 5. So from 0 to 9 you can identify these numbers, and here you can see that 0 and 5 ka addition will be 5. Same way if you get 3 and 2's addition, that will be 5. With 1 the number which we are looking for is 4, so 1 and 4 can get added to become 5. So in this way you can actually form various permutation combination of numbers whose addition turns out to be 5. Now obviously these are only 3 combinations which is possible, because beyond that, once you get to 6 or something, nothing can be added to 6 which will make it 5, and there is no -1 in Uno, right? So you can just use these as one of the combinations, and this you can ask the kid to replicate it for the first time. You can ask him to do it using the green cards, but you can also play it as a different game where say for example, instead of addition, now we are looking at subtraction. So subtraction is much more, you can have much more combinations. So let's say we take a smaller number 2 and we want to identify all combinations which will result into subtraction product, which is 2. So now we again start with basic digits, 4, 1, 4, 5, 0, and now we have 1 and 3. So 3 minus 1 will give you 2. Again, these are various combinations which are possible. So 4 minus 2 will give you 2. With 5, you have 3 once again. So 4 minus 2 will give you 2. 1 minus 3 minus 1 will also give you 2. 3 minus 1 is already done. 5 minus 3 will also give you 2. With 0, you might want another 2. So 2 and 0 will give you this 5. And another combination is 7 minus 5 will also give you 2. So here you can see that a lot of various permutation combinations can be made. 2 minus 0 is also 2. So in this way, what we can do is we can identify multiple combinations which will result into this product. And what I basically want to convey to you right now is using UNO as a mathematical tool is very exciting, because with a lot of different colors and with a lot of different permutation combinations that you can make using just 0 to 9 as digits, you can make various games with children. And I personally have played this game with my nephew during the lockdown, and he really enjoyed this way of learning numbers, because traditionally what we end up doing is we just ask children to write those numbers using a pen and paper or a pencil or पाटी पेन्सिल अशा गोष्टी वापरून आपण त्यांना हे नंबर शिकवायचा प्रयत्न करतो, आणि ते विद्यार्थ्यांना शिकताना बऱ्याचदा काही चैलेंजेस येतात, डिफिकल्टीज येतात. सो इस तरीके से अगर हम UNO कार्ड्स यूज करके उनको डिजिट्स का आइडेंटिफिकेशन सिखाए और ये नंबर सिखाए तो उनके लिए भी बहुत ज़्यादा एक्साइटिंग और चैलेंजिंग हो जाता है. The other game which a lot of you might have at home is actually that of Lego. तो जिनको लेगो पता है, तो लेगो ये जो होता है वो छोटे छोटे ब्लॉक्स होते हैं जो एक दूसरे के साथ लग जाते हैं और जिससे बच्चे घर बनाते हैं, अलग अलग तरीके की चीज़ें बनाते हैं. सो लेगो कम्स इन अ ब्लॉक ऑफ वेरियस साइज, एंड उसी के साथ साथ लेगो का एक बेस प्लेट आता है विच इज़ अ बिग प्लेट विच ऑन विच यू कैन फॉर्म वेरियस लेगो ब्लॉक्स और यू कैन ऐड वेरियस लेगो ब्लॉक्स. तो हम अभी देखते हैं कि लेगो जो है वो किस तरीके से एक मैथमेटिकल टूल की तरह यूज किया जा सकता है. सो दिस इज योर बेस प्लेट. As you can see here, this base plate actually has multiple number of dots. So यहाँ पर छोटे 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 dots है, and each of these dots are equally spaced from each other. They have equal distances with each other. And now these dots, you have these blocks which will fit on these dots. Okay, so like this is a block of 4 and which is a block of 2 by 2 actually. And you can see that this block nicely fits on this base plate. For this particular block, you can also see that because it has a very uniform shape, it is a square. It is a square having 4 unit areas if you want to count the area of this. It has a side which is of 2 unit length and another side which is of 2 unit length. So the area becomes 2 into 2, which is 4. Same way, you can have different kinds of blocks. So another common block that you find is that of 6. So this is 3 by 2. So this is a block which is of 6 units. And what, again, going by that same logic, you can see that this area of this block is 6 units. It's 3 by 2, and you can physically count those 6 dots. So the area can be estimated as 6 units. So basically we can use you can use Lego as an idea to identify basic geometry, introduce them to the concept of area. How do you calculate area? What is it actually that you are looking for? When you say the area of a rectangle is one side by another side or length into breadth. So here you can see that for the left side, which is a rectangle, you have 3 units on length and 2 units on breadth, and your area is actually multiplication of 3 into 2, which is 6, which you can also physically count here. Now you can add multiple blocks together, like I'm adding another block of 6 to the block of 6, and now this is a 4 by 3. So you can see here that on the length, which is bigger now, is 4 and this is 3. You can also add another block to the 4 by 4 block and you can make new shapes. So here you can see that now this becomes an additive problem, that if you have 2 rectangles and you are joining them together, what will be the area of the new rectangle? Many a times these type of problems are very difficult to visualize for children. With Lego and these uniform size blocks, we can visualize these very easily and see what is it that the area is being calculated. So for this example, just to give the answer, यहाँ पर हम देख सकते हैं कि 4 और 4 का 2 स्क्वायर अगर हम कंबाइन करें तो हमारा एरिया 8 हो जाता है. और अगर इसको हम एक फॉर्मूला की तरह भी काउंट करना चाहते हैं तो हम देख सकते हैं कि हमारा जो लेंथ है राइट साइड वाले का वो 4 है और ब्रेड्थ है वो 2 है, और जिसकी वजह से हमारा एरिया जो बन गया है वो 4 into 2 विच इज 8 हो गया है. लेफ्ट साइड वाले के लिए हम देख सकते हैं कि हमारा ब्रेड 3 है और लेंथ 4 है और हमारा एरिया जो है वो 4 into 3 मिला के हमारा एरिया फिर से 12 हो जाता है. And you can physically count those 12 dots also, so that you know that the areas that you are looking at or the calculations you have done are actually correct. And this is actually very important for children because उन्हें कई बार जो हम चीज़ें बताते हैं वो सिर्फ numbers में समझने में difficulty होती है, और इस तरीके से जब वो कोई प्रॉब्लम को विजुअलाइज कर पाते हैं या फिर सामने देख पाते हैं कि किस तरीके से ये शेप हमें दिख रहा है. When we say the area of a 3x2 rectangle will be 6, you can actually count those 6 units there and identify the area. इसी के लिए और एक तरीके का टॉय होता है जिसको हम जियो बोर्ड कहते हैं, एंड आप में से कई लोगों ने जियो बोर्ड देखा भी रहेगा. सो जियो बोर्ड इज यूजुअली मेड विद मल्टीपल नेल्स एंड यू कैन यूज रबर बैंड्स और अदर सच मटेरियल, थ्रेड यूज करके भी हम उसमें से यही चीज सिखा सकते हैं. बट जो कि इस बार लॉकडाउन में लोगों के पास लेगो जैसे टॉयज घर में होते हैं, तो हम लेगो का इस्तेमाल करके मैथमेटिक्स कैसे सीख सकते हैं ये अभी हम एक्सप्लोर करेंगे. The other thing that we can also check here is लेगो में हम ये देख सकते हैं कि अगर हमने एक बड़ा सा स्क्वायर बनाया लेगो में, तो यहाँ पर हम देख सकते हैं कि हमने यहाँ पर 4 लेगो ब्लॉक्स यूज करके एक बड़ा स्क्वायर बनाया हुआ है. एंड व्हाई आई एम सेइंग दिस इज अ बड़ा स्क्वायर इज बिकॉज दिस सेम स्क्वायर इज मेड ऑफ 4 स्क्वायर्स which are all of uniform size. So what we can explore using this is, if you see here जो separated square है, it is a square by itself and it is a square made of 4 units. So it's a 2 by 2 square, or it's a square of 2 which is resulting into 4 area or 4 units. Now if you take 4 such squares and combine them together, you actually get a bigger square, and that is a square of 4 which is of 16 units. So if you count here, you will have 4 into 4 which is 16. What we can explore using this is how powers of 2 work. So basically if you look here, this is the 16 which is 2 raised to 4. So you actually have taken 2 4 times, because one time you are taking it twice and another 4 times you are taking it. So ultimately you will get a bigger square which is of 16 units, which you can see here, and it's comprised of 4 equal squares of 4 units each. So this way we can have powers or multiple type of 2 raised to 2, 2 raised to 4, 2 raised to 8 can be taught to children using these numbers, and they can actually count them. On top of that, we can sometimes also have irregular areas which have to be calculated. So this is also very challenging for children. So for this, we have used this particular Lego idea, where calculating area of this blue rectangle is very easy. We can see that there are 1, 2, 3, 4, 5, 6 dots on the length, and 1, 2, 3, 4, 5 dots on the breadth. So this is a 6 by 5 rectangle, and the area of this will be 6 into 5, which is 30. And you can physically count those 30 dots. So you know that this is a shape, a regular shape of 30 unit area. But if I now form another shape, which is something like this, if you just consider the blue part, it is a very irregular shape with a small gap in between. There are protrusions, and calculating area of this shape is very difficult. So how do we calculate the area of this irregular shape is, at least for the sake of it, you can physically count the number of dots, and you will see that this also has the area which is equal to 30. So many a times children are taught how to calculate area of irregular shapes by either putting their hand on a graph paper and counting how many squares are actually overlapping with that hand shape that you have drawn. But in this particular example, why this is interesting is that this irregular shape that you see here can actually be organized or changed into a very regular shape, which is like this. So if you see here, this irregular shape is made of 3 blocks of 6 units, 1 block of 4 units, and 1 block of 8 units, which is the same here, that this is also made of 4 blocks of 1 block of 8 units, 1 block of 4 units, and 3 block of 6 units. And then this is where it becomes very evident that this is the same shape as what we are seeing here. And here we could calculate the area of this shape very easily. We know that this is a rectangle and this area is 30. So same way for this irregular shape also, the area will be 30. And why is this very important is because if I have to now show you another idea where I'll just take you this website that we have, which is called a digital repository of hands-on activities. And here if I go to mathematics activities, you will see that we have documented a lot of different activities here. These two activities, why area of circle is pi r square and why area of triangle is 1 by 2 base into height, is something that we can actually relate to the activity that we just saw. So as you can see here, that in this activity an circle is actually cut into multiple small pieces, and those of you who haven't actually seen this activity before, I highly encourage you to go on the digital repository and check out these activities. We have done extensive documentation on these activities on this site, which will be very useful to all of you. But the point I am trying to make here is what you are doing here is you are cutting this circle into many small pieces, and when you arrange these pieces along the length, you actually get a particular rectangle which is seen here, and the length of this rectangle is actually equal to circumference of the area, and the breadth of this rectangle is equal to the radius, and this actually gives us the formula of the area of circle, which is pi r square. So indirectly we are converting the circle into a rectangle and counting the area. Same way for the triangle also, if you see this activity of why area of triangle is half into base into height, you can see here that the triangle can be cut into two pieces. These two pieces can be arranged into a rectangle, and the area you will get is actually 1 by 2, because the height has become half, and base into height, which is the area of this particular small rectangle. So indirectly what we can show here is that once we find out how to calculate areas, finding out area of this irregular shape is just as easy as converting this irregular shape into a regular rectangle, and this process is actually called transformation. So in geometry, you have these transformations which allow you to calculate areas of various shapes, and this is simple process which can be explained using Lego blocks. So we are almost running out of time. I hope you like this idea of using games which are available at home, such as Uno or Lego, to explore mathematics, and this is just one of the ways of exploring hands-on mathematics. I will share the link of this digital repository in the description, where you can see these activities in detail, and I hope you like this idea of exploring mathematics using games. Stay tuned for further activities on this channel, and I'll see you later. Thank you. I just check whether the desktop audio is the one which is there, and if you are pulling up the right audio.
Yeah, good to go.
Okay, just mute everything else so that we don't have any interference from around. Okay.
Jai sir, ready?
Yeah, sure.
1 minute.
It's okay. थोड़ा सा एक Hello everyone. On behalf of IISER Pune and Science Activity Center, I welcome you all in this virtual National Science Professor Sunil Mukhi.
Sorry Chaitanya, sorry. Can you just repeat? Can you just repeat?
Sure. Starting से
Yeah.
go. Hello, hi everyone. This is Chaitanya again from Science Activity Center, and I welcome all of you for today's Virtual Science Day celebration. It's my absolute pleasure to introduce Professor Sunil Mukhi as first speaker in Meet the Scientist session. And this particular talk will be the title of the talk that we will be looking at right now. Sorry. Yeah, sorry. So, sorry, this is we are trying to do this live, right? So we are just coordinating with each other. So let me first introduce Professor Sunil Mukhi to all of you. Professor Sunil Mukhi is actually a theoretical physicist working at IISER Pune, and his area of work is actually string theory, quantum field theory, and particle physics. He's a professor at IISER Pune and also the dean of faculty here. As you can see on his wall, he's a avid music enthusiast and a very dynamic personality, and we all love him a lot at IISER Pune. So, without further ado, actually, since we will be running out of time very shortly, I'll just let Professor Sunil Mukhi take over, and if we have some questions on chat, we'll just discuss them towards the end of the session. Is that okay?
Okay, shall I start? Great. Thank you, Chaitanya, and welcome everyone. I must tell you that I am pretty excited because I see the audience of 925 right now. That's pretty much the largest audience I ever had in my life. I'm not a YouTuber, though I might be someday. And today I'm going to talk a little about the way theoretical science is done. To some extent, it is actually about the way all of science is done, but I'm a theorist and I don't want to presume more than what I actually know. So let me share my slides. I have a few slides and let me start right away. So the talk is called The Hows and Whys of Scientific Research. And let's jump in. So the person who has a person who has inspired me a lot in my life is Dr. Homi J. Bhabha, a great Indian scientist who founded TIFR, Tata Institute of Fundamental Research in Mumbai, where I worked for 28 years, and the Department of Atomic Energy as well. And he was a theoretical researcher in a rather exotic area called quantum electrodynamics. It's basically the quantum theory of electromagnetic forces. And I want to start a little bit talking about him and then go on to a few other scientists and try to weave a little thread for you about what people do, how things are done. Obviously, I can't go into too much detail in the available time of 15 to 20 minutes, but I'll give you some sketch and I'll be very happy to answer any questions you might have. Okay, so Bhabha, of course, you know, came from a wealthy Parsi family, and he was expected to work, you know, in the family business. They were associated with the Tatas. So he went to Cambridge really to be an engineer. But he wrote this interesting letter saying, I seriously say to you, this to his father, that business or a job as an engineer is not the thing for me. Physics is my line. I am burning with a desire to do physics. So, you know, if you are burning with a desire to do physics or even chemistry, biology, any kind of science, maybe you should print out this letter. I'm addressing the students here. Print out this letter and show it to your parents to convince them that this is the thing which you want to do. Here I have a picture of Homi Bhabha with Paul Dirac, a very legendary physicist and one of the real founding fathers of quantum theory. Now, one of his biographers said about Bhabha, his ultimate reference frame was nature herself, the objective reality out there. And this is really the theme of fundamental science, that there is nature, nature is objective, nature does what it does, and we have to understand it. Nature has not given us the key to understand what it's doing, to understand why stars shine, to understand why bodies fall, why the sun rises, why water freezes, so many interesting questions. It's up to us to try and understand it. But it's like a fair challenge because there is an objective reality out there. Now, what Bhabha did, and it was one of his main contributions in physics, and he did it really just around the time of being a PhD student or soon after, he calculated the rate of scattering of electrons and positrons using Dirac's theory of the electron. And I don't have the dates written here, but this was early 1940s or so, and Dirac's theory had just come, and then Bhabha did this calculation soon after. Fortunately, he was in Cambridge, so he had access to these results. And the process that Bhabha calculated is called Bhabha scattering. From Bhabha, I'll move on to someone much earlier and honestly much more famous, Albert Einstein, who in 1915 proposed the theory of general relativity. And this was his way of describing the force of gravity in a modern formulation, which agrees with experiment as we understand today. Now, Einstein, it's well known, used to think deeply about physics, but less well known, he also used to carry out difficult calculations. So, physics is not done just by thinking deeply. You also have to calculate and you have to make very precise statements. And Einstein realized that the force of gravity, so familiar to us, is a manifestation of the curvature of space and time, one of the surely most beautiful discoveries in the 20th century, and one which remains true and inspires us to this day. But he didn't just realize this thing. He wrote down equations called Einstein equations, which tell us exactly how to calculate this curvature in different situations. And here what happened is very interesting. Just a year after Einstein wrote his theory in 1915, 1 year later, Karl Schwarzschild found that there are some gravitating objects, objects with a gravitational pull, which is such that even light gets trapped in them. Quite a remarkable discovery. Actually, Schwarzschild didn't live very long after that. I think he went off to fight in a war and died there. So that's maybe an advice that try to avoid that if you're going to make a great scientific discovery. At least be around till you can see it really triumphing. Okay, and what did Schwarzschild find? He found some mathematical equations. That's all he found. But today these are called black holes. And we talk about them all the time. There are movies about them, there are experiments about them, there are simulations, there are artist conceptions like the picture I'm showing you. Now, what did actually Schwarzschild do? He took Einstein's equations, which is a set of coupled differential equations, very, very complicated ones. He made some physical simplifications and he found a solution. And basically one solution, and that's the Schwarzschild solution. To this day, the most general solution of Einstein equations is not even known. But he found the solution that made the difference. Here's another lesson about how research is done. It's not important to solve everything all at once, okay? If he had said, I'm going to solve Einstein equations in complete generality, he would have failed and everybody else has failed till now. He picked a particular physically motivated problem and he solved only that problem. And he basically wrote this one paper for which he's an absolute legend today. Now, after this work, 1916, remember, it was not clear if black holes were real or just some mathematical curiosities which he had written down. And for the next 50 years or 40 to 50 years, the situation remained essentially the same. Nobody was quite sure. Nobody was that interested. Only very few people were that interested. People were excited about many other things going on in sciences, in biology, in physics, in chemistry, but not this problem. There were some ideas, one of them from Fred Hoyle, about whom, by the way, ICER has made a very nice movie, and you should see it later, proposed that the newly discovered objects called quasars may actually be black holes. But people didn't take him all that seriously, except a few. Now, one of the people who probably did take him seriously was a young British mathematician called Roger Penrose, who in 1964 revisited the problem of formation of these objects that Schwarzschild had discovered. Now, Penrose, let me just tell you a few words about him. He was essentially a mathematician, and as you can see from this paper, which I think is his first paper, it's not really about physics at all. And this shows us that, you know, the research you do doesn't have to be narrowly in a particular discipline. I mean, Penrose succeeded in physics finally, also succeeded in mathematics, but this is where he started. And with his father, he developed something interesting. Have any of you seen this triangle? I don't know if I can actually get any feedback from you live, but you can tell me later. Take a look at this triangle and just I'll give you a few seconds to enjoy it while I drink my tea. So here's a triangle which is impossible. If you look at each of the angles, it makes perfect sense. But if you look at all the three angles of the triangle, it doesn't make any sense. This figure doesn't fit together. Okay, and it's a beautiful example of something we can draw which looks three-dimensional, but it doesn't actually exist in 3 dimensions. And on the right of this triangle, you'll see the Penrose staircase, which is also an impossible staircase, because if you look at it very closely, you will climb the steps. I don't know if you can see my cursor. I hope you can. This way coming, you'll be climbing the steps, then you'll be climbing the steps, then you'll be climbing the steps, then you'll be climbing the steps, and you're back where you started. Whoops. I didn't climb the steps. I clicked the steps by mistake. So here's a set of 4 staircases that when you climb all 4 of them, one after the other, you're back where you started. This can't be. So some trick or some illusion has been introduced here. But these are very beautiful illusions, and they're beautiful because they teach us something about drawing and about representations of reality. And this is a digression from my talk, by the way, but it's not a digression, because science is fun. That's one of the most important things, that science is fun. And Penrose, not only Penrose, but his father, they were having fun together. And all his work, he sort of saw it as a glorified extended form of having fun. Now, there's a Dutch artist called Escher, who you can Google about. And if you see, this is his painting with the same impossible staircase. And actually, Escher and Penrose exchanged information about these nice ideas. If you see Escher's staircase, it's going clockwise, unlike the one I drew earlier. People are climbing all the way and coming back to where they started. Other people are descending and coming back to where they started. So I hope you find this as cool as I do. This used to just thrill the life out of me. I see in my chat window, what are positrons? Okay, I'll come back to that. Let me do that at the end. Okay, I hope you had fun with this figure. It's not meant to be something very profound, but it excited me as a student in my 20s, and I suppose many of you are close to that age now. Coming back to what Penrose did in physics. He studied the behavior of objects that collapse under their own gravity. So things like stars, which are heavy, and they pull themselves in because everything inside is pulling on everything outside, and a collapse process starts. And what Penrose showed was that under suitable initial conditions, a mathematical object called a closed trapped surface can form. And once that forms, then the collapse of these objects is inevitable, and they will end up as black holes. And what he did thereby was to propel the idea of black hole from something that may occasionally, rarely happen, to something that happens all the time. Up there in the sky, in our universe, black holes are forming all the time, and this is the process, we believe. This weird diagram is lifted straight from Penrose's paper. You're not necessarily expected to understand it, but let me just say that time goes in the forward direction, upwards, and this circle is the black hole. We can't draw a spherical thing so easily because we are already drawing space and time. But imagine the black hole is like a circle. The circle is shrinking, shrinking, shrinking. At some point, it's become trapped according to his equations. And after that, the black hole forms, and this boundary is the horizon of the black hole, inside from inside which objects cannot escape. And right at the center of the black hole, there's something called a singularity of space and time, where space-time itself seems to break down. So black holes have a singularity at their core. They're very strange objects. People are still studying them very actively. And as I said, by no means I'm thinking that you're going to follow what Penrose did. In fact, most physicists cannot follow what Penrose did. It's very difficult, and it's a 3-page paper. He wrote longer papers later, but this paper, which is really the root of his contribution, is all of 3 pages long, and that figure is a part of it. So the text was maybe only 2.5 pages. Now, so the point is that he argued that after a certain time, collapse into a black hole becomes inevitable. Now, you might think that when he did this sensational work, people came running after him saying, Penrose, you're a genius, can we give you a Nobel Prize? No, that's not what happened. A lot of the physics community ignored him because there was no experimental evidence that was convincing enough that his theory is right. Okay. So, well, I don't know if he cared or he didn't care, but he continued working, and he worked with Stephen Hawking, and they joined forces in 1970 to give a general theory of these singularities, which applied not only to collapse, but also to cosmology. I have a separate talk on Hawking, which I think you can find on the net, and if not, I'll be happy to give it sometime in the future. Okay. Now, 50 to 55 years after Penrose's work is today. We are in 2021. His work was 1964. In this period, black holes have gone from being a mathematical curiosity to the most common objects in the universe. The universe is just full of black holes. There are at least 100 billion supermassive black holes in the universe, each having a mass of 1 million to 1 billion times the mass of the sun. There are also intermediate type black holes, which are of the order of solar mass or 10 times or 100 times solar mass, or a little more, 1,000 times, 10,000 times. So on all scales, there are black holes. And LIGO has even observed, as you probably know, through gravitational waves, has observed mergers. So this is a kind of artist's conception, two black holes circling each other, coming close, colliding, and forming a single black hole. And the masses here are like 50, 60 times the mass of the sun, each of them. Okay, so that's the lesson from Penrose's work. And these two people, Reinhard Genzel and Andrea Ghez, did the experimental research to find the supermassive black hole or evidence for it in our own galaxy. And this is the poster of the Nobel Prize in Physics 2020. So here's a little story I've spun, and let me now, in the last 2 minutes of my talk, say what I think are a few lessons to take away. First, theoretical research is done by first asking a physical question. That's very important. You can see that in the case of Einstein, in the case of Schwarzschild, in the case of Penrose, and also Bhabha, all the examples I've given. And by the way, also Ghez and Genzel, the other two Nobel laureates, all of them asked a physical question first. But none of them ended their research by asking a physical question. They did not lie in their bed and say, well, I think space-time could be self-reflecting, self-propagating, and green. You know, I'm using nonsense words. It's not just about words. It's about equations which have an actual meaning. So one must address the physical question through equations while being neither too rigorous, otherwise you'll never succeed, nor too vague, otherwise it doesn't mean anything. One has to do the following. This is my life since the last 40 years. Study, calculate, guess, calculate more, guess a little more, interpret the calculation, and then close the loop by studying again. This is how theoretical research works. Most great papers contain a small but important advance. Schwarzschild did not invent the theory of gravity. He added one solution to the theory of gravity, but it was a key addition. Bhabha did not discover the theory of positrons. Positrons are the antiparticle of electrons. They are positively charged particles which are otherwise like electrons. And Bhabha didn't propose them, he didn't discover them. He simply gave a formula how they scatter with electrons, what is the probability of that scattering, which can be measured in experiments. And you might say it's a small advance, but of course it's Bhabha scattering, and it's one of the most well-studied and measured and important processes in electromagnetism. And it confirms very, very deep and important facts about nature. Now, some luck is also needed. You can jump into theoretical physics and do great work, and nothing may come of it. So let me give you an example. Magnetic monopoles were predicted by Dirac, and a lot of people did both theoretical and experimental research on them, but to date, not a single one has been found. Doesn't mean they don't exist, but it's certainly true that we haven't found them. And so magnetic monopoles are not as famous as black holes. So there's a certain amount of luck. And here one point I'd like to make is that, well, we do research for the joy of it. We don't necessarily do research for being celebrated later on. Penrose, in his 80s, getting the Nobel Prize, I mean, probably he was happy. I'm sure he was happy, but it's not the motivation of his life. That is an important point to realize. Now, let me conclude by listing a few good qualities that help making a good scientist. In my experience, patience and persistence is one. Ability to think rationally is important, and self-confidence is important. And here I always tell young people, don't wait till you are successful to have self-confidence. First, believe in yourself, and then you will be successful. It works the other way from what you think. And then, of course, this can help you be a good scientist. If you want to be a very special scientist, there's something called imagination and intuition, and we have to allow it to flow. there's a joy in discovering new things. We have to feel it and we have to communicate it to others. And of course, it's a very it's a career which requires total commitment. It's very difficult to do science at a high level in a part-time way. Now, let me conclude with the words of Bhabha talking about science in India. And here he is in a picture with Pandit Jawaharlal Nehru, the first Prime Minister of India, and a very, very important person in making India the scientific country that it is today. Bhabha said, "It is the duty of people like us to stay in our own country and build up outstanding schools of research." And that's what he did. That's what I've tried to do, and my generation has tried to do. That's also what I hope you will do. And he says this too: no country which wishes to play a leading part in the world can afford to neglect pure or long term research. This is a very, very important statement that I'll advise you to think about. Okay, with that, I'm almost done. Let me just close with a little transparency of Nobel laureates from the Indian subcontinent. The Indian subcontinent for me includes undivided India. So what is today India, Pakistan, Bangladesh, and anywhere around the whole subcontinent is a large place. And let me just show you some faces. And I'm not going to tell you who they are. You're smart enough. You will figure out each one of them as I show you. And who's the last one? Well, there's a puzzle here because I don't know the answer, but I hope that it's you. So with this, I'm going to conclude this talk, and I'm happy to answer questions. Thank you very much.
Okay. Thank you very much, Professor Sunil Mukhi, for this wonderful talk. And we have shortlisted a few questions from the chat, which I'm pretty sure you will be able to tackle very easily. So I'll start with some of the most recurring question. There was a particular question which is slightly a misconception, I assume, is that people are asking that who gave a spark to the Big Bang. So I think the word Big Bang is causing the confusion. People think it was really an explosion of some sort. So if you can clarify what actually the Big Bang was and how you don't need anything like an intelligent design or anything to give a spark to a Big Bang. So
yeah.
You can tackle that.
So this is a good question.
Sir, I'm so sorry. Just a small request. If you can stop sharing the screen, the speakers will be visible. Right?
Sure, I'll do that.
Thank
Very
you.
good. Okay. So good. Who gave a spark to the Big Bang? So first, let me explain what is the Big Bang. It's a hypothesis that the universe started off as a point and started to expand. Now, it's very difficult to think what it means that the universe is a point, because what is outside that point? Okay, is there anybody looking at that point? No, the whole universe is in that point. Now, nobody seriously in science believes in points. A point is a very idealized thing. You can't make a point. If you make a point with a pencil, it will have a size of certain micrometers or millimeters. You can't just make a point, and nobody is saying it's really, really a point. We're simply saying the universe was very tiny. All of space and time itself was very tiny. And that happened at some initial time. Before that, the very concept of time didn't exist. People also ask what happened before the Big Bang. Well, there was nothing before the Big Bang, because time itself is part of space-time, and space-time started at the Big Bang. That's a very difficult thing to imagine, but that's the belief. And the reason we believe it is that if we look backwards at the universe, we find that it appears to be contracting in the past. And so we reason that, well, it may be coming together at some initial time. Of course, it need not do that. It might start to expand again. It might be some kind of bouncy thing which expands, contracts, and so on. These are all hypotheses. What we do know is that the universe was expanding and it is expanding. These are very important things. Okay. Whether it's exactly a Big Bang or not, these are matters of speculation. But in any case, the universe expands under the laws of physics. It doesn't need anybody else's intervention to expand. It's expanding now under the laws of physics. It was expanding then under the laws of physics. It just happened to be very small at one time.
So since we were talking about Big Bang, there was another question which is more like a popular science than actual science, I would assume. But people are asking, can you explain what is multiverse and your views on it actually?
Yeah, multiverse gets so much publicity, but it's a quite a speculative idea. But it comes from something about space-time. You see, if you agree that space-time is a manifold is difficult to define really. Um, um, a manifold of space is like any sort of space. So in that sense, the shape of this cup is a manifold. This manifold has a handle here. It has a certain geometry. It has a hollow inside. So, but now you have to imagine this mixed with time also. It's very hard to imagine. I can't imagine it. So I doubt that you can imagine it well. Anyway, this space-time, since it's a manifold, it can do things that manifolds do. For example, it can split off parts. So as time progresses into the future, part of space-time can go one way and part can go the other way. And these are not causally connected. That means from one you can never go to the other, even in principle, without going backward in time. And from one you cannot see the other because these are different universes. So these are all logical possibilities, but until we really understand what is observable about these kind of multiverses, we don't know what to say. Now, people speculate uh, with intelligence, it's not idle speculation, that the multiverse as a concept helps us understand our world. But our world, if at all, is only one part of the multiverse and we have no access to the rest of it.
So as a, I would say as a student in general also, are there any theoretical frameworks of research about multiverse? And if there are some names or some people that people should follow in order to get the scientific understanding of this concept, if you can share some names.
Okay. So I'll actually, shall I type a name here? You can read it out, or?
If you just type it on chat, I'll just put it, Zoom chat, I'll put it on the YouTube chat also.
Okay. This is a person who I knew well, but sadly passed away a few years ago, Joseph Polchinski. And he wrote some very good articles in defense of the multiverse. But I don't think there was, I don't know, right now I can't tell you the exact title, but it's something like In Defense of the Multiverse. And these were his views expressed at a conference on philosophy of physics. Mm-hmm. He actually sadly could not attend that conference because he had a brain tumor, and unfortunately that also cost him his life a few years later. But anyway, in the time that he had, he wrote up his thoughts on this, and you can certainly read them. But I would also advise students, this is the most exotic part of general relativity. You don't need to jump there. Don't think you'll get there without going through ordinary space-times, the general relativity of stars, of how ordinary stars, of black holes, which are already slightly exotic. Until you get through all this, you're not going to reach multiverse. It's only a word. Until you can write the formula of relativity, you can't talk about multiverse in a scientific way.
Yes. So there is a small request. There is a lot of chat which is asking for us to talk in other languages. So would you be okay talking slightly in Hindi?
Sorry, मेरी गलती हो गई. मैं सोच रहा था कि मैं बीच में हिंदी में बात करूंगा, लेकिन मैं actually बिल्कुल भूल गया. I really apologize.
And even when I'm trying to say that we'll talk in Hindi, मैं खुद ही फिर भी उसको इंग्लिश में बोल रहा हूँ. It is slightly difficult, I understand. पर हम एक काम करते हैं, एक लास्ट के जो 2 क्वेश्चंस है उसे हम हिंदी में आंसर करने की कोशिश करेंगे. दो जो एक मतलब I'm trying to combine a few questions here. 2-4 क्वेश्चंस ऐसे आए थे कि क्या वर्म होल्स को हम एक टेलीपोर्टेशन डिवाइस की तरह यूज कर सकते हैं. दैट्स अनदर पॉप साइंसी कांसेप्ट आई अज्यूम. इसी के साथ साथ और एक क्वेश्चन ये था कि हम ब्लैक होल्स में इतने इंटरेस्टेड क्यों है. व्हाई आर वी सो इंटरेस्टेड इन ब्लैक होल्स, एंड मे बी यू कैन कंबाइन फ्यू ऑफ दोस क्वेश्चंस. एंड अनदर क्वेश्चन which I think comes from Interstellar movie, that what actually happens when you fall in a black hole. तो अगर हम थोड़ा सा हिंदी और इंग्लिश मिक्स करके इनके आंसर कर सके, I think our viewers will be much more. मैं
हिंदी में ही आंसर करता हूँ, with the use of English words in between. लेकिन मैं वर्म होल्स के बारे में कुछ नहीं कहना चाहूँगा. जो मैंने मल्टीवर्स के बारे में कहा है वो वर्म होल्स के बारे में भी कहा जा सकता है कि ये बहुत स्पेकुलेटिव आइडियाज हैं, और ये एक्चुअली जनरल रिलेटिविटी के जो मेन कॉन्सेप्ट या मेन हार्ट ऑफ द सब्जेक्ट वो नहीं है. ये कुछ और है जो आप बाद में सीख सकते हैं. लेकिन जो किसी ने प्रश्न पूछा है कि ब्लैक होल्स क्या हैं, ये बहुत अच्छा प्रश्न है और इसके बारे में आपको पढ़ना चाहिए। ब्लैक होल्स तो आपको विकिपीडिया का पेज भी मिलेगा और बहुत सारे रिव्यू पेपर्स, आर्टिकल्स, मूवीज, यूट्यूब वीडियोस वगैरह मिलेंगे। लेकिन मैं यहाँ इतना बताऊंगा कि ब्लैक होल ऐसा ऑब्जेक्ट है कि आप एक बात सोचिए कि हम पृथ्वी पे रहते हैं, तो पृथ्वी का, अर्थ का एक मास होता है, टोटल मास जितना भी है। अभी आप उतने मास को अगर आप छोटे साइज में कंप्रेस करोगे, बहुत छोटे साइज में, पूरा जितना अर्थ का टोटल मास जो है, अगर आप 1-2 इंच क्यूबिक इंच के अंदर कंप्रेस कर सकते हो, तो वो ब्लैक होल बन जाएगी। और उससे क्या होगा कि इस मास के बाहर एक होराइजन पैदा होगा, अपने आप आ जाएगा, लॉज ऑफ फिजिक्स के द्वारा आ जाएगा। और वो होराइजन ऐसा होगा कि अगर कोई भी ऑब्जेक्ट या लाइट रे या कोई भी ऑब्जेक्ट अंदर गया, तो वो अंदर से बाहर वापस नहीं आ सकता है। तो उसको ब्लैक होल कहते हैं, क्योंकि नॉर्मल ऑब्जेक्ट्स, अगर आप मून पे लाइट शाइन करते हो तो वो लाइट रिफ्लेक्ट होती है, और अगर लाइट अंदर भी जाती है तो वो रिएक्शंस, अंदर जो रिएक्शंस होते हैं स्टार्स में फॉर एग्जांपल, उनके द्वारा लाइट बाहर भी आती है। तो सन से लाइट बाहर आती है। एक्चुअली मून से भी रेडिएशन बाहर आता है, लेकिन वो बहुत लो लेवल रेडिएशन है। जैसे आप जानते होंगे कि अर्थ शाइन नहीं करता है, लेकिन वो रेडिएट करता है, क्योंकि जो हीट दिन में अर्थ में दिन मतलब ड्यूरिंग डे टाइम जो अर्थ में हीट अब्सॉर्ब होती है, वो रात को फिर रेडिएट होती है ना। तो ये सब ब्लैक होल में नहीं होता है। जो अंदर जाता है वो बाहर नहीं आ सकता, इसको ब्लैक कहते हैं। अभी स्टीफन हॉकिंग ने इसको 2 चैलेंजेस दिए। एक्चुअली एक मेन चैलेंज दिया कि अगर ये ब्लैक है तो आप कोई भी इंफॉर्मेशन अंदर फेंक सकते हैं और वो इंफॉर्मेशन हमेशा के लिए चला जाएगा। तो टोटल अमाउंट ऑफ इंफॉर्मेशन इन द यूनिवर्स वो कम हो सकता है, और वो सेकेंड लॉ ऑफ थर्मोडायनामिक्स को वायलेट करता है, क्योंकि इंफॉर्मेशन जो हम कहते हैं वो, उसका दूसरा वर्ड है एंट्रोपी। तो एंट्रोपी, यूनिवर्स का एंट्रोपी कभी कम नहीं हो सकता है, और ब्लैक होल द्वारा हम एंट्रोपी कम कर सकते हैं, इंफॉर्मेशन कम कर सकते हैं, बाय थ्रोइंग इट इनसाइड, जहां से वो कभी बाहर नहीं आएगा। तो दिस इज व्हाई ब्लैक होल्स आर एक्साइटिंग, बिकॉज इट लुक्स लाइक दिस इज द सिचुएशन विच विल ब्रेक द लॉज ऑफ फिजिक्स। लेकिन अभी पिछले 10, 15, 20 साल का जो रिसर्च हुआ है, उसमें हम अभी उसके द्वारा हम अभी सोचते हैं कि ऐसा नहीं है। ब्लैक होल्स एग्जैक्टली ब्लैक नहीं है। एक्चुअली हॉकिंग ने इसका हिंट भी दिया था कि ब्लैक होल्स एग्जैक्टली ब्लैक नहीं है, वो रेडिएट करते हैं, लेकिन एक स्पेशल तरीके से, और वो रेडिएशन, उसको हॉकिंग रेडिएशन कहा जाता है। लेकिन इट्स वेरी वेरी हार्ड टू डिटेक्ट हॉकिंग रेडिएशन, बिकॉज इट्स अ वेरी लो टेम्परेचर रेडिएशन which we cannot see in practice. So these are the challenges to understand these objects. They are much more interesting and exotic compared with ordinary stars, planets, comets, and all the other astrophysical objects.
Okay. I know we are really sorry. I'm actually looking at the chat where there are continuously questions popping, and it might we are really sorry to our viewers that we may not be able to answer a lot of your questions. It's almost 11:30 and we'll be running out of time. So I think I'll just take one last question from the chat, which we haven't really tackled, and maybe this will also give you a chance to talk about how actually research is being done, because a lot of people are interested in knowing how people become scientists, what is it that you do, how do you become a mathematician, and maybe you can use the one of the topics that you work on really well, which is also a theoretical topic of what is string theory, to use this as an example to explain what it means to be actually a scientist, and how do people go about finding answers to questions which are not really have much answers.
Okay, but for this you have to tell me how much time I have, because in 1 minute I cannot tell you what is.
No. Maybe you can take another 4 or 5 minutes to answer.
4 or 5 minutes
This might be last question. So the floor is all yours, and we'll just move to the next session after this.
Okay.
Again, हम थोड़ी सी mixed language का use करेंगे ताकि सभी viewers को इसका फायदा हो सके.
ठीक है। तो स्ट्रिंग थ्योरी समझने के लिए पहले आप ये सोचे कि यूनिवर्स में बेसिक बिल्डिंग ब्लॉक्स क्या हैं। देखिए, जैसे कि जितने ऑब्जेक्ट्स हैं, जितना मैटर है, जितना रेडिएशन है, व्हाट इज इट ऑल मेड अप ऑफ, एंड द आंसर इज एलिमेंट्री पार्टिकल्स। आई थिंक 12 बजे एक टॉक पे एलिमेंट्री पार्टिकल्स पे टॉक भी होने वाला है, अरुण तलपिल, आई सॉ ऑन द प्रोग्राम। तो एलिमेंट्री पार्टिकल्स आर द बिल्डिंग ब्लॉक्स ऑफ एवरीथिंग, And there are only few, maybe 20, 30 types of elementary particles. They make up all of matter. Now, one question, एक प्रश्न जो लोग बहुत साल से पूछ रहे हैं कि इतने सारे elementary particles क्यों हैं? This is one question. Now, there's another question of quantum gravity. So, gravity is a basic force of nature. और नेचर में और भी तीन बेसिक फोर्सेस हैं जिसे हम कहते हैं इलेक्ट्रोमैग्नेटिक फोर्स, वीक न्यूक्लियर फोर्स एंड स्ट्रॉन्ग न्यूक्लियर फोर्स, थ्री फोर्सेस प्लस ग्रेविटी. अभी क्वांटम मैकेनिक्स ये कहता है कि universe is not described by classical physics, it is described by quantum physics with wave function, uncertainty, probability वगैरह वगैरह. You know that quantum mechanics के बारे में आपने जरूर सुना होगा. लेकिन क्वांटम ग्रेविटी के बारे में कोई बात नहीं करता है. क्यों? क्योंकि क्वांटम ग्रेविटी के जो एक्सपेरिमेंट्स हैं, जो क्वांटम इफेक्ट्स ग्रेविटी में देख सके, वो एक्सपेरिमेंट्स आज तक फिजिबल नहीं है. मैंने बार बार कहा है कि जो आज तक फिजिबल नहीं है वो फ्यूचर में जरूर फिजिबल होना चाहिए. जैसे कि ग्रेविटेशनल वेव एक्सपेरिमेंट्स भी until few years ago फिजिबल नहीं थे, और 1960s, 70s, 80s में लोग कहते थे कि ये कभी नहीं होने वाले हैं, लेकिन हो रहे हैं. In the same way, quantum gravity experiments are in the future. They are not in present. You cannot see them now, you cannot do them now, but someday they will come. But what is the theory? Abhi, in the process of making this theory, people have got stuck. It's very, very difficult to make a theory of quantum gravity. Iska main explanation nahi de sakta hu because it's a problem of equations. Unless you understand the equations, you cannot understand where we are stuck, but we are stuck. ठीक है. So two problems. One, many elementary particles in nature. Two, difficult to make theory of quantum gravity. Now, people found in 1970s and 80s that instead of elementary particle, if we try to make quantum theory of a string, which is slightly extended, still very small, very, very, very small, but slightly extended, like one dimensional, like a little wiggly thing or a circular thing, closed loop or open, both. People found two things. One, that the quantum theory of that is not difficult to make. It's possible to make quantum theory of strings. Okay, very good. Second thing, that theory contains gravitational force automatically. We don't have to put it in by hand, but the quantum theory of closed strings, loop-like strings, automatically is a quantum theory of gravity. And if you consider one string and different vibrations of it, just like musical string, usme sa, re, ga, ma, pa, alag notes bahar aate hain. So that one string, if you excite in different ways, it can behave like different elementary particles, like electron, positron, quark, photon, neutrino, like that. Now, these are all ideas, and as I told you, every idea should have good equations, and these have good equations. String theory is understood well at the level of equations, but it describes an idealized world which is not exactly similar to the world we live in. So there is still some problem in completing that program of string theory to match it with the world that we live in, but it addresses these two questions. Why are there so many particles? Maybe they are excitations of one type of string. Two, that quantum gravity is difficult to write. Maybe it is actually quantum string theory, which is actually easier. So these are the two main reasons. So I think I'm done now.
No, that's okay. So it's very wonderful to listen to like experts in the field talk about those things. But I'm really sorry, we are almost running out of time. One thing I would like to address to all of our viewers on YouTube is you are asking really wonderful questions, and there is a link given which is a pinned comment on YouTube right now. You can submit your questions on that link, and we will try our best to answer them either in future sessions or whenever we have further experts in the field, we will ask them to answer these questions for you. And with that, I would like to thank Professor Sunil Mukhi for his time on Sunday and enjoying Science Day with us. And it was very nice to listen to you about the whole topic that you have explained. It is our pleasure to have you, sir. And we'll just take it.
Thank you, Chaitanya, and thank you to the whole audience. You know, some of us are reaching the end of our career, and we are like me, not like other people here. But you know, we are looking forward that when we retire, we should be happy that science is in good hands. And seeing your hundreds, thousands of comments in the YouTube chat box, which I could not answer all of them, I feel really inspired. So thank you, students. You have made us feel that it's worth our effort, what we have done. And please take it over, please take it forward, and please solve all the problems which we could not solve. Thank you. Okay, can I leave? Shall I leave?
Hello, I am Pradnya from Science Activity Center, IISER Pune.
Hello, I am Neha, wishing you a very, very happy National Science Day.
On this occasion, I introduce you a person who has made lots of interesting toys by trash material, K.V. Poddar sir. K.V. Poddar sir is a mechanical engineer by profession and worked in Teklo for 30 years. After his retirement, he pursued his passion to make the toys, or you can say science toys or crafts. He has designed many toys from trash material, which are documented in special category by his name on website arvindguptatoys.com. He participated in various science exhibitions for many years. Presently, he is associated in various activities with IISER Pune. Let's look at some toys designed by Sir. Here is our first one, a grinding model, which is used to grind our grains or spices. In many years ago, these type of chakki are used to grind grains at home by ladies with lovely song. So, it is very cultural toy. Also, you can start thinking science behind that. Basically, towards the machine. There is a wheel and axle. Here is our next one, that is a moving footwear. Just look at the simplicity and creativity in this toy. how crank is used to move footwear to and fro. Interesting, no? Now here is box, and this cut in such a way that it shows the rigidity. Just press and leave it immediately. Can you guess science behind it? Can you relate this toy with conversion of energies? Think on that. Move on to the next toy. In this toy, there is a fan which is made by some thick plastic sheet and a spoke it attached with a ring magnet. Also, there is a star shape which is made up of the spoke. Now, just blow the fan and observe the movement of a star shape. It's so interesting. What do you think? Why this is happening? You can also make a different shape and observe it. Now, here is the next one, fun with 9 cubes. These 9 similar cubes are connected in such a way that if you can twist a diagonal cube, you can find the movement of all cubes, like they are dancing. It's fun, no? Now, there is a next one. Oh, it's a wire lizard. Just observe the movement of legs. It's so cool and amazing. For this, you have to move just a crank and all 4 legs starts moving. Here is the next one, rope jumping man. Just move that crank and the man will jump. It's such an amazing toy. Now here is the next one. Can you observe the material? There is a plastic box. There is a pencil, a fan made of plastic material, and the ring magnet. Can you guess where is the pole of ring magnets? Ring magnets having their pole on the sides. So on the edges there is a very low magnetic strength. Taking this advantage of the magnets, the fan is rotating so fast. Now there is a next one, a snake puppet. Observe the movement. Can you think a science behind this? There is a change in a motions, basically change in a linear motion to curvilinear motion. Also, observe the tongue of the snake. Tongue of a snake does not change their motion. Here is the next one, that is a flicker ball. For this, very simple material used, ball, plastic cup and a stick. From this, can you relate any Newton's laws? Think on that. Now, here are a man made up of wire, and this wireman cutting the wood. How? The wireman connected to the crank. While moving the crank, there is a movement of up and down. So that's why it looks like a wireman cutting a wood. Now here is a two wireman. Observe the movement of the wireman. And here is a boxman. For making of the boxman, using such a trash box and some foam strips are used. This boxman can walk also. Look at his movement. Isn't it fun to see such a beautiful toys made from trash which is having a huge hidden science in it?
Let's take a look at this wireman. Observe the bolts that are hanging on its legs. If you balance this wireman on your finger.
Hello, I am Pradnya from Science Activity Center, ISER Pune.
Hello, I am Neha, wishing you a very, very happy National Science Day.
On this occasion, I introduce you a person who has made lots of interesting toys by trash material, K.V. Poddar sir. K.V. Poddar sir is a mechanical engineer by profession and worked in Teklo for 30 years. After his retirement. Hello, I am Pradnya from Science Activity Center, ISER Pune.
Hello, I am Neha, wishing you a very, very happy National Science Day.
On this occasion, I
Hello, we are coming back now. We are coming back and just I am continuing the dynamic toys from trash. मैं आपको कुछ अच्छी चीज़ें दिखाऊंगा. इन अर्लियर फिल्म थोड़ा सा टेक्निकल जो प्रॉब्लम आ गया था ना, so we are solving that problem. But I would like to show you very interesting toys that you can do in your home. अभी देखिए मेरे हाथ में जो चीज़ है ना, this is very simple. आपको शायद आपको पता भी चला होगा. And what is that? These are the threads from the cement bag. ये cement bag के threads है. अभी मैं क्या करूंगा, अब इसके ऊपर देखिए बिल्कुल ये नजदीक है. There is a no any charge over here. अभी चार्ज है या नहीं कैसा पता चलेगा, तो थोड़ा सा वो यदि फैला जाते हैं, दूर जाते हैं, then you'll get the idea कि उसमें कुछ चार्ज है. अब ये बहुत नजदीक है, मतलब इसके ऊपर there is a no any charge. अभी मैं क्या करूंगा, जस्ट विथ हेल्प ऑफ माई हैंड इसे थोड़ा सा ऐसा रब करूंगा. 2-3 बार किया तो भी चलेगा. अभी लुक हियर ना, जस्ट 1 2 3. अभी देखिए इसमें कितना चार्ज आ गए. अब ये सेपरेट हो गए, बिल्कुल सेपरेट हो गए. और एक बार दिखाता हूं मैं आपको. देखिए बीच में भी जो है वो अभी सेपरेट हो गए. तो बेसिकली आई एम शोइंग यू द स्टैटिक इलेक्ट्रिसिटी. दिस इज अ वेरी इंटरेस्टिंग एक्चुअली एक्टिविटी टू एक्सप्लेन द स्टैटिक इलेक्ट्रिसिटी. और स्टैटिक क्या होता है, सी द मीनिंग. स्टैटिक मतलब जगह पे रहने वाला. और स्टैटिक बेसिकली चार्ज, अभी मैं बोलूंगा इसके ऊपर. एंड अल्टीमेटली जैसा हम इलेक्ट्रिसिटी बोलते हैं ना, दिस इज बेसिकली फ्लो ऑफ द इलेक्ट्रॉन. अब इसके बारे में क्या हो रहा है कि इफ आई रब ऑल द थ्रेड्स लाइक दिस एंड दे आर सेपरेटिंग, मींस ये जो धागे बन रहे हैं, ये जो धागे बने हैं कुछ एटम्स के होंगे, बराबर है. इफ यू सी द पिक्चर ऑफ द एटम, आपको मालूम है सेंटर में क्या होगा, एटम के प्रोटॉन है जो पॉजिटिव चार्ज होता है, न्यूट्रॉन है जहां कोई चार्ज नहीं है, और वो इलेक्ट्रॉन भी है. और इलेक्ट्रॉन क्या होते हैं, निगेटिव चार्ज होता है उसके ऊपर. तो यदि अभी ये बिल्कुल ऐसा नजदीक है, मतलब दिस इज अ न्यूट्रल मटेरियल, उसके ऊपर जितना पॉजिटिव चार्ज है मतलब जितने प्रोटॉन हैं, उतना ही निगेटिव चार्ज है मतलब उतने ही इलेक्ट्रॉन हैं. तो ये अभी न्यूट्रल है. न्यूट्रल मतलब नो पॉजिटिव चार्ज नो निगेटिव चार्ज, दोनों का भी संख्या प्रोटॉन इलेक्ट्रॉन का सेम. अभी मैं क्या करूंगा, जब इसे मैं रब करता हूं तो ये दूर क्यों जाते हैं, तो जो इलेक्ट्रॉन्स होते हैं ना उसका थोड़ा जाना होता है, नहीं तो आना होता है. मतलब मेरे हाथ से कोई इलेक्ट्रॉन यहां जाने का चांस है ड्यू टू रबिंग, और यहां के इलेक्ट्रॉन मेरे हाथ के ऊपर आने का चांस है. तो बेसिकली दैट्स क्रिएट द चार्ज. मतलब चार्ज कैसा पैदा होता है, एक तो इलेक्ट्रॉन जाएंगे नहीं तो आएंगे. जहां जाएंगे दैट इज अ नेगेटिव चार्ज बिकॉज दिस इज चार्ज ऑफ द इलेक्ट्रॉन, और जहां से गए वहां देयर इज एक्चुअली डेफिशिएंसी, कम है इलेक्ट्रॉन, एंड दैट इज बेसिकली पॉजिटिव चार्ज. मतलब वहां जो होगा वहां प्रोटॉन की संख्या ज्यादा होगी. तो ये सेपरेट क्यों हो रहे हैं अभी इसमें देखिए आपको पता चलेगा ये सेपरेटेड है ड्यू टू देयर इज अ रिपल्शन बिटवीन टू सेम चार्जेस, आइदर पॉजिटिव एंड नेगेटिव. चाहे चार्ज कौन सा भी होने दो, देयर इज ऑलवेज रिपल्शन बिटवीन द टू सेम चार्जेस. मैं बोल रहा हूं अभी ये देखिए मेरे हाथ पे चिपक गए, मतलब क्या है, देयर इज अट्रैक्शन नाउ बिटवीन माय हैंड एंड द थ्रेड्स, प्लास्टिक थ्रेड्स. दीज आर द थ्रेड्स फ्रॉम, एज आई मेंशन यू, फ्रॉम द ओवन बैग या सीमेंट बैग. हम जो डेली लाइफ में फर्टिलाइजर का भी बैग ऐसा ही होता है. तो अभी ये दोनों में अट्रैक्शन है, इसलिए वो चिपक गए मेरे हाथ को, बिल्कुल वो चिपक गए. सो आई एम जस्ट शोइंग यू द अट्रैक्शन बिटवीन टू अपोजिट चार्जेस ओवर हियर. और यहां देखिए थोड़ा अभी देखिए चार्ज पैदा करता हूं फिर एक बार, तो अभी सेपरेशन है क्योंकि रिपल्शन बिटवीन टू सेम चार्जेस, पॉजिटिव या निगेटिव. कितनी मजे की चीज है. और उसके लिए आपको क्या चाहिए, जस्ट थ्रेड्स फ्रॉम द सीमेंट बैग. अभी और एक चीज मैं आपको बहुत इंटरेस्टिंग दिखाता हूं, और ये जो एक्सपेरिमेंट है आप घर से देखिए, जो तुम्हारे आजू बाजू में मटेरियल है ना उससे कर सकते हैं. सो दिस इज द मैसेज ऑफ टुडेज साइंस डे, कि हमारे आजू बाजू में देखिए साइंस तो बिल्कुल हमारे आजू बाजू में. नेचर इज एक्चुअली बिग लैबोरेटरी फॉर अस, होम इज अ बिग लैबोरेटरी फॉर अस, किचन इज अ वेरी इंटरेस्टिंग लैबोरेटरी फॉर अस. तो अभी और एक दो चीजें मैं आपको दिखाता हूं. तो ये क्या है, मेरे हाथ में एक बलून है. बलून से बच्चे हमेशा खेलते हैं. देखिए एक सिंपल एक्टिविटी मैं आपको दिखाता हूं, बाद में भी आप कर सकते हैं. आपके पास कुछ रबर बैंड हो, कुछ रबर का कौन सा भी टुकड़ा हो, साइकिल का जो ट्यूब होता है ना उसका छोटा पीस हो तो भी चलेगा. अभी मेरे पास ये बलून है. अभी मैं क्या करूंगा, ये बलून का टेम्परेचर थोड़ा सा फील करूंगा. तो क्या करूंगा, बलून यहां मैं टच करता हूं. और आई एम फीलिंग द टेम्परेचर ऑफ द बलून। अभी जितना है मैं ध्यान में रखूंगा और उसके बाद क्या करूंगा, बलून को क्या करूंगा, व्हाट आई विल डू, जस्ट 2-4 बार ऐसा ऐसा करना है, देखिए 2-4 बार। अब देखिए ओ इट्स वेरी वेरी हॉट, वार्म हो रहा है, मतलब गर्म हो रहा है। ये क्यों गर्म हो गया? ऑफकोर्स देयर इज अ मूवमेंट इनसाइड द, जो कुछ जो बना है, और बेसिक कंपोनेंट क्या है, एटम से बना होगा, तो उसमें देयर इज अ लॉट ऑफ मूवमेंट ऑफ द एटम्स इनसाइड दिस मटेरियल या बलून। और वो जितना ऐसा उसको मूवमेंट होगा, वाइब्रेशन होगा इसके अंदर, तो क्या होगा, दैट्स क्रिएट द हीट। अभी मुझे ऐसा ठंडा लग रहा है, लेकिन 2-4 बार ऐसा करने के बाद मुझे अभी गर्म लग रहा है। एक तो एक एक्टिविटी ये कर सकते हैं बलून से। एंड देयर इज अनदर वेरी वेरी इंटरेस्टिंग एक्टिविटी व्हाट यू कैन डू विद द बलून। अभी देखिए मैं उसको हवा, उसमें हवा लेता हूं, अभी ये इनफ्लेट हो गया, और मैं थर्मोकोल की जो बॉल्स है मेरे पास, बहुत लाइटर मटेरियल जो है ना, मैं लेता हूं नजदीक। अभी देखिए मेरे पास खाली बलून और थर्मोकोल के बॉल में लेता हूं। अभी पहले तो ये देखो, ये मेरे हाथ को चिपकता है या नहीं? अरे नहीं चिपकता, देखिए कुछ नहीं हो रहा। अभी देखिए बलून इज एक्चुअली फॉलिंग, ये नीचे जा रहा है। अभी इसको थोड़ा सा मैं फ्रिक्शन क्रिएट करता हूं। एक तो आपके पास स्वेटर हो तो स्वेटर के ऊपर या ऊल के ऊपर फ्रिक्शन कर सकते हैं, ऐसा 2-4 बार कर सकते हैं। नहीं तो दूसरा क्या, बस अपने बाल के ऊपर 2-4 बार ऐसा फ्रिक्शन क्रिएट करो। देखिए बाल के ऊपर, अभी मेरा बाल का भी देखिए मजा, थोड़ा उठ रहे हैं देखिए, तो मतलब दोनों में अट्रैक्शन हो रहा है। अभी ये तो हो गया, लेकिन देखिए ये मेरे हाथ को भी चिपक जाएगा। अभी देयर इज नो एनी ग्लू, तो क्या हो रहा है कि ये बलून और मेरा हैंड जो है, दोनों में अट्रैक्शन, मींस देयर मस्ट बी, यह पॉजिटिव है तो यह नेगेटिव, और अदर वे अराउंड, मतलब 2 चार्जेस है, एक पॉजिटिव होगा तो दूसरा, और बाद में देखिए गिर जाता है, मतलब वो दीज आर द टेम्पररी चार्जेस। और वो जगह पे जहां फ्रिक्शन हो रहा है ना, वही जगह पे वो बन रहे हैं, अदर साइड पे नहीं हो जाएंगे फिर वो। सो दिस इज वेरी वेरी इंटरेस्टिंग एक्टिविटी यू कैन डू विद द बलून। और एक मैं चीज आपको दिखाता हूं, आई हैव हियर सम थर्मोकोल्स बॉल। अभी देखिए थोड़ा सा मैंने यहां फ्रिक्शन किया था, तो देखता हूं क्या हो रहा है यहां। अभी देखिए हल्का सा कुछ हलचल दिखाई पड़ रही, देखिए। लेकिन इफ आई क्रिएट मोर फ्रिक्शन, मतलब ज्यादा मैं इलेक्ट्रिसिटी यहां पैदा कर रहा हूं, एंड दैट इज स्टैटिक। मैं कभी कभी इलेक्ट्रिसिटी शब्द भी इस्तेमाल कर रहा हूं, कभी कभी चार्ज भी इस्तेमाल कर रहा हूं। तो बेसिकली दैट ये कैसा बन रहा है ये तो आपको पता चला, क्योंकि इलेक्ट्रॉन का मूवमेंट होगा, जाएंगे नहीं तो आएंगे ड्यू टू द फ्रिक्शन। एंड द फ्लो ऑफ द इलेक्ट्रॉन को नॉर्मली हम इलेक्ट्रिसिटी बोलते हैं, और यहां जो वो है वो एक जगह पे तैयार होगा, एंड दैट इज व्हाई इट इज अ स्टैटिक इलेक्ट्रिसिटी, और कॉमन लैंग्वेज में हम उसे स्टैटिक चार्ज बोलते हैं। अभी देखिए यहां मैं फ्रिक्शन पैदा कर रहा हूं, और अभी देखिए यहां जो थर्मोकोल के बॉल है आपको शायद दिखाई पड़ेंगे, यहां मैं ऐसा पकड़ रहा हूं, अभी देखिए सी देयर इज अ लॉट ऑफ अट्रैक्शन ओवर देयर। मजा आ गया ना आपको, इतना अट्रैक्शन हो रहा है, देखिए कितना अट्रैक्शन, इतने बॉल वो चिपक गए, मींस you have created very nice actually this charge, and this type of the activity जो होते हैं ना, ये नॉर्मल है कोल्ड सीजन में ज्यादा अच्छे होते हैं, ड्राई सीजन में, और स्पेशली हमारे देश में लगभग नवंबर से फरवरी तक होते हैं, क्योंकि वो थोड़ा सा ड्राई सीजन होता है, बाद में समर हो जाता है। और ये जो है रेनी सीजन में इस टाइप के एक्टिविटी बिल्कुल नहीं होते रेनी सीजन में, क्योंकि वो जो चार्ज बनेगा इमीडिएटली वो डेसिपेट हो जाएगा। तो ये एक बात है। और दूसरा, आपको और इंटरेस्टिंग चीजें करना है तो क्या कर सकते हैं, एक ऐसा पीवीसी पाइप ले लो, और वो स्वेटर तो मेरे पास है। अभी ये पीवीसी पाइप को मैं क्या कर रहा हूं, थर्मोकोल के बॉल के नजदीक ले रहा हूं। देखिए मैं अभी क्या करता हूं, ये थर्मोकोल के जो बॉल है, फिर एक बार इसके नजदीक पाइप लेता हूं, देखिए इसमें कुछ नहीं अभी। एंड देन व्हाट आई एम डूइंग ना, अभी मैं क्या कर रहा हूं, इसको 2-4 बार ऐसा फ्रिक्शन क्रिएट करता हूं। देखिए 2-4 बार ऐसा फ्रिक्शन क्रिएट करता हूं। अतः अभी इसको ये चार्ज इसके ऊपर आया नहीं, कैसा पता चलेगा? अभी तो मुझे दिखाई, आंख से तो नहीं कि कुछ देख सकता हूं, लेकिन अभी मैं ऐसा कर रहा हूं, जो थर्मोकोल की बॉल्स है मेरे बाजू में, बस वो लेता हूं फिर एक बार, और आपको पता चलेगा। अभी देखिए आगे ये चिपक रहे, देखिए। So this is a very very interesting activity to show the static charges just with help of the balloon and the PVC pipe. Now ये जो हमारा डायनामिक टॉयज फ्रॉम ट्रैश ना, हमने बहुत इस टाइप के छोटे छोटे एक्सपेरिमेंट जो होते हैं ना, जो बच्चे घर में कर सकते हैं, पेरेंट्स घर में कर सकते हैं, ऑफ कोर्स टीचर्स घर में कर सकते हैं ना, ये हमने बहुत डॉक्यूमेंट किए हैं और उसका डिटेल लिंक हमने डिस्क्रिप्शन बॉक्स में भी लिखा है। और एक चीज़ मैं आपको जल्दी दिखाता हूँ। और ये मेरे पास जो है ना, देखिए पहला तो मैं आपको ये दिखा रहा हूँ। ये देखिए एक छोटा सा जो है ना स्ट्रॉ है, और यहाँ मैंने एक छोटा सा छेद किया है। देखिए एक छोटा सा छेद यहाँ है, और आपको शायद यहाँ का छेद बिल्कुल दिखाई पड़ेगा। ये छेद देखो आप, देखिए ये तो छेद आपको दिखाई पड़ रहा है यहाँ, और यहाँ एक यहाँ और ये एक यहाँ, मतलब ये सील किया यहाँ, और यहाँ भी हमने सील किया, स्ट्रॉ लिया बस। और ये डायमेट्रिकली अपोजिट 2 होल्स हैं, और ये जहाँ ये जो पाइप है इसे एक छोटा सा छेद यहाँ है, मतलब एक छेद यहाँ, मिडल का छेद तो आप बिल्कुल देख रहे हैं, और देयर आर 2 मोर ओवर हियर डायमेट्रिकली अपोजिट, और बाकी पूरा सील किया है इसको। अभी यदि मैं हाथ में रखूंगा ये, और ये मेरा यहाँ स्टॉपर रखूंगा बिल्कुल, तो हवा कहाँ जाएगी? मेरे मुंह से यहाँ जाएगी, और यहाँ से निकलेंगी, नहीं तो अपोजिट साइड यहाँ से ऊपर या नहीं तो नीचे। और उसका क्या हो रहा है देखिए अभी, वेरी वेरी इंटरेस्टिंग। और अभी उसका उल्टा करो, अभी सी द रोटेशन ऑफ दिस, उसे मैं प्रोपेलर बोल रहा हूं, ये जो घूमने वाला है ना। तो अभी देखिए इट इज अदर वे अराउंड नाउ। तो ये हो गया। शायद आप बोलेंगे कि यार इस टाइप का मटेरियल हमें नहीं मिलेगा, शायद स्ट्रॉ भी, पेपर के स्ट्रॉ भी आजकल मिल जाते हैं, लेकिन डोंट वरी, वी हैव वेरी सिंपलर वर्जन ऑफ दैट। इसके लिए मैं एक पेपर ले रहा हूं, देखिए ये पेपर है मेरा, बस ये पेपर है, और पेपर जो डबल है मेरा, देखिए ऐसा डबल। और बाद में मैं क्या करूंगा, टेप लगा के ये साइड बंद करूंगा, यहां भी टेप लगाऊंगा और यहां भी टेप लगाऊंगा। और टेप आपका जो ऑर्डिनरी जो होता है ना, वो टेप, बस यहां मैंने टेप लगा के आपको रख दिया है। ये जो टेप है मेरा बिल्कुल यहां रख दिया है। और उसके बाद देखो जो होल है, यहां होल है और यहां होल है, देखिए डायमेट्रिकली और अपोजिट, और बीच में जो होल है। और उसका इंटरेस्टिंग ना, जस्ट विथ हेल्प ऑफ द पेपर, अभी यहां जो होल है, ये छेद इज वेरी इंपॉर्टेंट। देखिए एक होल यहां, इसके अंदर मैं डालता हूं, तो ये होल क्या करेगा, यदि मैं ये देखिए ऐसा बंद करूंगा तो हवा यहां जाएगी और परपेंडिकुलर, जहां मेरा होल है समझो यहां है, तो परपेंडिकुलर निकलेगी। और बस वही अभी यू कैन मेक वेरी नाइस प्रोपेलर जस्ट विथ हेल्प ऑफ द पेपर स्ट्रिप। अभी यहां मैं बंद करता हूं और यहां से जोर से ब्लो करता हूं। और यदि मैं इसे अदर वे राउंड करता हूं तो क्या हो जाएगा, इफ आई होल्ड इट लाइक दिस, ये उल्टा घूम रहा है। मतलब आपको पता चला कि एक बार क्लॉकवाइज चल रहा है, एक बार ये एंटी क्लॉकवाइज चल रहा है। और ये ऐसा क्यों हो रहा है, दोनों भी एक्टिविटी में देखिए यहां से हवा अंदर जाएगी, ये तो बंद है यहां, तो निकलेगी कहां से, यहां। दिस इज माय एक्शन, यहां की एक्शन हो गया। एंड देयर इज अ एक्शन मींस एवरी एक्शन देयर मस्ट बी सम अपोजिट साइड रिएक्शन, एक्शन रिएक्शन, न्यूटन्स थर्ड लॉ। और यहां एक्शन होती, रिएक्शन यहां, और यहां जो अदर साइड में जो हो रहा है, यहां एक्शन थी, उसके रिएक्शन अपोजिट साइड में। तो बेसिकली दिस टॉय वर्क ऑन द न्यूटन्स थर्ड लॉ, बट वी डिजाइन दिस वेरी सिंपल एक्टिविटी जस्ट विथ हेल्प ऑफ द ऑर्डिनरी पेपर। सपोज यू डोंट हैव द सपोज दिस स्ट्रॉ, यू कैन यूज बॉल पेन रिफिल, जो हमारा इंक खत्म होने के बाद नॉर्मली हम जो करते हैं ना, उससे भी वो हो सकता है। चलो, we are coming, thank you very much again, and we are going for the another very very interesting session.
Hello,
Okay, we are good to go. Sure.
Yes,
So,
yes.
hi, hello everyone. Welcome back to the Meet the Scientist session that we are planning to conduct over Zoom, and welcome again for this virtual celebration of Science Day. It is my pleasure to introduce our next speaker for this Meet the Scientist session, which is Dr. Arun Thalapillai. I'm sorry if I butcher your pronunciation again. You can correct me later. He's an assistant professor in theoretical physics at IISER Pune, and his area of research is actually theoretical particle physics, high energy physics. And we will go through some of his presentations, and the title of his talk is actually Our Universe as a Grain of Sand. And as you can see here, he has a small presentation for us, so we'll hear him first, and whatever questions you have, you can type them in YouTube chat. I'll collate some of those questions later and ask him towards the end of the session. Over to you, sir.
Okay. Hello, everyone. I hope all of you are enjoying this spectacular program put together by the Science Activity Center and all the enthusiastic fellow members at IISER. So what I hope to convey to you today is in some sense a kind of unity which, is there across different fields of sciences and definitely across various subfields in physics. So this is the kind of philosophy I want to take in this talk. Please feel free to ask any questions. I've intended it as a kind of an informal interaction session. So, we look out the window and we have a wonderful world out there. Okay, we look out into the universe, we see billions of stars, not just stars, there are like wonderful nebulae, globular clusters, spiral galaxies, this really remarkable world out there when you look out into the sky. Not to be beaten, even on Earth, nobody can argue with the beauty of a sunset or the pattern of a sunset, a windswept sand dune, which you might see in a desert, or the intricate pattern of lightning during a thunderstorm, the beauty in a snowflake, the beauty in life, the flora and fauna around us. And what I hope to convince you is that as different as these might seem, there is actually a very nice, beautiful connection between all of us, including us. Okay, so this brings me to this image. There is this very old image, which usually is depicted as a snake eating its own tail, or rarely something like a dragon eating its own tail. It's a very old symbol. It's been even found in the Egyptian tombs of some of the old pharaohs and so on. And the symbol was always meant to depict the unity or connections between things, eternity, and so on. Okay, so there is, and this is sometimes called the Ouroboros. Okay, what I want to say is that there is also an Ouroboros of our world. Now, if you look at this image, you'll see various length scales. All the way at the bottom are probably length scales you and I are familiar with in our day-to-day life. Okay, as humans, we interact with objects which are like maybe a few centimeters in characteristic length. Maybe there is an ant, or those among you who are more adventurous than I am, maybe you go on treks, you climb, you do rock climbing, so you might even be familiar with the slightly larger characteristic length scales on a day-to-day basis. And unfortunately, we are also experiencing the effects of neighboring length scale, which is the length scale of microbes. So there are these various length scales in our universe. Galaxies, which are extremely large objects. The distances are astronomical. That might be a tautology, but the distance is so vast. For example, just to give you an idea of this, you think of light. You switch on a torch. we think of the light as almost instantaneous, right? But actually light has a finite velocity. Okay, it's around 3 × 10⁸ meter per second. So in fact, it takes about roughly 8 minutes for the light from the sun to reach Earth. Okay, but there are objects in the universe for which the light from these objects takes billions and billions of years to even reach us. So the distance scales are enormous. On the other end of the spectrum, you have things which are extremely small, subatomic particles, atoms, and things which are even smaller than atoms, nuclei, and things with particles whose relevant length scales are even smaller than nuclei, subatomic particles. So there is a huge richness in scales. Either you can view it as a richness in the length scale, or equivalently in a particular way as a richness in the energy scales. Okay, and there is a connection between all of these. Okay, and this is, as I mentioned, this will be my theme. Okay, so in some sense, the at least in the context of physical laws, the first indication that somehow, what we see on Earth, the kind of laws which we see on Earth have some connection to things which we see in the heaven, as they would put it. This was in some sense first realized by Sir Isaac Newton. Okay, all of you are familiar with this story of how he was inspired by a falling apple to kind of realize that, okay, maybe the law or the force which is responsible for an apple falling is also probably responsible for the moon's orbit around the Earth. Okay, some of the stories are definitely embellished. Definitely this story that an apple fell on Newton's head and that's when he got the idea is almost definitely apocryphal. Okay, but science historians have also seen indications that in some ways, okay, these stories are there is a grain of truth in these. In fact, what is shown on the upper right is actually the manor where actually Newton stayed, and very interestingly, which we can all relate to, this was also a year of an epidemic when Newton did most of his greatest works, or at least he brought to closure or started bringing things to closure during this time. This was between 1665 and 1667. There was a terrible plague affecting London, and around I think end of 1665 or something, it had already spread to Cambridge, and Newton had to leave the Trinity College and go to this manor and stay there as a lockdown for 2-3 years. And it is during this time that he developed what we now call calculus, laws of motion, Newton's universal theory of gravitation, things in optics, and so on. Okay, so I'm hoping that some really young, smart mind out there who is currently under lockdown or having to live in very constrained situations because of an ongoing pandemic is actually thinking about something really amazing. And in a few years, so there is a silver lining, hopefully, to and hopefully we'll all come out of it safe and sound. Okay, so the first person who realized that there is some connection between laws on Earth, apple falling, it might have something to also do with the motion of celestial objects and so on, was Newton. Okay, and Newton's theory of gravity was extremely successful for many, many centuries. It gave predictions which you could observe exquisitely. Okay, so but towards the early 20th century or late 19th century, some small discrepancies started being observed in the motion of Mercury near the sun. Okay, initially people thought maybe there is another planet which is closer to sun, which we are not observing, and maybe that explains the motion or this slightly strange motion of Mercury, which could not be fully explained by Newton's theory of gravity. Okay, and that is an interesting history in itself. I will not dwell into it, but the point is that the Newton's theory of gravity was subsumed by another more general theory called the general theory of relativity. And all of you know the gentleman on the lower right, Einstein. He had an idea that what we think of gravity is actually in some sense a curvature in space and time itself. So the motion, the reason you see the moon orbiting around the earth is not because of a force, okay? In some sense, it's actually because that's in some sense the shortest path it can travel in that particular geometry, okay? So he interpreted gravity in terms of a geometric entity, okay? So Newton's theory is a correct theory in the sense that, in a particular limit, general theory of relativity becomes Newton's theory. Okay, so it's not that one is wrong. Okay, in some sense, yeah, the correct theory, as far as we know currently, is general theory of relativity, at least in a particular regime. Okay, but in a particular limit, it becomes Newton's universal gravitation law. Okay, there's another remarkable person which I've also indicated here. So I want to mention, in many of the connections I'll make, I'll also try to represent a particular field by some of the participants in the field. In no way is that representation accurate, because history is more complicated. It's not just that one person one day did a theory, and I hope you all should appreciate this. Okay, but I'll try to give some indication of who are some of the participants. And in some cases, for example, in the case of Emmy Noether, she was a very remarkable mathematician. She was somebody who solved something which both Einstein and Hilbert, who was a giant in mathematics. Hilbert was a very famous mathematician. Some of you might even have heard of Hilbert's problems and so on. After general theory of relativity, both of them were thinking about the status of conserved or laws, conservation of energy. How does conservation of energy appear in general relativity and so on? And it was not very clear. And she is the person who actually clarified this, not only in general theory of relativity. She actually took that whole idea and built up a full structure of, how to think about symmetry. What is the relationship between symmetries and conserved quantities? Things like conservation of energy, conservation of angular momentum, conservation of linear momentum, which some of you might know about. She actually built up a very beautiful understanding of this. Okay, and it's a travesty that she could not even have a paid job at the time, because women were excluded from sciences in that era. Okay, so Emmy Noether, when physicists meet for lunch or coffee, a usual question is, hey, what's your favorite theorem? Yeah, I know. Yeah, this is the kind of conversation sometimes we have. It's not about who's your favorite actor. It might be what's your favorite theorem or what's your favorite equation sometimes. And Noether's theorem is usually in the top 5. Okay, and personally for me, it's also, I would say definitely Noether's theorem is one of my most favorite theorems in physics. Okay, now, so what we have essentially done, or what we have essentially seen, is that we are able to connect terrestrial or local phenomena involving moon, sun, orbit of planets around the sun, things falling on Earth, all the way to the motion of galaxies, the motion of stars, motion of clusters of stars, and so on. So this was the first way in which this unity was kind of appreciated. Not the only one, as we will see. Okay, but so in some sense, we have there is a unifying theme or unifying law which kind of ties up these facets. And I also just want to mention, although I should have mentioned it earlier, you look at any point in this Ouroboros, there are scientists at IISER Pune working on every facet of this diagram. Okay, there are biologists working on fascinating things uh, uh, at the level of flora, fauna, microbes, DNA. There are chemists working on beautiful biochemistry, inorganic chemistry. There are physicists working on gravitational waves, and there's going to be a wonderful talk later today afternoon and about India now being a part of this adventure to look for gravitational waves. We have already discovered it, but we have the potential to bring in a lot of new excitement and capability there. Okay, so I hope you will attend this talk as well. Okay, so there are scientists at ICER and definitely physicists working on every aspect of this diagram. Okay, now subsequent to Newton, over the many centuries, starting from, in fact, many of the foundations laid by Newton himself, we have developed a very good quorum of physical theories which can explain quite a lot, okay, which goes by the name of things like classical mechanics, electrodynamics, and so on. And again, here there's a unity, the same kind of physical principles and equations of motion which would describe how a top would spin, for example, can also be used to understand how a motion of a cyclone occurs, or how a water would flow, with appropriate generalizations. Okay, what is shown on the top right is an optic fiber cable, which enables us to get high-speed internet or do communication very quickly. This is predicated on things in electrodynamics, okay, things like total internal reflection and so on. Okay, and the dynamics of two skaters or two ballet dancer or a Kathak dancer, the laws which can describe the dynamics is also the laws which can explain things like a spinning top or a pendulum or so on. Okay, so we have built up a body of knowledge which has helped us understand a lot in sciences and physics specifically. Now, what was found is that when you try to apply some of these laws to things which were minute, of atomic scale and so on, okay, this is an artist's rendering of an atom on the top left, then there were certain puzzles which arose. One could not just use classical mechanics or what I would call conventional electromagnetic theory to understand. It seemed to be a puzzle. So this is something which many great physicists worried about in the early 20th century. Okay, and what we were led to, okay, through experimental observations as well as very heroic theoretical intuitions, is the fact that one, just like Newton's theory of gravity was a limit of a more general theory, what was realized is that what we call classical mechanics is actually a limit of something much more general. Okay, it goes by the name of quantum mechanics, and many of you might have heard this thing, and that actually helped us understand phenomena at the atomic scale, phenomena of some things which happen in a crystal lattice. What is shown on the top right is graphene. There are condensed matter physicists who, my friends and colleagues who work here on graphene, fractional quantum Hall effect, which have amazing properties. Okay, and quantum mechanics is like the tool to pose some of these questions. Okay, so, and even to understand properly how a laser works. Okay, laser is like almost ubiquitous, right? You go to a mall, grocery store, or you go to a talk, or at least when we could go to a actual talk, people would be using laser pointers. We have used lasers for communicating. You need quantum mechanics to properly understand that. Okay, even things like, you know, you use a cell phone camera almost every day, right? It has devices, you know, things called like charge coupled devices and so on. It depends on the fact that quantum mechanics is what it is. Okay, we have been able to build semiconductor devices, microprocessors, build microwave, okay, microwaves is electrodynamics, but the point is quantum mechanics has helped us do this. And what is shown on the bottom right, some of the people who played an important role in this. Again, it's not exhaustive, you know, there are many people whom I've left out, but some of these people might be familiar to you. And I'm just giving an example of some of the people who played a role. In a different regime, see, what we talked about is going to smaller and smaller length scales, atomic scales, and so on. And we found that classical mechanics, or more precisely, Newton's laws of motion had to be modified. And Newton's laws of motion, Newton's theory, classical mechanics was only a limit of quantum mechanics. In a other regime, one also noticed, both out of observational and experimental intuition, as well as certain theoretical reasons, that when objects are traveling close to, or when objects are fast, very fast, okay, very close to the speed of light, the notions which we had in the Newtonian era about time and space, you know, till the early 20th century, we thought of, okay, you know, time and space is like a stage and we are actors in it. We act, time and space is like just a stage. A realization started dawning that that is not completely correct. In some sense, the nature of space and time itself depends on the observer. The reason we do not see this in our daily life is because we do not encounter speeds which are very large. Okay, what might be the largest speed you might have encountered, or at least heard about in human experience? It might be something like we are launching a probe to the moon, you know, Chandrayaan, Mangalyaan. Now, this has to escape Earth's gravitational pull. Okay, so there is a characteristic speed called the escape velocity. It's very large, around 11 kilometers per second. 11 kilometers. Okay, but compared to speed of light, it's nothing. So these kind of effects, you would think, or you would see only when the speeds are comparable to the speed of light. Okay, then there was a realization that one has to replace this with another theory, which is a more correct theory called special relativity. Okay, and I want to add that this is not just completely no application. Okay, today's GPS satellites, okay, which have very precise, when you order something on, I don't know, Zomato or Swiggy or any of the other thing, or you order something from Flipkart or Amazon, you know, you give an address, there is a GPS location. The GPS satellites have to incorporate these corrections to get the kind of accuracy which is required. You know, you put something in Google Maps, you want it to be accurate to a few meters, you can only do this because you've incorporated special relativity. I should also add that there is a different way in which all this ties together, okay, which is this maxim that more is different, which is that even if you know all the fundamental laws of, let's say, a particle like a water molecule or a grain of sand or something, when you put these objects together, new phenomena arises, which goes by the name of emergence. Okay, what is shown on the top left is like turbulence. You might know a lot about a water molecule, but something like turbulence, okay, flow of water when it is choppy, crudely speaking, it's one of the hard and outstanding problems in classical physics, for example. Okay, so this more is different maxim was actually coined by a very eminent and well-known condensed matter physicist, Paul Anderson, who passed away recently. So one should not take a very naive reductionist viewpoint that, okay, if you know the law of a single object or a single entity. No. Okay. In fact, life is in some sense an emergent phenomenon. Okay. So more is also different. Okay. So we have now linked up two regions. Okay. Although I've drawn them as separate ellipses. Okay. It's the same law. It might be that in certain limits only you don't see a facet of a particular law, but it's all the same law. Okay. So we have connected up one part. Now, furthermore, as humans understood more and more about atoms or things which were even smaller than atoms, we started seeing exotic particles in cosmic rays. We started realizing that, okay, maybe the nuclei of atoms can be split. We started seeing objects out in the universe called neutron stars or pulsars, which is shown in the lower part of the slide. Pulsars are these stars which shoot out radio waves, extremely intense and very focused radio waves at a very, very, very precise time period. They're much more accurate than some of the conventional atomic clocks. Okay, then there was a realization that one has to go further in terms of physical laws than what we know of. Okay, and again, some of the people, theorists as well as experimentalists who helped us and taught us what some of these laws could be are shown below. I want to emphasize again, Lisa Meitner there. She is actually one of the people who actually discovered nuclear fission. Okay, she was again a very remarkable physicist. She went unrecognized. Her collaborator, Otto Hahn, did win a Nobel Prize for nuclear fission, but she was never recognized for this. Okay, so I want to emphasize Lisa Meitner. Okay, so we understood that, okay, we have to understand subatomic phenomena. How do things in the nuclei interact? There are exotic particles like muons, which look, a muon is like an electron. It's negatively charged, but it's about 200 times heavier than an electron. Okay, so over many decades, we were able to build a consistent theory of subatomic phenomena, okay, which explains the fundamental interactions, which is kind of prosaically called the standard model of particle physics. Okay, but it explains in a beautiful way three of the fundamental interactions in our universe. Okay, the electromagnetic force, what is called the weak nuclear force, which is responsible for radioactive decay, strong nuclear force, which is responsible for holding the nuclei together. And if you also include general relativity, it kind of explains, I would say, something like 95, 99% of everything which we can see out there. And see, I'll put it in quotes, okay? And it's not important for this talk, but this is based on a framework called quantum field theory. Quantum field theory, basically what it does is it combines, or it beautifully unifies the principles of quantum mechanics and special relativity. Okay, so what we were calling as quantum mechanics is again only a particular limit of a quantum field theory. Okay, and just like we have a periodic table of elements, there is a periodic table of elementary particles, which is what is shown in the center of the screen. And you can basically write the law of the universe at the back of a coffee cup. I have a similar mug. Okay, and this was something remarkable. Okay, and some of the people who kind of brought this story to some closure are Weinberg, Glashow, and Salam. And of course, as I always, a caveat is that there are a lot of people who actually did amazing work, whom I'm not even bringing up here. Okay, and just to tell you, it's not just theory. Some of these calculations you can see on the top. Electron has something like a magnetic moment. You can calculate it to many decimal places very accurately using this theoretical tool called quantum field theory, and you can measure it. Look at the exquisite agreement. They match to 11th decimal place. Okay, others there are theoretical uncertainties also for some technical reason I will not go into, as well as experimental. I don't know, but so sometimes things like quantum electrodynamics, which is one of these quantum field theories, is sometimes whimsically called the most perfect theory invented. I don't know, maybe discovered by man, whatever the case may be. Okay, so experimentally, these give very precise things. So we have been able to combine various length scales now. Okay, again, I've drawn them as disjoint ellipses, just partly out of my poor artistic skill, but it's the same law. And if probably my daughter were there, she would even make fun of me, saying it looks like Mickey Mouse. So if there are any young viewers there, I see the point. So enough with my poor artistic skills. Let me end with a few parting comments. Okay, we talked about connections. There's a part remaining. How do we connect back to the large scale structure? Now, in the current understanding, okay, with a few partial observational evidence as well, what we believe is that the universe started, very crudely speaking, from a small region. Okay. So in these small regions, like I said, quantum mechanics was needed to understand subatomic phenomena, small phenomena. So when the universe was at that stage, okay, maybe 15 billion years or much earlier, actually, actually the quantum phenomenon was important for the universe in that stage, in that small stage. And one of the predictions of quantum field theory is that there are what I will call quantum fluctuations. So these are kind of like thermal fluctuations, which you are familiar with. You're sitting in a room, AC or whatever, but when there's a slight whirl of wind, then you feel a little cold or maybe a little hot in some region. So quantum fluctuations are kind of the analog of such things. And the point is that these quantum fluctuations cause slight density perturbation. So it's a little bit like there's a body of water, but there is some small depressions here and there, and water might accumulate a little bit more there. Okay, so the quantum fluctuations kind of led to these density perturbations, and these became the seeds for things like stars, things like galaxies to form, because you need a gravitational well so that some dust can accumulate and eventually form stars. So it's the quantum fluctuations which actually we believe seeded these, and there are some indirect evidences already, and we are trying to look for these actual fluctuations. And some of the remarkable people who physicists who played a role in this, some of them, Alan Guth, Linde, Starobinsky. So this is how things at the smallest scale get connected to things at the largest scale. Okay, the laws, it's the same laws which were applicable in the smallest scales, which also help us understand some of the largest structures in the universe. So let me end with a parting thought. Okay, so this is a beautiful few lines from William Blake's Auguries of Innocence. So there is, in a real sense of the word, a whole universe in a grain of sand, because it's the same law which describes a grain of sand, the atoms in it, or how a sand particle moves when it's put in a pile, or when there is a wind blowing, the nuclei, the electrons in a sand particle. It's the same law which unites all of us. Okay, and of course, it's not just a grain of sand which has this property, including us. There is a whole universe. It's the same law, same set of laws, which describe all of these phenomena. Okay, so let me thank you for your patience, and I will be happy to take any quick questions.
So, Dr. Arun, I'm really thankful for your wonderful presentation, and the thoughts that you discussed were really thought-provoking, and these ideas, I'm pretty sure most of our viewers will have nice comments to talk about this.
The only catch is that we have like very interesting questions which are asked, but there were just too many of them, and we might be running out of time very quickly. So I'll just ask you just one question, which seems to be the latest conversation in chat which is going on right now, which is about matter and antimatter. And as a theoretical physicist and as a person who is working in these type of fields, if you can just shed some light about what actually is antimatter, and if you also want to talk about how there are some misconceptions because of popular science concept that you can have antimatter as some sort of physical entity which will collide with matter and do annihilation and things like that. So maybe if you can just quickly talk about what antimatter actually is in a theoretical framework, how people study this, and what misconceptions are probably there with people which you want to clarify.
Okay, that's a very good set of questions. So first thing I'll tell you is that antimatter is definitely something amazing, but one should not also think that it's something very exotic either. Because let me tell you, we produce antimatter as a matter of routine now. In fact, even in many hospitals. Okay, there is, for example, a scanning technique called PET scan, positron emission tomography, which uses positrons to actually monitor the brain. A positron is an antiparticle of an electron. Okay, in some cases, it's used for cancer therapy. At colliders, like the Large Hadron Collider, which is running in Geneva, we produce antiparticle in collisions as a matter of fact, routine. A few years back, a decade back, there was another collider which was running in North America called Fermilab, which was a anti-proton collider. Okay, so antiparticles are really we have almost made a technology out of antiparticle. Okay, now antiparticles arise actually as a requirement. It's kind of forced into you when you try to combine special relativity with quantum mechanics. We talked about quantum field theory. So when Dirac tried to combine these, okay, he also had some physical motivation for it, but also extremely brilliant mathematical and theoretical intuition. He realized that if you want to combine this, for every particle, one also needs to have an antiparticle. Now, electron has an anti-electron, proton has an antiproton. In some cases, the particle and antiparticle are the same particle. Like photons, antiparticle is also a photon. Okay, I'll end with just one other comment I'll make about antiparticle. Things are not completely symmetric. In the sense, you look out into the universe, there's more matter than antimatter, primary form. Okay, they're produced. Antimatter is produced in stellar processes, neutron stars, all that. But what I'm saying is, whatever was left over from the beginning of the universe, there's a lot more matter than antimatter. Okay, we have some understanding of how this could happen, but the story is not completely understood. Okay, so this is one of the puzzles which physicists are trying to understand. Why is there more matter than antimatter? And it's good for us, because if they were of the same amount, and when a antiparticle and a particle meet, they would actually annihilate and you would get pure energy. So life would not be possible. Things like stars would not be possible. This beautiful tree outside my window, none of this would be possible if it was a perfect symmetry between these two. Okay, we understand a lot about it, but the story is not completely closed. So I'll end there.
Okay, it's very fascinating to discuss all these ideas, and I'm pretty sure most of our viewers will find it very interesting to look this up further. I'm really sorry, I would like to address the chat here that there are a lot of interesting questions, and there is a pinned comment where the link for submitting your questions as a Google form is being given. So please submit your questions and we'll try to answer them in future sessions whenever we have other experts with us.
Yeah, I'll be happy to check with you.
Yes, sir. And with that, I'd like to thank Dr. Arun for this wonderful session. And I'm pretty sure most of our viewers also enjoyed it. So we'll go to the next part, which is again some more hands-on science activities. Thank you, sir.
Thank you.
सभी का फिर एक बार स्वागत. Now this is a very interesting session, again hands on science, and today I am showing you very interesting activity that you can design with help of the ordinary material. चलो let's start. अभी जो मैंने एक्सपेरिमेंट जो किया था पहला बलून से किया था, so let me start with the balloon. अभी देखिए, see the simplicity of this experiment. What I am looking over here ना, there is a one balloon over here and another balloon over here, and these balloons are from the same batches. बैच उनके सेम हैं, तो बैच उनके सेम हैं. अभी देखिए ये पाइप जो है यहाँ अलग है, देयर इज अनदर पाइप ओवर हियर, ये भी तुम्हारा दो पाइप ऐसे अलग अलग है, और ये जो थर्ड पाइप जो है जहाँ बलून नहीं है, सो दिस इज अनदर पाइप. अभी देखिए बेसिकली 3 पीसेस है जो पाइप के, एंड देयर इज अ टी जॉइंट, और ये क्वालिटी जैसा मैंने बोल दिया कि सेम है. नाउ माय क्वेश्चन इज, ये दो बलून सेम होने के बावजूद अभी देखिए यहाँ से मैं ब्लो करने वाला हूँ, और आपके लिए एक क्वेश्चन है, यू कैन आंसर इन द चैट. क्या क्वेश्चन है? यदि मैं यहां से ब्लो करूंगा तो कौन सा बलून फर्स्ट इन्फ्लेट हो जाएगा, ये बलून या ये बलून या दोनों एक साथ? आपका आंसर यू हैव टू राइट इन द चैट. और मैं बोल रहा हूं कि दोनों बलून के कलर भी सेम है और उसका क्वालिटी भी सेम है, क्योंकि एक ही पैकेट से है. चलो आपका आंसर अभी चैट बॉक्स में शायद आया होगा. तो व्हाट आई एम डूइंग नाउ, आई एम डूइंग द एक्सपेरिमेंट. अभी साइंस का मतलब बोल के नहीं, करके दिखाओ. यू हैव टू प्रूव विथ हेल्प ऑफ द एक्टिविटी. अभी मैं आपके सामने एक्टिविटी कर रहा हूं. लेट मी इन्फ्लेट फ्रॉम हियर, मुझे ब्लो करना है अभी. अरे एक ही इन्फ्लेट हो गया. शायद आपने सोचा होगा दोनों एक साथ होना चाहिए, एक ही हो रहा है. आप बोल सकते कि ये खराब हो सकता है. चलो लेट मी टेस्ट नाउ. अब ये मैं ऐसा बंद करके रखता हूं. खराब तो नहीं है, दोनों भी अच्छे हैं बलून, तो भी बार बार अभी देखिए, लेट मी शो यू वन मोर टाइम. एक ही ब्लो हो रहा है, नो मैटर मैंने उल्टा भी किया तो. ऐसा क्यों? एक ही बार मैं ब्लो कर रहा हूं दोनों में, तो एक ही कोई इन्फ्लेट हो रहा है. तो उसका रीजन मैं आपको जल्दी बताता हूं. ये ऐसा है कि हमें लग रहा है कि दोनों बलून सेम हैं, बट दे आर नॉट एग्जैक्टली आइडेंटिकल. थोड़ा सा उसमें फर्क होगा, थिकनेस में फर्क होगा, माइक्रो लेवल पे फर्क होगा. तो इसलिए जो थोड़ा सा वीक है वो फर्स्ट इन्फ्लेट हो जाएगा, और वो दूसरा जो थोड़ा सा स्ट्रांग है वो बाद में इन्फ्लेट हो जाएगा. सो दिस इज अ ट्रिक बिहाइंड एनी 2 balloons even if you use from the same packet. अभी ना अनदर इंटरेस्टिंग क्वेश्चन. अभी मैं क्या करूंगा, एक थोड़ा सा बड़ा इन्फ्लेट करूंगा, इतना किया, और ये छोटा सा इन्फ्लेट करूंगा मैं. हाँ, नाउ माय क्वेश्चन इज, अभी देखिए ये जो मेरा उंगली है यहां मैंने रख दिया है, तो मैं उसे छोड़ दे दूंगा. तो ये छोड़ने के बाद, और ये तो बंद है, यहां जाने का चांस ही नहीं है, तो ये उंगली छोड़ने के बाद हवा कहां से कहां जाएगी? मतलब छोटे से बड़े में हवा जाएगी या बड़े से छोटे में हो जाएगी. और अल्टीमेटली क्या होगा, दोनों इक्वल हो जाएंगे या नहीं हो जाएंगे? शुड आई शो यू? रेडी? 1 2 3. अरे ये छोटा और छोटा हो गया. जो आपका आंसर था ना, दोनों इक्वल हो जाएंगे, बहुत लोगों का आंसर यही होता है, तो ऐसा नहीं हुआ. अभी और एक बार मैं दिखाता हूं. अभी इस टाइम इसे मैं छोटा करता हूं, देखिए इसे छोटा करता हूं, दिस इज माय स्मॉलर. अभी ये बड़ा है. अभी क्या होगा, हवा बड़े से छोटे में जाएगी या छोटे से बड़े में जाएगी? देखिए आपका क्या आंसर है, मतलब लेफ्ट टू राइट या राइट टू लेफ्ट. 1 2 3. अभी देखिए ये जो है मेरा छोटा 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 होता जाएगा, और अल्टीमेटली क्या हो जाएगा, देखिए मैं अभी यहां पकड़ रहा हूं थोड़ा सा. अभी इस टाइम क्या हो गया, थोड़ा सा मैंने, मेरा यहां से शायद लीकेज है, मैं जरा पक्का करता हूं, इसे पक्का करता हूं. और अभी देखिए यदि मैं ये छोड़ूंगा, अभी देखिए इसका क्या होता जाएगा, तो ये छोटा 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 हो जाएगा, और छोटा होता जाता है. लेकिन एवरी टाइम यू नीड टू चेंज द बलून। अभी मैं थोड़ा सा इसे और कम करता हूं, और कम करता हूं, और कम करता हूं, और इसे मैं बड़ा करने की कोशिश करता हूं। लेट मी इनफ्लेट, इस साइड वाला बड़ा करता हूं। अभी देखिए, और एक बार देखिए, और एक बार मैं कोशिश कर रहा हूं। छोटे से छोड़ने के बाद छोटे की हवा बड़े में जा रही है, छोटे की हवा बड़े में जा रही, मतलब दैट इंडिकेट स्मॉलर बलून इज ऑलवेज स्ट्रॉन्गर। स्मॉल जो बलून होता है ना, वो हाई प्रेशर होता है एज कंपेयर टू द बिगर बलून। तो यहां प्रेशर ज्यादा था हवा का, इसलिए तो यहां गया। लेकिन ये एक्सपेरिमेंट 2-3 बार करने के बाद यू हैव टू चेंज द बलून, क्योंकि उसका इलास्टिसिटी बाद में बदल जाता है। इसलिए कभी कभी ना जो हम बोलते हैं वो होने का चांस नहीं, लेकिन इफ यू हैव द ब्रांड न्यू बलून देन यू विल गेट द सेम रिजल्ट कि छोटे से हवा बड़े में जाएगी। सो दिस इज अ इंटरेस्टिंग एक्टिविटी। नाउ द अनदर वन विद द बलून, आई हैव हियर द बॉटल। अब देखिए मैं बताता हूं बॉटल में क्या डाल दिया मैंने। ये बलून है देखिए, और ये बलून यहां मैं अच्छी तरह से फिट करता हूं। देखिए ये मुझे अच्छी तरह से यहां फिट करना है। देखिए ये फिट करने के बाद ये अंदर गया अभी, और ये अंदर जाएगा तो ये बलून मुझे इन्फ्लेट करना है बॉटल में। एंड व्हाट इज द ट्रिक, यहां से तो नहीं मुझे टच करना, यहां मैंने एक स्ट्रॉ लगा दिया। नाउ यू कैन सी यहां इसका माउथ ओपन है बिल्कुल। सो लेट मी शो यू विद द स्ट्रॉ, आपको पता चलेगा ये बॉटल में जो बलून है उसका माउथ ओपन है, ओपन माउथ इन्फ्लेटेड बलून। ये क्यों ऐसा हो रहा है ये आप घर में करके देखो। सिंप्लिसिटी क्या चाहिए आपको, जस्ट यू नीड द बॉटल और अंदर बलून डाल दिया, तो ओपन है माउथ उसका, तो भी मेरा बलून इन्फ्लेटेड है। ऐसा कभी बलून नहीं होता ना, लेकिन है यहाँ, क्योंकि क्या किया मैंने, हवा खींच के निकल दिया यहां से, एंड दैट्स क्रिएट द लोअर प्रेशर इनसाइड द बॉटल। और जितना अंदर का प्रेशर कम हो जाएगा उतनी हवा यहां से अपने आप जाएगी। मतलब अभी इस सिचुएशन में टोटल सिस्टम का जो अंदर का प्रेशर है और बाहर का प्रेशर है सेम है, और बलून की खुद की इलास्टिसिटी है, तो इसलिए मैंने यहां छोड़ दिया तो हवा गई। अभी पता चला। और एक बार देखो, मैं खींच रहा हूं तो बलून इन्फ्लेट हो रहा है, और यहां का प्रेशर मैंने लो रख दिया, नीचे वाला मैं बोल रहा हूं, बलून के नीचे बॉटल में, तो मतलब बलून इन्फ्लेटेड ही रहेगा। और जब यहां से हवा में अलाउ करूंगा तो बलून जो है उसकी हवा निकल जाएगी। सो दिस इज अ सिंपल एक्टिविटी यू कैन डू विथ हेल्प ऑफ द जस्ट बलून, बॉटल एंड द पाइप्स। नाउ लेट मी शो यू अनदर वेरी वेरी इंटरेस्टिंग एक्टिविटी। अभी देखिए, लेट मी स्टार्ट विथ दिस एक्टिविटी। आई हैव हियर, आपको पता चलेगा, अभी मैं बोलूंगा नहीं, डेफिनेटली विल आइडेंटिफाई व्हाट इज दिस मटेरियल। क्या है ये, पता चला ना, अट्रैक्शन है मतलब मैग्नेट होना ही चाहिए। अभी ये मेरे पास मैग्नेट है, और ये सभी देखिए इस टाइप के अलग अलग है, ये रिंग मैग्नेट्स है। रिंग मैग्नेट, उसकी खासियत है पोल्स उसके सरफेस पे होते हैं। यहाँ एक पोल है तो अदर राउंड दूसरा पोल है। अभी मैंने सभी मैग्नेट यहाँ डाल दिए, नो मैटर मैं उल्टा सीधा करूंगा तो वो अट्रैक्शन मोड में है, क्योंकि नॉर्थ साउथ, क्योंकि मैग्नेट को 2 पोल होते हैं, नॉर्थ एंड साउथ, तो यहाँ नॉर्थ नॉर्थ साउथ साउथ नहीं होंगे, क्योंकि अट्रैक्शन है मतलब नॉर्थ एंड साउथ होंगे। अभी लेट मी रिमूव फ्यू मैग्नेट्स, और उसको एग्जैक्टली मैं उल्टा करूंगा। यू कैन मेक वेरी नाइस स्प्रिंग। अभी ये उल्टा करूंगा, यू कैन मेक अनदर वेरी नाइस स्प्रिंग, और ये उल्टा करूंगा तो और यू विल फाइंड वेरी इंटरेस्टिंग एक्टिविटीज। इसमें बिल्कुल ऐसा स्प्रिंग बन गया, देखिए ये स्प्रिंग बन गया, और ये उल्टा करने के बाद देखिए फिर अट्रैक्शन होगा। और मेरा क्वेश्चन ये है अभी, और एक क्वेश्चन क्या है, अभी देखिए ये पूरा सिस्टम मतलब मैग्नेट विद स्टैंड, मैं क्या करूंगा, एक वेइंग मशीन जो मेरे सामने है, यहाँ वेइंग मशीन पे रखूंगा इसके ऊपर। तो मुझे आपका आंसर ये चाहिए, ये पूरा सिस्टम अट्रैक्टिव मोड में, मतलब सभी मैग्नेट अट्रैक्शन में है, तो यहां रखूंगा, उसका क्या वेट है हम मेजर करेंगे, और बाद में ये 2 मैग्नेट में हवा में रखूंगा, ये हवा में रखूंगा, ये बिल्कुल हवा में है, तो पूरे सिस्टम का वेट क्या होगा। अभी लुक हियर ना, पहला ये देखते हैं हम, और इसका मैं आपके सामने ये वेइंग मशीन लेता हूं और बिल्कुल ऐसा ये रखता हूं। अभी शायद एक्यूरेट आपको पता चलेगा। अभी मैंने छोड़ दिया तो दिस इज योर वेट, और दूसरा मैं क्या करूंगा, यदि मेजर करने को नहीं आए तो पॉइंटर के रफली जगह देखो कहाँ है, और बाद में मैं क्या करूंगा, इसको जो है तो मैं उल्टा करके, देखिए अब ये हवा में है। आप बोलोगे कि ये तो बिल्कुल हवा में है, इसका वेट माइनस होना चाहिए। अभी देखो क्या है, उतना ही वेट होगा, उतना ही वेट होगा। तो बेसिकली जित इसे अभी नो मैटर एज लॉन्ग एज होल सिस्टम ऑन दिस पैन, तो पूरा वेट उनका सेम ही रहेगा, चाहे तुम्हारा अट्रैक्शन हो, अभी देखिए ये रिपल्शन है, नहीं तो तुम्हारा रिपल्शन हो। अभी मैं अट्रैक्शन करता हूं, देखिए इसको ऐसा करता हूं तो आपको पता चलेगा उतना ही रहेगा। So this is a very, very interesting activity you can do with help of the ordinary material. Now, just one activity I would like to show you, and then I would ask my colleague, he will continue. So this is the simplest one, and what is that? क्योंकि ये आपको बताना चाहिए साइंस डे के बारे में, क्योंकि we have simplest one, just 2 magnets and the copper coil. Copper coil है इसके अंदर, और बस मैग्नेट, नो हिडन बैटरी है, देखिए इतना ही है। एंड देन फाइनली व्हाट यू कैन डू, इफ आई change the magnetic field in the copper coil, insulated copper coil 1000 tons, and 2 ends attached to this LED. So this is simple assembly, and just pipe or any syringe. I am using the एक syringe है। अभी देखिए, can you see that? So very nice actually generator. कभी कभी आपको थोड़ा सा फ्लिकरिंग में हो जाएगा, लेकिन दिस इज अ वेरी वेरी सिंपल एक्टिविटी, बेसिक जनरेटर। और उसका थोड़ा सा एक अलग वर्जन हमने बना दिया, वही थिंग, just there is a magnet inside copper coil. You know the Faraday's law, but this is actually real life experience of the Faraday's law. I am changing the magnetic field in the conductor. अभी देखिए, can you see the light now? So this is a probably simplest generator actually you can design, but probably you will not get this charkha kind of the thing, but we have made another simple version for that. And what is that? Basically ये है, बस सीडी का व्हील बना दिया है, 2 सीडी का, और इसके अंदर बस मैग्नेट है, पाइप के ऊपर कॉपर कॉइल। नाउ हियर लाइट आ रहा है बिल्कुल, देखिए दिस इज वेरी वेरी। अभी यहाँ थोड़ा सा देखिए, आपको मैं थोड़ा सा ऐसा करता हूँ टेढ़ा, आपको अच्छा देखने के लिए। नाउ यू सी, very simple activity, basically generator you can design with help of the ordinary material. Now I am inviting Dinesh to show one more interesting activity, but before that I would like to play one small video. So it's very very interesting video, you have to see carefully and then you have to answer what is happening over there.
Hello everyone, you have seen the toy now. Now we have to discuss the science behind it, what is exactly happening in this toy. So you have seen that when the water jet flow from the bottle, the LED glows. So how does it work? So the principle behind it is, like, the LED is connected to the battery and through the copper wire, and this copper wire was inserted inside the bottle. You can see some water inside the bottle, which is basically a salt water. When this salt water comes out through the hole, what happens? It falls on the second open leg of LED. When it touches the second leg of LED, what happens is, like, the light glows. So what this toy demonstrates? This toy basically demonstrates salt water is a good conductor of electricity. So this is commonly we use people, like, how normally in the classes, like the solutions which contains ions, these are really good conductor of electricity. So this is the way we can demonstrate thing. Now could you go to the next, please? Now here I am going to demonstrate something dependent on the resistance phenomenon. So here you can see the glass bulb and फिलामेंट. सो दिस इज नथिंग बट द इनकैंडेसेंट लैम्प जो बहुत पहले हुआ करते थे हमारे पास, अभी नॉर्मली हम लोग यूज़ नहीं करते हैं, बट स्टिल वी कुड एबल टू गेट इट. और अब इसका हम लोग करेंगे क्या? सो कुड यू गो ऑन टू द नेक्स्ट प्लीज. सो यहाँ पर हमने दो बैटरी ली है, दे ऑल आर कनेक्टेड इन सीरीज, और वहाँ का पॉजिटिव टर्मिनल हमें फिलामेंट से कनेक्ट करना है. और वो जो वायर है, दिस इज कनेक्टिंग अगेन टू द इलेक्ट्रिक बल्ब, and the open end is there. Negative terminal of the battery we are going to connect on this open end, and we'll see what happens. So here we can see that this is glowing. I mean, this experiment has to be performed in dark light. So could you stop the video please? Pause. Okay, so the question is, when we are heating this filament, what happens exactly? So we are using the matchstick over here to heat the filament. Now you can guess your answer. Okay, observe the intensity of the light. Now you can go ahead. Oh, when I'm removing basically this matchstick, the intensity increases. So why this happens, we'll discuss it later. In the second experiment, yeah, so what I'm doing, I'm blowing air from my mouth, and what happens is basically the intensity of the electric bulb increases. So why this happens? When I'm heating the filament, when I'm blowing air from my mouth, तो उसका intensity कम हो रहा है, ज़्यादा हो रहा है. ऐसा क्यों हो रहा है? तो हम लोगों ने इफेक्ट पढ़ रखा हुआ है कि अगर आप किसी मेटल को हीट करते हैं तो इसमें रेजिस्टेंस बढ़ जाता है. रेजिस्टेंस बढ़ जाने की वजह से, अगर क्योंकि वो सर्किट में है, तो रेजिस्टेंस बढ़ जाने की वजह से उससे जो करंट फ्लो होगा वो कम होगा, और जो इलेक्ट्रिक बल्ब को जो करंट मिलने वाला है, क्योंकि उसका क्वांटिटी अभी कम हो गया है, एंड दैट्स द रीज़न कि आपका जो इंटेंसिटी है वह कम हो जाता है. तो ये कब होता है? व्हेन वी आर हीटिंग द मेटल. नाउ वी आर स्पेसिफिकली टॉकिंग अबाउट द मेटल ओनली. In the second case, when I am blowing air from my mouth, so what happens? It's coming up with a low temperature, which is low in comparison to the atmospheric temperature. So when it cool down the filament, what happens is basically resistance again decreases. और जब resistance decrease होगा तो फिर current बढ़ जाएगा, और जब current बढ़ जाएगा तो उसका जो intensity है वो फिर से बढ़ जाएगा. तो ये जो phenomenon है, normally we people study in 11th 12th like how does the temperature the resistance of the material or the metal basically depend on the temperature. So I can ask you the question, like if the same thing we will do with some semiconductor element, what will happen? Will you going to get the same effect or not? Okay, so now after this we would like to go on the next please. यहाँ पर आप एक पिक्चर देख सकते हैं जिसमें थोड़ा हम लोगों ने थोड़ा इलेक्ट्रॉनिकली इक्विपमेंट ले रखा है, जिसमें आर्डिनो है और कुछ डिवाइसेस है. तो वी आर नॉट गोइंग टू मच डिटेल इनटू हाउ टू मेक इट. फॉर दिस प्रोबेबली यू कैन राइट टू अस एंड वी कैन सेंड द प्रोसीजर. और यहाँ जो वाइट है दिख रहा है वो पावर बैंक है. पावर बैंक से हमने आर्डिनो कनेक्ट किया है. और यहाँ जो एक स्टैंड की तरह दिख रहा है वहाँ पर आप देख सकते हो कि वायर कनेक्टेड है जो रेड है, और वहाँ पर कुछ ब्लैक पार्ट दिख रहा है. तो वहाँ एक गैप, एयर गैप के बीच में दो ऐसे सर्कुलर जो है आपको डिवाइसेस दिख रहे हैं. दिस आर नथिंग बट द अल्ट्रासोनिक सेंसर्स. अब इनका हम लोग क्या करने वाले हैं, लेट्स सी. सो कैन यू प्ले ऑन द वीडियो हियर. सो मैंने एक मेटल मेश लिया है और उसके ऊपर पॉलिस्टीरीन जो बीड है उसके कुछ पीसेस रखे हुए हैं, और मैं इन दोनों अल्ट्रासोनिक सेंसर्स के बीच में रखने वाला हूँ. नाउ सी व्हाट हैपेंस. ओह, they are levitating into air, right? Again I have taken the another one. I'm going to place it just above it. Still levitating. Now going to keep third one. So how many we can place this? And the basic part is why this is happening. तो हम लोग एक फेनोमेनन पढ़ते हैं जिसे हम लोग बोलते हैं स्टेशनरी वेव. तो स्टेशनरी वेव होते क्या है? अभी हम लोगों ने देखा कि यहाँ पर मेरा एक अल्ट्रासोनिक सेंसर है, दूसरा यहाँ पर है. जब यहाँ से मेरा सोर्स इमिट कर रहा है क्या, अल्ट्रासोनिक वेव्स विच आर बेसिकली बियॉन्ड द ऑडिबल रेंज, और यहाँ से भी दूसरा जो सोर्स है वो भी अल्ट्रासोनिक वेव प्रोड्यूस कर रहा है। इन दोनों का फ्रीक्वेंसी और एम्पलीट्यूड सेम है, इस वजह से ये लोग क्या करते हैं, इंटरफेरेंस करते हैं। और इंटरफेरेंस हम लोगों ने जो 11th-12th में मोस्टली हम लोग पढ़ते हैं, उससे होता है कि वो एंटीनोड और नोड फॉर्म करते हैं। These are something like interference in light, but here we are mostly talking about the pressure waves, क्योंकि जो साउंड वेव्स होते हैं वो बेसिकली प्रेशर वेव्स होते हैं। तो जहाँ जहाँ पर हमने देखा कि जो बॉल है जहाँ लेविटेट कर रहा है वहाँ पर जो प्रेशर है वो हाई है, उस वजह से वो उस बॉल के मास को क्या कर रहा है, काउंटर बैलेंस कर रहा है। दिस इज द रीजन दे आर फ्रीली लेविटेटिंग इनटू एयर। सो दिस एक्सपेरिमेंट सीम्स रियली ग्रेट, राइट? इट्स फनी, आई मीन you can simply watching something without any support, they are levitating into air. This is how like the people would like to do. I mean, main also like to do that, right? Yeah. So can you go for the next one please? Okay. अभी हम लोग यहाँ पर काफ़ी सिंपल सा एक्सपेरिमेंट देखने वाले हैं जो आप रसोई में रह के कर सकते हैं। और ये रसोई में इसलिए बोल रहा हूँ क्योंकि आपको वहाँ पर एक स्क्रब दिख रहा है। ये बेसिकली मेटल स्क्रबर होता है जिससे हम लोग बर्तन साफ़ करते हैं। मैंने क्या किया है कि वहाँ पर से थोड़ा सा पीस लेके उसे लकड़ी में माउंट किया है, मतलब ऐसे एक स्ट्रेट तरीके से, सो दैट कि वो सीधा रहे। और पास में मेरा 9 वोल्ट का बैटरी है। अब हम लोग इससे करने वाले क्या है? सो कैन वी गो ऑन द वीडियो प्लीज? देखिए क्या हो रहा है। आपको कुछ रेड रेड नजर आ रहा है? तो ये मेटल वायर जो है जहां पर मैं बैटरी कनेक्ट कर रहा था, सिर्फ उतने ही पार्ट में क्या हो रहा है कि जो मेटल वायर है वो रेड में कन्वर्ट हो रहा है। इसका मतलब क्या है? तो हम लोग जो पढ़ते हैं कि इलेक्ट्रिक हीटिंग इफेक्ट ऑफ इलेक्ट्रिक करंट, तो जब बैटरी से जो करंट जा रहा है उतने ही रीजन में वो करंट फ्लो हो रहा है, क्योंकि इस जो वायर है उसका रेजिस्टेंस हाई है, इसकी वजह से वहाँ पर हीटिंग इफेक्ट ज़्यादा हो रहा है। तो हमें एक लॉ पता है कि हीटिंग इफेक्ट इज बेसिकली इज इक्वल टू I²RT, जहाँ पर वो आपके जितना ज़्यादा रेजिस्टेंस होगा उतना ज़्यादा हीट प्रोड्यूस करेगा, और जितना ज़्यादा करंट होगा उतना ज़्यादा वो हीट प्रोड्यूस करेगा। इसे हम लोग जूल्स लॉ बोलते हैं, और हम लोगों ने काफ़ी पहले से पढ़ा करते हैं। तो इसमें भी यही हो रहा है कि ये जो वायर है उस छोटे से रीजन में जब जाता है तो उसका जो करंट है वो काफ़ी हो जाता है, और इस वजह से वहाँ पर वो हीटिंग इफेक्ट शो करता है, वहाँ पर वो रेड हॉट हो जाता है, क्योंकि वहाँ पर कोलिजन वगैरह एटम्स का काफ़ी होते रहते हैं। तो ये हमने छोटी छोटी जो टॉयज़ है, छोटी छोटी जो चीज़ें हैं, वो हमने आसपास की चीज़ों से बना रखा है। तो बस इसी के बाद मैं एंड करना चाहूँगा। थैंक यू अंकिश।
Namaskar. I welcome you all on occasion of Science Day celebrations in IISER Pune. Today we have with us Dr. Chandrashil Bhagwat, who is an associate professor in mathematics department in IISER Pune. We are going to venture into the amazing world of prime numbers. Number system have various categories. Why there was a need of having so many categories?
So, hello everybody, happy Science Day. So, Shanti, that's a very nice question. And then people often wonder why these numbers come into existence, first of all, and why people study it. So, to answer in one line, everything has come into existence, or in some sense come to our senses because of the need of counting. From long time, people have been counting various things, and then that's how various kinds of numbers have been, let's say, I won't say invented because they existed, nobody like created them, but yeah, people started thinking about it. And among them, one of the most important, let's say, type or class of numbers is called prime numbers. And then people are curious why prime numbers are important. So in one line, again, the prime numbers can be thought of as building blocks of integers. So as all of us have learned in school, every integer, let's say every positive integer can be written as product of prime numbers. And you can think of compounds and elements in nature. So for example, water is made up of hydrogen and oxygen, but it's only, yeah, I mean, only when people studied that there's a notion of elements and compounds, then only people realized how various, let's say, substances in nature are made up of other smaller objects. That's how you can think of prime numbers, as the building blocks of integers.
But there were odd numbers, there were even numbers, and now they are prime numbers. So what are exactly prime numbers?
So for example, when you talk about even and odd numbers, that categorization is based on what happens if you divide a number by 2. If it's completely divisible, then we call it even. If it's not completely divisible, we call it odd. Now here, instead of dividing a number by one particular number like 2, you start with a number and then you look at all its factors. And then if there is no other factor than, let's say, 1 and that number itself, then we'll call such a number prime. Except in this definition, we are already, let's say, defining primality only for numbers which are bigger than or equal to 2. So there's a convention that we don't call the number 1 as prime. Okay, so this is the definition basically, that if there is no divisor other than that number and 1 itself.
Very nice. And you said that 1 is neither prime nor composite. So why is it so? What is so special about 1?
So for example, if you think of integers, so suppose you want to ask yourself a question that given an integer, can you look at its reciprocal? So everybody understands what is reciprocal. Like we write it as 1 divided by n, or 1 over n. And then if you ask the question that which integers, let's say which positive integers have a reciprocal also as an integer, and the answer is only 1. The number 1, its reciprocal is itself, which is an integer. But for no other positive integer other than 1, if you take the reciprocal, it won't be an integer. It will be something called a fraction. So in mathematical terminology, such a number is called unit. Okay, so often in our usual daily life, unit, somehow we think of 1 unit or unity as associated to the number 1. So in mathematics, this concept is generalized, and then any kind of system, if the multiplicative inverse or reciprocal of that object is also in the same system, then such a number is called unit. And in that sense, only one positive number is in it, integer is in it, that is 1. So that's why we don't want to define the notion of primality for that number. So it's part of a convention and part, let's say, a logic system which is based on this convention.
So prime numbers as such is very special. And you were saying that it is very important, and historically also it has played a very important. But who invented prime numbers? I was very curious about this. So what do you think?
Yeah, so for example, as I said earlier, these objects are not something like machines which were, let's say, designed by someone or invented by someone. These are part of our
like let's say natural number system, which is again based on how to count objects. So if there is no object, we'll say that number of objects is 0. If there is exactly one object, we'll give a number, associate the number to that set. Then the set becomes a set with one element. That's how the natural numbers have come into existence. And then there is a notion of taking product of natural numbers and also adding natural numbers to each other. And when you look at the products, then you realize that there are some special numbers which, as I said earlier, don't have any other factor other than that number and 1. And then that's how the word prime number has come. Prime is something like basic or let's say important in that sense. So another consequence of this fact is that if you take any positive integer, so I'll use the word natural number for such a positive integer, but we are not looking at 0 as a natural number. We are only looking at positive integers. And of course, we are not also looking at 1. So anything bigger than 1, you can always factorize into as a product of prime numbers. And that can be done in a unique fashion. So this was something, so this is, for example, known as, let's say, fundamental theorem of arithmetic. And then these kind of facts were first studied by Greek mathematicians long back, something like more than 2000 years back. Archimedes was one of the person who studied it. Euclid, whom you know more as a, let's say, father of geometry, he was another person who studied prime numbers with a great extent. Then people continued getting fascinated by prime numbers. Many important discoveries were made. And some of the connections of prime numbers with other areas of mathematics than algebra, they were visible more in the recent times, last 300 to 400 years. And again, I'll not mention each and every work, that's not possible in just a short time, but the main heroes of the story were very famous mathematicians, Euler, Fermat, Gauss, then Dirichlet. So these names are more familiar to the mathematics students, but not to a common man, a common person. But these people made a big contribution. So this was again some around, let's say, 16th, 17th, 18th, and 19th century. And in 20th century, of course, much more progress on connection of primes with other areas in mathematics has taken shape.
Great.
So historically, many important mathematicians have, let's say, worked with primes and have proved theorems about primes.
So primes have already always fascinated a lot of mathematicians, and they wanted to discover more and primes and also understand in detail why primes are so important and what's so special about prime numbers.
Yeah, I mean, that's a good question, and such a question is often asked about any concept in abstract mathematics, in particular about the concepts which are not obviously visible in our daily life. Right now, all of us are watching this video on some, let's say, website or something on the internet, and often we give our name and password to that website. And you should often wonder how your password gets, let's say, the password gets used. So the password is only known to one person and the one who has created it, but somehow that works in the system. So this thing needs something called, so in layman's term, called decoding and coding. And then there are various methods of coding something into a secret, let's say, secret language, which uses properties of prime numbers. So one very famous, let's say, use of prime numbers is this. So if you look at, let's say, two prime numbers, both are 11-digit long. And then any school kid will take, let's say, 2 seconds or 3 seconds to calculate the product of these two prime numbers on their pocket calculator. And if you have a computer, it might be even faster. But whatever happens, it's very fast process. On the other hand, suppose I just tell you that there's a big 22-digit number, and I tell you that it is product of two prime numbers. And then to know my password, you have to know those prime numbers individually. Then any thief will take much more longer time to, for example, calculate the factorization of this number and hence crack my password than actually, let's say, threatening me or killing me. So the actual mathematical way to, let's say, crack a password, it's much more difficult when it is based on this idea. Yeah. So somebody has to spend much more energy, money, and time to
crack it. So people will not try to do that. You see, the point is like password has to be safe. Even if the
Yes.
person is in danger, password has to be safe. That's how
Yes,
the
of course.
password is, right? And then
Yeah.
this is a mathematical, let's say, trick to
Wow, that's
make
really
it
nice
safe.
to know. And I think so, encryption, and especially in banks, like where you feel that your money has to be safe. When we use debit card also every time, I feel the same mechanism would be working, right?
Yeah. Except
So
nobody
it,
will know which mechanism is working. Otherwise, people will.
so yeah, I think there is a very popular branch of mathematics, cryptography, which is works on the similar lines, is there. And I think so, like our viewers can also try and understand what is cryptography more,
Sure.
and they also work on primes.
Yeah, and just to complete my answer, this is like the, let's say, one very basic day-to-day life experience where you indirectly use primes. But then the other one is more, let's say, more deep in the sense that the idea of prime numbers are, as I said, they're building blocks of integers. And often the theme in, let's say, some sort of arithmetic work is that you study the numbers by studying their prime factors. And then this idea is very prevalent in many other branches of science as well as in our life, that if you want to study a problem but can't study it directly, you try to break up into small parts and then study it. So this kind of theme of factorizing something into small parts has been in use at many places. So in that sense, one can think of this idea of prime numbers versus how a number get factorized into prime numbers. That idea is also, let's say, useful and relevant.
Okay, so that is really insightful actually. Thank you so much for briefing us why actually prime numbers are that important. And now I think most of our viewers would take interest into primes and know more about it. When I was discussing with you, you said that there are like infinitely many primes, right? And like we cannot go to infinity and check whether it is there or not. So how we can prove that there are infinitely many primes? It's really fascinating. What do you think?
So that's actually one of the important points, Shanti, you have raised, because often in mathematics, people think that the mathematicians compute things and calculate things and then get answers. That's how our school system works, right? You have to solve a math exam or math problem, you have to just calculate something and go ahead with it. But such a method won't give an answer. So for example, nobody is going to check all the numbers in the world, whether they're, and how many of them are primes, right? This will take forever. So this process will never stop. So there is no way one can check by calculation that there are finitely many primes or infinitely many primes. That's why one has to use some clever logical ideas to prove such a thing. So what I'm going to do is I'm going to give one proof, which is a slight variant of something which is well known. Okay, so some of you might have seen why there are infinitely many primes. So you might have seen that proof. So the history is that I talked about Euclid sometime back. So the Euclid was a mathematician who lived something around 2100 years back. And then he's supposed to have given the proof of this fact for the first time, that there are infinitely many primes. And I'm going to just now going to tell you some variant of that proof, and possibly another very different kind of proof, which uses a very different kind of mathematics. Okay. So basically the idea is this. So I'll talk about some idea called proof by contradiction. So suppose P1, P2 up to Pn are the only primes. That means there are only finitely many primes, n of them. N could be very large, we don't care. But there are only finitely many primes. What you do is that you look at the product of all of them. Okay, so you take P1 into P2 into P3 up to Pn. Again, as I said, n could be very large. In this proof, we don't have to know what is the value of little n. It could be 5, it could be 1 crore, whatever. Then you look at the number L minus 1. Now, what we know is that L minus 1 has a prime factor. because we know that every number has some prime factor. Okay, that's a property of prime numbers. By factor, I mean divisor. So some of you might be more familiar with that one. So you look at the L minus 1, it has a prime factor. And that prime factor has to be one of the PJ, because there are only those many prime factors involved. Okay, that's what we are assumed here. So whatever prime factor of L minus 1 you take, it has to be one of the PJs. So let's call it PJ. And now we are in very bad situation, because that means what? PJ is a factor of L as well as L minus 1. Okay. So what is happening? We know that L is a multiple of PJ. L minus 1 is also a multiple of PJ. How can that happen? Two consecutive numbers cannot be multiples of same prime number. So we got some absurd, definitely false thing, and then that's how a proof by contradiction works. So what does it mean? It means that our assumption is wrong, that there cannot be only finitely many primes, there have to be infinitely many of primes. So quick word, so the original proof of Euclid, which is more famous, uses L plus 1 and gives a slightly different argument. And this surprisingly cute argument was, I think, given by another mathematician called Kumar around 100 years back. So I learned about this very recently, so I thought I'll just present it.
Yeah.
Okay, so I think let's not go into the other proof in detail. I'll just say there are many proofs. One very famous proof is just something called Riemann zeta function, which was studied by Euler. And then Riemann zeta, the existence of Riemann zeta function itself says that there has to have to be infinitely many of primes. Otherwise, things will break down.
And you were also saying that the theorems and proofs are very, very important, and they are the base in which most of the mathematician works, right? So what exactly is a theorem? Like, what happens in the theorem, and how a mathematician proves? Because there are, what I have read is there are many things and many areas, especially as per prime numbers, where a lot of things are yet to be proved. So I think there is $1 million award also for a theorem if it is to be proved.
Yeah, I mean, this, as you said, proving theorems is a game that has been being played by mathematicians for last many thousand years, let's say. And this is part of the job. So it's like, for example, the artist will create a piece of art, and then they will be very proud of it. That way, the mathematicians who have proved, let's say, important theorems according to them, then they are often proud of it. And people, yeah, I mean, the mathematician is recognized by what sort of work they had done, not the kind of knowledge they gained, but the actual, let's say, creative work they had done. So as like for a layperson, theorem is some logical statement. So before one proves it, it may not be a true statement, but it is a logical statement. So it has to be either true or false. Otherwise, if it is a vague statement, then there is no way of proving or disproving it. And so a theorem in that sense could be any statement. So right now we saw a theorem saying that there are infinitely many primes. So it's either true or false, right? Either there are infinitely many primes or there are only finitely many primes. And then we saw, in fact, a proof which used this fact that if it is not true, it has to be false. And then how does one get a contradiction out of it? And a proof is something which is difficult to describe in short words, but very briefly, you start with some knowledge or some axioms or some hypothesis that you have. And based on that, you try to build a logical argument which should go something like this. This is true, hence this is true, hence this is true, and so on. Sometimes there might be more possibilities, like either this is true or this is true or both. So one has to consider all that logical sequence and then try to logically arrive at what you want to prove. Okay, so one cannot say that Earth is round, hence there are infinitely many primes. So both statements are true, but there is no logical relation between them. So that's not called a proof. Okay, even though both statements are supposed true.
Yeah, I don't know
Yes.
whether, I don't remember whether I said Earth is flat or round, but for some people, they can assume that Earth is flat. For them,
Yes.
it is a true statement. So you got the point. So both statements could be true according to a person, but then if there is no logical relation between them, it's still not a proof. And then, as Shanti, you said, there are many more interesting, let's say, let me not call it theorems because they're not yet proved. They are called
Yes.
conjectures. So that's the word mathematicians use for unproven theorems. And they might be false also. So we don't know whether they're false. So some claims have been falsified and then they are no longer called conjectures. So, but there are many unsolved, unproven statements, and then they go by the name conjectures. And let me just, since we're talking about prime numbers, let me just mention a couple of them. So one is very famous conjecture called Goldbach's conjecture. It says that if you take any even integer bigger than or equal to 4, then you can always write that as sum of two prime numbers. Okay, so you work with, let's say, 14. So 14 you can write as 7 plus 7. If you look at 28, then now it's a small exercise for you. You find out which two prime numbers add up to 28. People have checked for a lot of numbers. I don't know exact number, but lot of numbers using computer, and the kind of search has been going on. But there is no proof of this fact yet, and there is no counter example. What is counter example? Counter example will mean that come up with a even number which cannot be written as sum of two prime numbers.
Yes.
That also hasn't been found. But nobody has given a logical proof. Only computational evidence exists, not a proof. That's why it is not a solved problem. And then there have been many interesting developments in this subject which use techniques from other parts of mathematics and so on. And yeah, I mean, this is one of the very simple to state problems in mathematics, in my opinion, which hasn't been yet solved. The other related problem is, in case of prime numbers, is another famous conjecture that goes by the name twin prime conjecture. So twin, often we use the word twin for two objects which are identical. In this context, they are not identical, but they differ by 2. So for example, we can easily check that apart from 2, there is no even prime, because every even number is divisible by 2. So if an even number is bigger than 2, it cannot be a prime number. So all other prime numbers are odd numbers. And then you look at certain, so you observe that there are certain pairs of prime numbers which differ by 2. For example, 11 and 30. For example, 41 and 43. So you can find many such interesting pairs, and they are called twin primes. Now, again, a very similar question to what I showed as a proof some time back that has been also studied, that are there infinitely many such pairs?
Yes.
Okay. Again, the answer is not known. So people have been trying to find big and big primes where there are two consecutive odd numbers which are primes, but there is no proof yet that there are infinitely many such twin primes. Recent work has been something like this. So I'll again explain this in very broad terms. It's difficult to convey the importance of this type also to a layperson. But for example, we are asking for infinitely many pairs where the difference is 2. Okay. Question: are there infinitely many pairs such that difference is at most 10? Okay, you understand? So these kind of steps are also important in this result. And recent work has been, I think, so I may not be completely correct here, but the difference, so for example, it has been proved that there are infinitely many pairs where the difference is bounded by some number which is of the order 500 to 600. So, but this is, since 500 looks too big than 2, you will say that this is nothing. But then this is also important step, and it has only been achieved very recently. So that way, it might feel that we have a long way to go before we prove or disprove the twin prime conjecture. But you never know; some very genius technique might come which we have overlooked so far, and then we might get such a theorem. So that's the beauty of, I think, mathematics, and in particular these kind of objects where one can explain the problem very easily in one line to any person over a cup of coffee. And then, but the proof, nobody knows how it will come. So, there are many more such very important results. And
we don't know how important they are. That's also the beauty.
So conjecture is the base actually. So asking questions, thinking about something, what works, what doesn't work, and then proving it later. So this is very, very important for all of us to understand why questions are that important, why such statements are that important. We should encourage more students to ask questions, to think about various areas, various variables that are interacting, and how this can be led into various proofs. How we can prove, either we can prove by contradiction, or we can take help of some assumptions, some axioms, and then we can start proving some statements which are very important. In fact, in school syllabus also, there are theorems, and there are when we prove the theorems, it is said that there are certain things given, and from the given they have to take, and then they have to give logical statements. Either from earlier theorems they have to take something, and then they have to come to the conclusion that they have proved something. So this is really very interesting, this entire process. I feel mathematics is based on this entire process of theorems, proofs, and then finding out and thinking about something.
We know that, for example, if I give you a number, so suppose 4,322. So there is a number with those many digits. There is a prime number with those many digits. This can be deduced from such a theorem. So that way we know that there are infinitely many primes. Moreover, given any number, there is a prime number with those many digits. So that's already there. Now the question is how to find it. Okay, so now let's say how to find it, the easiest way or whatever, the brute force way is you check all the numbers of that magnitude and check which of them are primes. But that's a huge task. And then people are clever. They don't have to like do this all brute force. They have some more sophisticated tools and techniques using the both mathematical theory as well as computational, let's say computational techniques to check which numbers are prime and not. And then using sophisticated tools, they succeed in finding these big primes. And as you know, as you go more and more deeper into, let's say, bigger numbers, it's the number of primes also, let's say, proportion of the primes also gets smaller and smaller. So there are theorems of that type also. So that's why it's rare to get prime as you go along. And then that's why such discoveries are exciting. Okay, but they directly, so for example, having such a number with all those number of digits, that's not very directly relevant to, let's say, number theory or.
Okay, great. Thank you. And you were also saying something about existence and discovery. We feel that discovering a number is really very interesting, but it was already existed. So what is your take on it?
Yeah, means so it's basically what I said sometime back. So once we know the existence, maybe mathematician won't get excited by discovery of that thing. That's what my point was. But on the other hand, there are some other instances where discovering something which was unexpected has given, let's say, boost to some other theories. So again, there is something called, it will take a long time if I start talking a lot about it. But there were some more, let's say, more challenging and more famous theorem, unproved theorems in mathematics. One of them was called Fermat's last theorem. And the way people tried to prove Fermat's last theorem, that led to discoveries of many interesting phenomena. Though the theorem was proved only recently, like 30 years back, but many discoveries were made along the way, and then they gave boost to development of theory. So it's always not the case that discovery is not important, but in this case, my take is that once we know there are large and large primes, discovering then like to check that some number is prime and not, that's not so exciting for me.
Okay, great. So being a mathematician, and what is your inclination towards prime numbers? So what excites you, and what excites others also? For what is so exciting about prime numbers that mathematicians are often attracted to?
Yeah, I mean that is a very that's a very important question to ask. Like whatever mathematical concept one encounters, like why, like first question is why should common people care about that? That we already talked about some time back. But then mathematicians, they know about many more things in mathematics and why a particular concept is more exciting for them? That's a very good question, but also difficult to ask and very subjective. So I'll tell you my take on this. So, and of course, I know a little bit about how mathematicians think about various things. So in that sense, I'll give. So one very important aspect of prime numbers is that, so this is very much related to the modern way to look at geometry. So you compare the way you learn geometry in school, that you have a concept of, let's say, line or Cartesian plane, and then the basic objects in that plane were called points, and then everything was made up of points. So we can take this philosophy a little more seriously forward. The V meaning it has been already taken, but we can think in that way. And we can in fact think of points of a geometric space as analogs of primes, okay, or prime numbers. So this has been one of the very basic concept of modern geometry in the last 50 to 60 years. And then in that sense, one is unifying various concepts in number theory, algebra, and geometry. So that is one of the most exciting thing about prime numbers to me, that people have uniformly or in a unified way thought about, let's say, primes or points in space, etc. And taking the same analogy forward, you can think of integers defining functions on those geometric spaces. This is one aspect. The other aspect is more, let's say, also a little less known. So let me take this opportunity to talk about it. So there's a notion of distance that we look at. So for example, distance between 7 and 7.4 is 0.4, that kind of distance. So this is one way to measure distances. This is what we learn in school, and this is how we measure distances in our daily life. Abstractly, there are other ways to measure distances. And then the way prime numbers show up there is that for every prime number, there's a notion of distance. So mathematicians study something called p-adic numbers. Again, I'll not go into a lot of details here, but the idea is that everyone knows what are fractions. So that is our starting point, all the fractions. They're also called rational numbers in the technical language. From there, we study something called real numbers. Okay, so for example, square root 2, pi, e, all these are real numbers. They are not fractions. Now, a mathematician can, or anyone with a logical thinking, can ask the question, are there other distances which give rise to different kind of number systems? And then there is a notion of p-adic numbers, which say that for every prime number p, there is an analogous number system, which is not same as the real number system, but something else. And then this is also one of the very exciting feature in mathematics. Unfortunately, it is not taught at very basic level, but one can ask the question, why only real numbers? Why not all these other number systems? And then the mathematician definitely finds these things very exciting. And the third aspect is the actual arithmetic properties of prime numbers. So we talked about how infinitely many prime numbers, the proof that infinitely many prime exists can be also given in many directions. So there's a very important direction which goes into something called analytic number theory, which uses the ideas of calculus, limits, integration that we study in school, and how they are related to the arithmetic and numbers. So that is something, that is another place where the primes are very exciting. And then that gives rise to many interesting theorems. And that's why mathematicians are excited about prime numbers. And I'm sure other colleagues of mine and other fellow mathematicians will have their own, let's say, reasons for liking primes.
You discussed that why primes are so important. Our primes are so primed for mathematicians because there are so many questions, as you have said, that based on how the distribution of prime is, or based on some patterns if they are showing, or based on some relevance which we take it now for daily life, like cryptography and another encryption details. So these are the important areas where mathematicians are really interested in, and they want to study more primes and how they can be related, and they can be thought of various ways which will help in future in existence and development of human beings. So actually, I feel there is a lot more to be explored. The prime number story has no ending because there are infinitely many primes, and there will be infinitely many questions which we have to answer, especially pertaining to prime number. Thank you so much, Chandrashil, for being a part of this Science Day celebration of IISER Pune. And I would request all the audience also to keep track, because we have so many activities and so many talks of scientists, and the entire schedule is given in the description box. So I would encourage you to just have a look, and you can visit us anytime. And this is a way we are celebrating Science Day. Hope this mathematics session of prime numbers would really excite you, and from today you will think about most of the things as logically as Chandrashil has also encouraged us. So thank you so much, Chandrashil, and I hope all of you have enjoyed this session. Over to the next session.
LIGO India is a very exciting mega science project that promises to usher in a new kind of astronomy, that with gravitational waves.
We know gravity is everywhere. Strong gravity, weak gravity. But what is it? Gravity has been boggling physicists for a long time. We know from school textbooks that gravitational force is defined by Newton's laws of gravity, F equals g times m1 times m2 upon r square. Keeping this in mind, what if sun vanished all of a sudden? Then Earth would know that sun's gone before even we stop seeing its light. But is that right? We know nothing travels faster than the speed of light, which is 3 into 10 to the power 8 meters per second. So it would take a while for light to reach Earth from the sun. So it would be a while before even we knew sun was gone. Is that also the case with gravity? Newton never told us how gravity is transmitted. But Einstein came up with the theory of relativity, which is a theory of gravity that says space-time is curved. Space-time can be thought of like a rubber sheet. Placing something massive on the sheet will make it bend and cause curvature. Any less massive particle moving in the vicinity would experience a pull towards this particle. And that's how planets orbit around the sun. But wait a minute, this is all in 2 dimensions. How does it look in 3 dimensions? I came across this cool YouTube video which illustrates this the best. Let's take a look. So, gravity is a geometrical effect. Earth revolves around the sun because space-time around sun is curved. But how do we know all this is right? One of the consequences of Einstein's theory of relativity is the existence of gravitational waves. These are ripples in space-time caused by dense and massive objects like black holes that exist far away from us in the universe. As they reach Earth, these waves are of the size of 1/1000 the diameter of a proton. We never imagined that proton has dimensions, and here we are detecting something that's smaller than a proton. Let's see how this works.
Now, in order to understand what's going on in the cosmos, how various objects are interacting, there are telescopes which are existing to look at these objects, but you can only see when there is something to look at. For instance, if we look at the stars in the night, we can see the stars because there is light being emitted. But then if there are large objects which do not emit anything, and you want to know whether they are there or how they are behaving, one has to go beyond what we call as electromagnetic spectrum. Electromagnetic spectrum is something which extends from gamma rays down to millimeter waves, down to meter waves, in which a small portion of that is what we can see by eyes, which is the visible spectrum, and in the other spectra, there are other telescopes which operate in looking at the radio waves, or which operate at looking at infrared, or which operate at looking at X-rays. Now, if I want to look at objects which do not emit any of this electromagnetic radiation, what do? Einstein gave us a solution to that, and that was by looking at what are called as gravitational waves. Now, do I or can I look at what's going on in space? Say, for example, if there are big objects like dense objects like neutron stars or black holes, when they are colliding with each other or when they are going past each other, is it possible for us to see? Yes, it has been made possible to look at these objects by looking at these gravitational waves that reach our Earth. Now, how do I see that? Of course, if you just look at the numbers, you think that it's completely impossible. But then there is something that made us possible to invent things that can detect this. So, one such instrument that is used for detection of these gravitational waves, which was proposed initially, was what is called as a Michelson interferometer. Michelson interferometer is basically an interferometer based upon interference of light. So, you have a device where if there is a small change in length, there is a large change in an observable quantity. In a Michelson interferometer, it's the shift in fringes. So, Michelson interferometer consists of a light source. In this case, we have a helium neon laser. The beam goes into this beam splitter, splits it into two paths. One goes this way, one goes that way, but there is one part which goes outside. Now, same thing happens with the initial beam that goes onto this mirror, comes back, it again splits into two parts, and some portion goes on this part. So, there are two beams coming at the output port here which interfere and cause a bright and a dark fringe as shown on this screen. Now, if I change any little bit here, the fringes keep moving on this. So, this movement of fringes is caused because of the changes in the lengths. The light interference can be caused by a variety of factors. One is physical changes in the dimensions, which can be caused because of acoustic noise coupling to the table, or it could be atmospheric disturbance wherein the refractive index of air changes. Now, if you look on the screen here, there is something moving around. If I take away two beams which are coming back from two paths, there is no change in the intensity. However, if I make the two beams merge with each other, then there is an interference that is caused because of the addition of the amplitudes of the electric field of both beams. Now, let me show you something by inducing external noise, external sound into this interferometer. We will see that the fringes will rapidly move on the oscilloscope. As this sound is coupled to the table, to the Michelson interferometer, you can see the fringes change rapidly and they correspond to the acoustic noise that is being created on the table. So, this is a toy interferometer which is just is used for just demonstrating how the Michelson interferometer works like. But in the actual LIGO detector, this interferometer, as I told earlier, is about 4 kilometers long along one arm, and they are both placed at right angles to each other. Not only is the length very large, they also make the light beam go back and forth at least 200 times along each arm. Now, this is achieved by what are called as optical cavities, Fabry-Perot resonators. So, it's like having two mirrors and then you send in a light beam. This light beam reflects from first mirror, goes to the second one and comes back and bounces back and forth many times. Now, this is needed to enhance the sensitivity. As I said, the signal that you are seeing here is because of length changes in the range of microns, micrometers, because of the acoustic noise from the speaker coupling onto the table. The changes in the length is of order micrometers. But we are talking about distances lengths that change, which are about between several thousands to a millionth of a size of a proton. Now, to do that, one needs to take into account many factors. One has to stabilize the intensity, one has to stabilize the length of these cavities against any external disturbance like seismic noise or any other noise from the environment. One has to reduce the disturbances caused due to atmosphere by putting this entire thing under ultra high vacuum chambers. So this is what they do at LIGO, that these mirrors are actually suspended with thin glass wires, and actively acoustic noise and seismic noise is cancelled, so that this cavity remains ultra stable, ultra stable, and it is only sensitive to anything that comes from space and not sensitive to anything that happens on Earth. Now, one of the things that is also needed for this is, as I said, stabilizing the intensity and making the laser beam very clean. Clean meaning, when you look at the light on a piece of paper, a laser beam, it has got a lot of speckle noise and lot of spatial noise which keeps changing all the time. One of the things that goes into cleaning the shape of the laser beam is what is called as a mode cleaning cavities.
Hi again. Let's see what it means to clean a laser beam and how it works. Optical resonators or optical cavities are systems that confine light between smartly chosen mirrors and also allows for laser light power buildup. LIGO uses these optical cavities to stabilize lasers to unprecedented levels. What sits in front of me is a little pre-mode cleaner. It's a toy version of the pre-mode cleaner optical cavity that sits in the LIGO interferometer. Well, besides cleaning the shape of the laser beam, this optical cavity reduces associated laser power noise and also improves beam pointing fluctuation. All in all, what it does is improves the quality of the laser beam. Let's see how this works. Never forget to wear your goggles while using a high power laser. Light from the laser goes through an optical isolator, which prevents reflected and scattered light from going back into the laser. This is followed by a series of optical elements which are smartly chosen and meticulously placed. These help to steer and direct the beam into the optical cavity. Now, how does this stabilize a laser beam? A cascade of feedback circuits go into the system that locks the cavity to the laser. What you see here is a video of different modes of a laser beam. They are just different states of a laser beam, one more unstable than the other. The primary aim of the project is to transmit the most stable of all. As an undergraduate student, I intend to understand the working of the LIGO interferometer that exists in the US, Europe, and not to forget, soon in India.
I should mention, while there are other detectors coming up in Europe and Japan, LIGO India being on by construction very similar to the US ones brings in lots of advantages. You can see behind me is a picture of the LIGO India site, actual site terrain obtained from ISRO. Overlaid on that are actual rendition, 3D rendition of drawings that are sitting in the desks of engineers who have planned to set up this mammoth 4 km by 4 km arm massive facility. As you see, there are many areas of astronomy and fundamental physics that will be taken forward by LIGO India. We are going to make new steps in key areas of technology, starting from optics and quantum optics, lasers and control systems. You can be involved with LIGO India in many ways. So LIGO India provides platform for doing high-end absolute frontier science. Of course, we are looking for physics graduates who would follow up on the science. We are looking for computational experts who will tell us how to deal with the large data and make the best inferences out of it. We are looking for technology people who would maintain this facility and make further upgrades to the sensitivity. We are looking at the best experimental physics researchers, best engineers who will make sure that this facility is isolated from ground observations. This facility will also provide amazing seismological data for seismologists. Here is the central station. It has a building height of 20 meters, above 20 meters, and there are these pipes going out 4 kilometers on either side, which hold ultra high vacuum in a 1 meter sized beam tube, comparable to ones in the US LIGOs. But this has a volume of 10 million liters of space kept under ultra high vacuum. And then These are auxiliary facilities. This is where things are readied to be deployed inside the detector, and here's where scientists and engineers will sit. This is the main work office, and this is the support places. So all in all, a massive campus will be built around this facility. And why is this all happening? It's happening for you. The next generation is going to grow up and benefit from this completely state-of-the-art facility for science, and an opening a window into a new world that we will start seeing into the universe. Given the large number of areas that are involved in making a LIGO detector, it's not surprising that we involve people from multiple institutes. There are 4 lead institutes focused on making sure that this detector is up on ground. But there is a whole lot of institutions across the country, like more than a dozen, maybe 15 institutes, from where researchers are involved in the science, the science of the experimental setup, the science that we get from gravitational waves, the analysis of the data, and many more. So it is a national project that involves all the institutions. It invites people from all the institutions to come and take part in this. And we have made lots of progress since we finalized the site in 2016. There have been colleagues of mine who have actually scoured the country and looked at various promising sites, seismologically studied them. So there are seismologists who have been involved with LIGO India. And this site is in Maharashtra, turned out to be the most promising site from various ways. The search for this site is an exciting 5-year-long story in itself, starting all the way back in 2011 when I started leading this effort to look for an appropriate site, because that is a big challenge. You may not think so, but this site had very severe requirements. It had to be on ground that was stable, which means we could not be in the seismic areas of India, the least seismic areas. Then it had to be away from roads, railways, cities, people. Essentially, we did not want people. On the other hand, you can imagine a frontier facility like this banks on people to be around. So you have to make that compromise. How far and how remote should we be versus how quiet should we be? Luckily, the government officials have also agreed to keep that area a regulated urban development area, which ensures that noise levels will not rise, we will not have an airport next door, or we will not have a road passing right close to the, or railway passing close to the site. And every bit that we go forward and successfully do for this project will be huge challenges of that nature. Multiple years, multiple people, and very, very high-end challenges.
Hello everyone, thank you for joining us at IISER Pune for celebrating the National Science Day. Today, we hope to communicate some of the recent advances in sciences that have impacted our lives directly. And for that, we are in conversation with Professor Srivatsan from the Department of Chemistry at IISER Pune. His group works in the domain of chemical biology and mainly the nucleic acid chemistry. So thank you for joining us. We are very happy to have you here. To begin with, we would like to know more about your research. So what does nucleic acid chemistry research really mean?
Yeah, first of all, thank you for the invitation, and then I am very glad to be part of this program, and I would also like to appreciate the Science Activity Center and the Science Media Center for organizing this wonderful program on the National Science Day, and I am very glad to be part of this program. And coming back to your question on our research group's research interest, we are basically developing nucleic acid labeling platforms and probes to understand the structure and function of nucleic acid. I am sure the audience watching this program should be familiar about DNA, and as we know, DNA stores information and transfers information from one generation to another. It is not just DNA that stores and transfers genetic information. There is another molecule called RNA which also stores and transfers genetic information. Okay, for example, viruses like HIV and coronavirus store genetic information in RNA. Another important point I would like to bring here is that DNA, apart from forming classical double helical structure, can also adopt various other structures, and these structures are very important in controlling the protein expression levels in cells. So our group is concentrating on developing fluorescent, NMR and X-ray diffraction probes to understand the structure function relationship of mainly therapeutically relevant nucleic acid molecules.
So that's really interesting, and in last 1 year the DNA chemistry has played a huge role, especially in tackling the COVID-19 pandemic. And as the pandemic began, I think every nation tried to expedite testing to see if people are positive. And one of the techniques, the RT-PCR techniques, I think really relies on the DNA and RNA chemistry. Could you please walk us through some of these techniques that are used to detect the COVID-19?
Yeah, one of the things which you said is absolutely right. It is important to keep on testing, and testing is the way to control the spread. There are mainly two techniques which are used for testing coronavirus infection. One of the techniques is RT-qPCR, which is reverse transcriptase followed by quantitative PCR analysis, and the other technique is based on immunoassay, which relies on detecting antibodies which are raised upon exposure to the virus.
Right.
The RT-PCR technique is the gold standard technique because one could detect very low copies of the virus as compared to the antibody based testing, which requires a reasonable amount of antibody which has to be generated by the patient.
Right.
Okay. So per se, the immunorapid testing does not give information if the person is having infection or not, but then it is a good thing that if the antibody is there, the patient has responded to viral infection.
Agreed.
But then RT-PCR is the best technique, I would say, because you can detect the infection even at the early stage.
Right. So how does this technique function?
Okay. So I will walk you through the whole process of RT-qPCR technique, but then before that we should understand how the virus infects the human cells, and that will give an understanding of what we are actually detecting in RT-qPCR technique.
Right.
First we look at how coronavirus infects human cell. Coronavirus binds to certain receptors present in the human cell and it gets internalized. Once inside the cell, it breaks open and then releases the RNA, which actually has the genome information or genetic information of the virus. Now, this genomic RNA is converted into several of the viral specific proteins by using the host cell machinery, and these proteins are then packaged again to produce several of the viruses, which then gets outside the cell and starts infecting other cells. This way the coronavirus infects the cell and as well as uses the host cell machinery to propagate. Now, one can use the information present in the genomic RNA to develop diagnostic tool. In order to develop RT-qPCR based diagnostic system, one requires primers and probes which will specifically target the genomic RNA, and that we are going to look at it in detail. First we collect the swab, and from the swab we isolate the RNA by using a RNA isolation kit. Now, this RNA has to be converted into DNA, and then the DNA has to be amplified several times by using a reaction called polymerase chain reaction. In order to do this step of converting RNA into DNA and then further exponential enrichment by polymerase chain reaction, you need viral specific DNA primers. And once we amplify these DNA sequences, then you need a way to detect these amplified DNA sequence. For that, we use DNA probes. And finally, we interpret the fluorescence data and identify if the sample contains the virus or not. Okay. To confirm the infection, we need to detect the presence of 2 to 3 viral RNA genes. Based on the WHO recommendation, we usually detect E gene, N gene and RDRP, which are very important for the life cycle of the virus. Let us look at the steps involved in the RT-qPCR technique. Once we isolate the viral RNA, it has to be converted into cDNA, and this process is performed by a reaction called reverse transcription. This reaction uses an enzyme called reverse transcriptase, the monomer, dNTPs, and importantly a DNA primer. And this reaction essentially extends this primer depending on the code which is present in the viral RNA to produce the cDNA. Now, we have to amplify the cDNA by a process called polymerase chain reaction. Here what we do is that we use another primer . Next, what we do is that from this step cDNA to double stranded DNA, we keep repeating this step multiple times in presence of forward primer and a reverse primer to produce billions of copies of DNA. Essentially what we have done is that from one copy of RNA by polymerase chain reaction, we have created billions of copies of DNA, which essentially has the information stored in the RNA. This is in an exponential fashion. Now, to detect the amplified DNA, we use a fluorescent DNA probe, and I will show how it is done in a reaction. During each cycle itself, we start to detect the amplification process, and what happens is that the DNA probe binds to the viral cDNA. In this form, the fluorescence of this particular probe is very weak. It is actually practically there will not be any fluorescence. That is because we have a quencher and a fluorophore due to interaction. Okay. So, what happens is that the fluorescence of this probe is very weak. Now, what happens is that during the extension time, the DNA polymerase extends till this point, and then it encounters this DNA probe, and hence it cannot extend further, but then this DNA polymerase has a unique property of breaking this probe DNA into pieces like this. So, what happens is that the DNA probe is broken down into pieces, and then it further extends to form a double stranded DNA. Okay. In this process, what happens is that the quencher and fluorophore are separated, and hence this leads to enhancement in fluorescence intensity or increase in fluorescence intensity. This increase in fluorescence intensity will depend on the amount of DNA present in the system. So, what happens is that as you amplify by PCR cycle, what will happen is that if the viral RNA is present, which is converted into viral DNA, and it keeps on amplifying, then what should happen is that you should get an incremental or progressive increase in fluorescence intensity. Okay. So, a typical RT-qPCR fluorescence data would look like this, and based on the cycle threshold, one could determine the infection. This is the complete workflow of detection of coronavirus by RT-qPCR technique.
So, these primers or the fluorescently labeled probes that are used in RT-qPCR how are they typically manufactured?
The oligonucleotide primers and probes required for RT-qPCR testing is essentially made on a DNA synthesizer. My students will now explain how this technique works and what is the chemistry which is involved in this whole process of synthesis of primers and probes and how RT-qPCR works.
That's great. So let's go to his lab and really see how these primers are made.
DNA is a polymer made up of deoxyribonucleic, deoxyadenosine, thymidine and cytidine. These nucleobases are connected via phosphodiester linkage in the DNA. Now let us consider DNA as a necklace which consists 4 different colored beads which are connected in the string which like a phosphodiester linkage. This DNA necklace can be synthesized by using simple cycles which consist simple chemical reactions. In the first step, the protecting group on the nucleobase is removed. Further, the free hydroxyl group is reacted with the upcoming other nucleobase to get the dinucleotide which consists trivalent phosphorus. Further, this trivalent phosphorus is converted into the pentavalent phosphorus by using oxidation process. In the next step, again the protecting group is removed and then further the hydroxyl group is reacted with the another third nucleobase to get the trinucleotide. Now in the similar way, the whole process is repeated to get the desired DNA oligonucleotide sequence. Now let us see how this DNA necklace can be synthesized by using DNA synthesizer instrument. So these are the building blocks which we have attached here like A, G, C, T and the other reagents which required from the coupling reactions like deprotecting agent, coupling agent and the oxidizer. We feed the desired DNA sequence in the instrument which can be further sent to the DNA synthesizer. Now depending upon the DNA sequence, the building blocks like A, G, C, T will transfer into the reaction vessels and which the cycle which I explained earlier, depending upon that the deprotecting agent, coupling agent and oxidizing agent will transfer to the reaction. Now in this way we will get a desired DNA oligonucleotide sequence. Using same cycle, we can also synthesize a fluorescent DNA oligonucleotide. Here we have other port where we can keep the modified nucleobase monomer and the cycle which I explained earlier, one can get probe which have fluorescent modification and the primers for RT-PCR. Now once we get the desired DNA oligonucleotide sequence, we purify this DNA oligonucleotide by using gel electrophoresis. Further, the purity and the identity of this DNA confirmed by using further instrumental analysis.
So now let us see how gel electrophoresis apparatus can be used for purifying DNA oligonucleotides. The gel electrophoresis method is a method to purify or separate biomacromolecules such as DNA, RNA, protein based on their size and charges. Here we use polyacromide gel as a medium to separate. First what we do is that we load the DNA onto the polyacromide gel electrophoresis apparatus, and as we know DNA is negatively charged. When we apply a negative potential, what would happen is that due to charge repulsion, the DNA would move along the gel matrix and because of the size they would get separated. Now what we do is that we remove the gel and then we visualize using a certain technique and identify the desired band, we cut it out and extract it in a buffer. Now we have the DNA purified and this purified DNA will be tested for its purity by using high performance liquid chromatography technique.
So thank you for explaining the process of RT-qPCR and the science behind it. I can imagine that as the pandemic started, for a country like India that has huge population, especially indigenizing the process of making these diagnostic kits was a very important process.
Yeah, you're absolutely right. It is very important to indigenize these diagnostic kits if we have to become Atmanirbhar. The main components of RT-qPCR, I would say, is the RNA isolation system or isolation kit, the monomers which are necessary for the primer synthesis, DNA primers, fluorescent probes, DNTPs and enzymes, most of these components of the RT-qPCR technique is actually purchased from foreign vendors. And since several of the countries are testing in a humongous scale, it becomes necessary that we make our own kit in India. And if these diagnostics can be wholly made in India, then two things can happen. One is that the accessibility will be fast, and also we would dramatically reduce the cost of the testing kits.
Definitely. So, I completely agree with your view of becoming more Atmanirbhar, and in that regards your lab has played a very important role in indigenizing this process. So, we would also like to know more about that.
The Center for Cellular and Molecular Diagnostics, situated in Bangalore, has recently launched a project called Indigenization of Diagnostic. It is called the INDEX program, and this INDEX program is funded by Rockefeller Foundation, United States. This INDEX project aims to actually have a very good supply chain of Indian companies which are actually making reagents and enzymes for COVID diagnostic kit. IISER Pune is one of the centers of excellence in this program, and we are mainly dealing with the chemistry aspects of this diagnostic kits. Wow. And I am heading this center, and what we do is that we give an end-to-end chemical characterization and functional characterization of the chemical components which go into making RT-qPCR diagnostic kit, such as the monomers, the primers, probes, DNTPs. Okay. In this way, we help the companies to actually maintain the very high standards which are required for diagnostic kit development.
Right, because you don't want false negatives and false positives. That's something that most of us are worried about, especially while
definitely we need to have very high standards of these diagnostic kits, because I told you, like the RNA is the one which is very important in this diagnosis process, and RNA is not very stable.
Right.
So we need to have reagents which are RNase and nuclease free, so that we avoid false negative or false positive results.
That's great, and we really wish you all the best in this journey to make these kits indigenized, and hope to see a completely indigenized kit very soon.
Yeah, through this INDEX program, we would like to we aim to actually produce 1 million kit per day.
So it would be great to see that happen, and I was just wondering if these probes, the fluorescent probes that you were talking about, can they be used for other diagnostic tests or?
Sure. Per se, RT-qPCR technique is a very general technique, and it can be used for detecting other pathogens or viruses. Wow. You have to just change the primer sequence and the probe sequence, which will be specific for that particular viral genome, and then you can develop diagnostic kits. So becoming self-sufficient is going to really be helpful, and this could really help our healthcare system.
So that's really great to hear, and in a way developing these testing kits or indigenizing them will really make our healthcare system future proof. So that's wonderful to hear. We would love to hear more from you, but the time is short, so we would like to ask you one last question, which is any message to our viewers for or on the occasion of this National Science Day. Would you like to communicate something to our viewers?
Sure. In my opinion, education and healthcare system is the backbone of any progressive nation. As the proverb goes, a sound mind is in a sound body, meaning a healthy body with a mind capable of positive, good and free thinking is very important. Right. And this also happens to be the theme of the National Science Day 2021, which says that science, technology and innovation and its impact on education, work and skills. Right. And so what I would like to say to the young colleagues and teachers is that have a good scientific temper and think rationally, and it is going to happen that certain phenomena and certain questions may not be readily answerable at this time, right. But then that is what a science is. Okay, so we have to search for it, right. And then you would with a sound mind and sound body, I think you should be able to answer those questions in future.
Right. So science is ever evolving.
Exactly.
And we should keep practicing it.
And finally, I would also like to add my thoughts on women in science. For quite some time, their representation was very low, but now I think it is getting much better. For example, I have 12 students and 8 are girls actually. That's very good. I would encourage women to take science as a career option, and if they can become part of the mainstream science and technology initiatives, that will greatly help our society.
Definitely. So thank you for that great message, and thank you for being here. It was great to talk to you. Thank you so much.
And it's my pleasure to be part of this program. Thank you.
Good afternoon. Our next session is very interesting, and that is about the current topic COVID-19 and its vaccine. For this, we have with us very special guest, Dr. Vinita Bal. Dr. Bal currently is visiting faculty, member of the biology department at IISER Pune. She is a medical doctor and an MD by education, who then took up the research in basic sciences. After initial training in immunology at Haffpin Institute, Mumbai, and in London, Dr. Bal worked as a scientist at the National Institute of Immunology in New Delhi for more than 25 years. With her vast experience in the field of immunology, there is no any better person to talk about this important topic on the occasion of the National Science Day. Today's topic is mainly about the discussion of the common questions asked by the student and the teacher about the COVID-19 and about its vaccine. So without any further delay, I am requesting Dr. Bal and Dr. Apurva Asim, please start your session.
A very warm welcome, Dr. Bal. Let us get on with straight away with the first question. I think the most basic question that all of us have in our minds is, what exactly is a vaccine? What does it have? And is it like a medicine? Can it cure a disease?
Well, vaccine can be considered as a medicine, but normally the way one would think of defining vaccine is a product. So if say we want to have a malaria vaccine, then something which is either killed malarial parasite or some part of the malarial parasite, so that gets used for artificially for immunizing in individuals, and then that immunization results in an immune response. This immune response is supposed to protect against the original disease for which we are creating this vaccine. In this case, as an example, malaria. So vaccines are normally supposed to provide protection against the specific disease. So if we are going to look at COVID-19, because we are in the pandemic, again, SARS-CoV-2 is a virus, and either some part of the virus or killed virus are being used for immunization, and those are the ones which are vaccines which of a variety of kind. and companies have tested them, and many of them are declared safe and effective. So essentially, the vaccine would contain either a killed organism, microorganism, or a component of it, so that the protein of interest will be generated in the body and there will be an immune response. But the difference is that vaccines are not supposed to cure a disease. Vaccines are supposed to normally prevent the disease. So if we take vaccine, we want an assurance, for example, for COVID-19, that the current vaccines should prevent occurrence of, especially of serious COVID-19 disease. That's the idea about vaccine. So that's why I said it's quote unquote medicine, but it is not a preventive medicine. I'm sorry, it is a preventive medicine. It is not a treating medicine.
How these pharmaceutical companies normally produce this vaccine? And sort of how long does it take to make one vaccine against a disease?
Sure. So when people conceive of making a vaccine, what we need to understand is what part of that virus, for example, let's just stick to virus because it's easier to explain taking an example, but what part of the virus is responsible for gaining entry into the human beings and subsequently replicate in the human body to cause further disease. So the entry point is an important point. So if there is a particular viral protein which is responsible for entry into the human host, such as in this particular case, if you may have heard, ACE2 protein on human cells is supposed to be a receptor for virus entry. So everybody, once that was identified, everybody who vaccine manufacturers thought that that is the great target for the vaccine generation. So most of the vaccines, there are some mRNA-based vaccines, there are some protein-based vaccines. All of them are interested in that part of the virus which is responsible for entry. So this is called a spike protein, and a smaller portion of that is called receptor binding domain, or RBD. So most of the vaccines consist of strategies which will make this RBD or spike protein following immunization in the human host, and would start, as a result, human host will start responding to the protein. That's how the process is. And sometimes, as I said, killed viruses are also used for immunization, in which case it's not just single protein, but it would be multiple proteins from the virus which will be available for generating immune response. The peculiarity for COVID-19 is that in less than a year from the beginning of the pandemic, a vaccine actually became available. And this has been phenomenally remarkable. It is not surprising, but it is still remarkable, because the history of vaccines that we know of, something like, triple vaccine that many of us do take, or the BCG vaccine, which is meant to prevent tuberculosis and so on, all of them historically took a long time to develop, took a long time to demonstrate that they are effective, and so on and so forth. So normal duration over which vaccines used to get developed was, say, 5 to 10 years. And that long duration, it had also issues such as looking for safety of the vaccine, efficacy of the vaccine. Maybe we'll talk about that. But this time, because it was pandemic and because it was involving so many people all over the world, especially the developed world, the vaccine got developed with a serious urgency. And that is why we have vaccine at the end of 1 year. So it is certainly a safe vaccine. That we know, because people have tested that. There is no compromise in testing for the safety. But is this as good or great, or is this the best vaccine that we can have? The primary reason why we want to take vaccine is to provide protection for a long period. So some of you who are old enough to remember smallpox vaccination, we used to go every 5 years to take a booster. So 5 years was the duration of protection for the smallpox vaccine. Here, that duration has not been tested, because if the vaccine itself has taken 6 or 8 months to develop and test, there isn't a 5-year period involved for follow-up. So that is the major limitation. So it is a safe vaccine. It is likely, and that likely word should be underlined, likely to provide long-term protection. We don't have an answer for that, but that is the bit of a compromise as far as the current vaccines are concerned. So I would like to emphasize that the older vaccines, meaning say pneumococcal vaccine or BCG or triple vaccine, we also know of course of tetanus toxoid vaccine, all of these were tested for their safety in a similar fashion. So what was happening was that vaccine development goes through at least 3 phases of clinical trial, which is phase 1, phase 2, and phase 3. Most people in the past used to do it sequentially, meaning do the phase 1 first, see the results, then go for phase 2, and then go for phase 3, because nobody was looking for an urgent vaccine development. Here, because of that urgency, people have actually done overlapping processing. So while phase 1 was happening, they were starting with phase 2. While phase 2 data were coming in, the people were starting testing for phase 3, and so on and so forth. So the safety is not a problem. That has been tested. But as I tried to highlight, because this vaccine was tested after individuals were followed up only for 3 months or 3 months or so. What we know is that vaccine will give protection for about 3 months. As we are progressing in terms of vaccination, we will know how long the protection would last. So that is certainly a question mark, but it is not a reason why we should be wary about the safety of the vaccine. So it needs to be stated that that is a critical point that that people should understand, and vaccines do provide protection, and hence one should actually go ahead and get vaccine as and when they become available.
So it's not that any steps have been skipped or missed. It's just that they have been collapsed and sort of other processes have been sped up to make the process shorter.
Quite right. So that is the major point. And as I said, because of the technologies and because of the global need, there were many companies. There are more than 200 or maybe by now 300 different efforts which started long back. And we already have 5 or 6 vaccines which are in use. The only point that people have, I should also mention, is that these are called as emergency approval of the vaccine. That is precisely the point I was highlighting, that the duration of protection has been, or efficacy as it is called, has been evaluated only for a short period. And because it's a pandemic condition, under certain guidance or under certain guidelines, the vaccines have been approved. So that emergency use approval will eventually, this label will go off when there are adequate results of the clinical trial. It will go off, but it hasn't gone off yet.
The question that normally everybody thinks about is that, so we are injecting a virus inside us to develop immunity, which we call as vaccine. So with that respect, how safe it is what safety measures are taken to make sure that there is no infection, but there is immunity?
Correct. So that is normally the principle, but I must say that the virus that causes disease like COVID-19 is certainly risky affair. So if somebody is feeling like, I can, in whichever fashion, I can isolate SARS-CoV-2 virus and inject it in myself, that's a disastrous state to think of. So that disastrous in the sense there will be infection, COVID-19 disease, all of that will happen. But what is ensured when the vaccines are approved for mass use, as we have been seeing, is that that vaccine would not cause the infection and disease the way we understand it. So it can be a killed virus, in which case it will have all the proteins that are part of it, but a virus cannot replicate. If it is a component of the protein, as I was mentioning earlier, the spike protein or the receptor binding domain, the virus will not be generated in the body because there is only one protein of the virus which is being injected. So for virus to replicate itself, all the proteins which are part of nucleic acid replication assembly are required. There is membrane that is required. All of that is the case. So the vaccines are designed in such a fashion that the infection will not happen. And there are, I should also point out that there are some vaccines which we use, such as BCG vaccine, which is for tuberculosis. So it is a sort of a bacterium which is similar to tuberculosis bacterium, but there is a guarantee that it will not cause pathology as in disease. That is ensured, and that is why I said in the past there were these extensive long duration testing procedures which were followed. Especially that is the case for what I was describing, BCG, as live attenuated vaccine. None of the COVID-19 vaccines that are currently in use are or are in the process of development are live attenuated. So they are just components of the virus or killed virus. Hence, no infection and no disease, but immune response. That's it. That's the critical point.
So following on this discussion so far is, can we say that should everyone take the COVID-19 vaccine? How many doses? How does one decide how many doses to take? And what about side effects? Once we know that the vaccine is effective, there are all these other questions that people have in their minds.
That is true. And when I said safety, the side effects is what I was partly referring to. So most vaccines, including if anybody remembers, they themselves or more commonly their kids getting vaccinated for triple or pentavalent vaccine or other vaccines, normally kids also develop a little bit of fever. There is injection site pain and so on and so forth. These common side effects are also there with all COVID-19 vaccines. There is no escaping. Some people will have a little more, some people will have a little less. The serious anaphylactic reaction, meaning shock-like reactions, are rare, but people are allergic. So even without vaccine, some people go into anaphylactic shock. So it's not necessarily the case that vaccines will cause anaphylactic shocks much over at a frequency much over and above what is seen in the population. So in that sense, those reactions are critical, but you must have heard that currently vaccines are provided in hospital settings or wherever there is a doctor available, and the people who get vaccinated are asked to stay back for about half an hour and then let go. So that observation period is essentially to say that even if there are some urgent, immediate side effects, the doctor and the team there should be able to handle that. It is not happening at a frequency which is really worrisome. So that is for sure. And how many doses is determined by the way the clinical trials are designed. So traditionally, most vaccines are given as 2 or 3 doses. If you remember good old triple vaccine, which was for diphtheria, tetanus, and pertussis, the whooping cough, though that used to be given and even today is given as 3 doses 6 weeks apart to kids. But you also must have heard that polio, when we were trying to eradicate polio from India, there were once in a month for months on end polio Ravivar campaign. So I don't know how many doses were given. So it depends on how effective the vaccine is once it goes into the field, and if people are using it, what is the response that they see. But for COVID vaccines, most of the COVID vaccines, certainly the 2 that we have in India, emergency, which are distributed under emergency use. One is Covishield, the other is Covaxin. Both of them are supposed to get 2 doses. So what happens is first dose is given, immune response is sort of triggered, and when the booster is given, though that first round of immune response gets further expanded because you are providing another boost. They are actually called as booster. Primary shot and a booster shot. It is to boost your immunity further. And that's why I said most commonly 2 shots are given. And theoretically, if you ask me, Covaxin, one of the so-called Indian vaccine, hasn't completed its phase 3 trials. So we do not know a lot about how effective it is. Covishield, which is manufactured by Serum Institute, and Covaxin is manufactured by Bharat Biotech. But Covishield, manufactured by Serum Institute, has been documented to show between 50 to 90% protection. So that is certainly worth taking. And it's also currently available in very many doses because Serum Institute is one of the big manufacturers. But Bharat Biotech is also gearing up. It will also have its own vaccine, this Covaxin. And once it is declared as showing a certain proportion of efficacy, there is no harm in taking either of those vaccines by anybody practically. So if, for example, if somebody is really undergoing cancer chemotherapy, at that time, or radiation, at that time, the body is heavily compromised for immune response. The immunotherapy or the chemotherapy actually dampens immune cells. Such situations should be avoided. So physicians, doctors should be consulted. There are some contraindications for the vaccine, but general healthy people, including those above the age of 60 years, should not be worrying too much about it. But as I said, there should be, if you have diabetes, don't go there when diabetes is completely uncontrolled. If you are on treatment for diabetes with medication, there is mostly no problem. So it is a safe vaccine. It is likely, both vaccines are likely to give protection. So everybody who can have access should actually take it.
So that also means that when someone develops a mild fever or some reaction, it means the body is responding to the vaccine, the injected virus, right? So which is a good thing in a way.
Yes, but I should also warn that some people have more tolerance to fever and they will not complain. So if you do not have you do not have fever, or if you do not have pain, that doesn't mean that you are not responding. Correct. But if you have a reaction, then that means what we describe as inflammation, that is setting up. Fever is one indication of that. So that's fine too. So either way, because otherwise people suddenly get worried that, oh, I didn't have anything. Does that mean I'm not responding? That's not the case.
Right. Okay. Dr. Bal, we also now hear about the various strains of this virus. So there is one UK strain, or there is South African strain, and new strains will come up over time perhaps. So the vaccination that we are sort of developing now and taking now, will this vaccine also help us resist or develop immunity against these strains?
Yes and no is the answer. The reason I will explain. The UK strain had just one mutation in the virus. And as you know, most people don't really realize this, those who do not work in the area of science or microbiology. But viruses are continuously mutating. As they divide, they continue mutating. Some mutants create problems, many others do not create problems. So UK mutant had only one major mutation, because of which its ability to spread increased. But because it was only one mutation, all the antibodies that are generated by the vaccination were capable of handling it extremely efficiently, 90% or more. But the so-called South African strain or the Brazilian strain, they have many more 6, 7, 8, 9 mutations. And what does that mean? That you have such a shape of a virus. And say UK one was where one finger I'm holding, so only that much of mutation, and which means the rest of the shape is completely similar to the original. So the antibodies which are directed against all of these shapes, they are capable of responding, and one that doesn't need to worry about it. But in contrast, if you have not just one finger, but another finger here and another finger here, so if the shape changes so drastically, then you will realize that, say there were 15 different antibodies which were binding to all these portions, and now there are only 3 portions left. If that is the case, then the antibody efficacy will go down, which is something that can happen. And both a South African strain and Brazilian strain, because they have many more mutations, this is a clear possibility. We have preliminary data with some vaccines that despite that, the current vaccines would provide protection. But if these mutations go sort of, I should say out of hand, but if they continue further, then there might be a strategy required where a booster with these modified mutations will have to be given. So protein has a certain sequence out of which 1, 2, and 3 have changed. So you replace it with the mutation sequence and then use that protein for vaccination. That's a strategy that people have been thinking of, but it's not something that's just around the corner. It will take its own time to develop. Until then, vaccinating as many people as you can, as rapidly as you can, is one way of thinking that we will probably have better protection as a community.
So then what about people who have already contracted COVID? Is it necessary for people who have recovered from COVID-19 to take the vaccine? And if yes, why is that so? And which type of immunity will last longer? The one which is developed by taking a vaccine, or the one that is developed by combating an infection of COVID, of the virus?
This is for this question, one has to remember that the pandemic is only 1 year long, and the virus is also has been around only for a year and maybe 3 months or 4 months. So whether on the long term this virus infection would provide protection or not, we have data only for 12 months. We don't have data for a longer period. So it's logically difficult for me to say that the infection is likely to provide longer protection. I have no idea. Nobody has a very clear idea in the absence of data. It's a very peculiar situation that we are in. Same is the case with the vaccine. That vaccination has started being tested for last 6 months. So we know that probably for 6 months, the immune response will provide protection. But how long? Nobody has a clear answer. Based on the wisdom that we have acquired with other viral infections, most viral infections, not all, but most viral infections do provide, relatively speaking, long-lasting protection. So one can think that maybe this virus will fall into the same category, unless it is like a flu virus, which keeps having major mutations and major changes in its structure and hence can cause problems. We will know only with time. It's not that we can actually give a very, very clear answer to this question. But if somebody is infected and recovered, one shot of vaccine would essentially be a booster. What I said earlier was that primary dose and a booster is the strategy. Infection followed by one shot of vaccine can also function in a very similar fashion. So that will provide for longer lasting immunity. So it's worthwhile if you have access to take at least one shot, if not two, post-infection.
Right. One more term that we hear is herd immunity regarding the pandemic. So can you just explain what exactly is herd immunity and how it is connected with vaccination that we are talking about?
Yeah. So this epidemic has made phrase herd immunity very, very popular. So it has really come into newspapers. Everybody wants to know whether we have herd immunity, we have achieved it or not. But it is something that is very hard to provide an answer for, because normally so far herd immunity was seen and speculated about, but based on past experience, in the sense that if over the past 5 years an epidemic has come and gone and something, look at those data and now you can say, okay, herd immunity was achieved, or that herd immunity was not achieved. Again, we can't say that so effectively for the current epidemic, but herd immunity, what herd immunity means is that one has to start looking at not just individual immunity, but immunity which is present in a community of the people. Instead of herd, many people feel very offended by the word herd, saying, are we animals? We are animals actually, but because human being is also an animal. It is not that it's an inappropriate word, but it feels politically incorrect. So community immunity, if you want to call it a community immunity, within that community, 100% people do not need to have antibodies for the given virus or immune response to the given virus. But if there is a large fraction which already has protection either because of infection or because of vaccination. It can be both which will contribute. But if that happens to be the case, then the remaining people, maybe 5%, maybe 10%, maybe 30%, and that will vary depending on the kind of virus, its ability to transmit itself, and so on. So the remaining people who are not exposed, who do not have immunity for that particular virus, would also receive indirect protection because of the herd around them. But if these individuals who do not have immunity, if they move out of that herd and go somewhere else, then they are equally vulnerable, because if people around the new situation do not have immune people, then they are as vulnerable to virus infection as it could be. So it's a sort of a situation which is defined depending on who is around you, what is the population and a group around you. That is why it is called herd immunity. But even for this virus, we do not know whether 80% is good enough, and 80% in India, 80% in Pune, 80% in ISER community. So you do need to define how small or how large your community is based on the data that you have. We don't have such extensive, thorough, deep data, as one would call it, for the country, because we don't have that kind of infrastructure. But if there are certain areas in Pune, for example, since we are in ISER Pune, see, there are areas in Pune, in localities where there has been extensive spread of the virus earlier, then those communities might have developed herd immunity, but we don't have data. So herd immunity is a good measure to predict about future vaccination strategies and so on. Herd immunities will help in designing future strategies, but you do need to have solid data for it. And an evolving epidemic does not give you solid data for arriving at such conclusions.
So another very, very sort of burning question that people have in their minds right now is there are so many vaccines being developed in India as well as abroad. In India, we currently see that there are 2 vaccines in use, as you mentioned, Covishield and Covaxin. Which one, out of multiple vaccines in India and abroad that are available, which one should we take?
Whichever you can get hold of. I think most of them, all of them are as safe as any other vaccine which is coming out or will come out in the next few weeks and months. So safety is not an issue. There can be an issue of whether vaccine X is providing 80% protection or 80% efficacy or 60% efficacy, but there is also an issue. So you may want to choose based on that, but that 60% is, you have to remember that it is not 100%. So whether you fall into 60 category or 40 category is something that nobody can predict. So, but at the same time, if everybody around you, since we just discussed about herd immunity, if everybody around you gets vaccinated, and if 60 or 80% of the people are protected, then even if you do not fall into that 60 or 80%, but in the 40 or 20%, you will get protection. So in that sense, whichever vaccine is available, whatever is the schedule recommended, people should go ahead and have it, except where there are medical conditions which will be contraindications.
What care one should take until they get the vaccine or once they get the vaccine also?
Yeah, here I'm going to simply say two things, not so simply, but we have been wearing masks, we have been forced to wear masks, and I think that strategy should continue. The physical distancing that has been practiced should continue. And one more thing that people have been saying that, look, I was vaccinated, so I'm protected, why should I wear a mask? That is not a safe attitude, because the vaccines do not provide protection from infection, but they provide protection from disease. Disease is illness. So if there is, for example, I'm vaccinated, but somebody sneezes on me extensively who is carrying of the virus, then the virus will go in. The receptor in my body is still there. So the virus will gain foothold, but that foothold will not be solid enough, because soon after that, my immune system, because it has been already primed, it will start attacking the virus to clear it. That is the distinction. Did I get the infection? Yes. Did I get the disease? No. That distinction between infection and disease is because of prior immunity, either because of earlier infection or because of earlier vaccination. So in the early stage, when I have infection, but I am vaccinated, if I reciprocate to somebody else sneezing, then again, I can actually spread the infection. So for both ways, not that somebody else should not give me infection and I should not give infection, though neither of us will fall ill if both of us are vaccinated, but still it will be a minor problem here and there. To prevent that kind of viral transmission, we do need to take care of wearing masks. And in that sense, these vaccines that we are currently available are not, I'll use a little bit of jargon here, they are not transmission blocking vaccines. They are disease blocking vaccines. So transmission may happen, infection may happen, but disease is unlikely to happen with the current set of vaccines. So that we do need to take care of by wearing masks. If you're sitting alone, like I am, you are right now, of course we are not wearing it, but if I meet you physically, I will have to wear one.
So I hope this discussion has answered many of your questions about COVID-19 vaccines, and please stay tuned for the further lineup of programs that we have planned for you today on Science Day. Thank you.
Hello everyone, and welcome to this ToyFest 2021 interactive session on the occasion of National Science Day celebration. So we have here participants from all over the India, and let me have an opportunity to introduce this ToyFest event. So I'll quickly start introducing myself. So myself is Sankesh Tirpude. I am a science communicator at IISER Pune Science Activity Center. About Science Activity Center IISER Pune, it's in Pune district of Maharashtra. And we at Science Activity Center are engaged in developing low-cost interactive science toys that can be used to teach science and mathematics in more engaging and hands-on way. And the main objective is to strengthen the teaching and learning of science and mathematics by use of the simple toys and hands-on activities. So here we also generate some resource material for teachers to improving their conceptual understanding of topic from curriculum. So from 2017, we are here we have conducted many workshops, demonstrations, hands-on sessions, and Toy Fest is one among them. So on 8th February 2021, we have announced this event and we have sent nearly 10,000 schools all over the India. And as a response, we have received a total of 1901 registrations. However, a total of 327 project submissions were received for this event. This event has a two category: submissions of science and maths projects where students, it's a student category where we have received total 249 participations from all over the India from respective schools. And the second category was in educational aid model where teachers have participated and submitted. Nearly 62 teachers have participated and submitted their models. However, we have selected some exciting and novel ideas to present on the occasion of National Science Day. So without further ado, let's start the session. So I would like to request Vasant Ramaji Nehe to present the toy and share his ideas on this interactive platform. Sir.
मी तयार केलेल्या साहित्याचं नाव आहे अध्ययन अध्यापन उपयुक्त शैक्षणिक साहित्य. इयत्ता 8वी, इयत्ता 9वी आणि इयत्ता 10वीच्या अभ्यासक्रमामध्ये महत्तमापन हा विषय आहे. यामध्ये क्यूब, त्याचप्रमाणे सिलेंडर, क्युबॉइड, कोन या भौमितिक त्रिमितीय आकृत्यांचं पृष्ठफळ आणि घनफळ कशा पद्धतीनं काढायचं यासाठी मी एक शैक्षणिक साहित्य तयार केलेलं आहे. यामध्ये घनाकृती जी आहे तिचं पृष्ठफळ काढण्यासाठी हे एक शैक्षणिक साहित्य तयार केलं आहे. यामध्ये जे साहित्य वापरलेलं आहे त्यात प्लास्टिकचा कागद, त्याचप्रमाणे कार्डबोर्ड यावरती घनाकृतीची पहिल्यांदा कापल्यानंतर कशा प्रकारे आकृती तयार होईल हे दाखवलेलं आहे. आणि ही अशा पद्धतीनं फोल्डिंग केल्यानंतर ही घनाकृती तयार होईल. मग या घनाकृतीचे 6 पृष्ठ सारखेच आहेत आणि 6 पृष्ठ सारखे असल्यामुळं या घनाकृतीचं पृष्ठफळ हे 6 बाजूचा वर्ग येईल. हे विद्यार्थ्यांना अतिशय सोप्या पद्धतीनं समजावून सांगता येईल.
हे विचारायचं होतं की हा आयडिया तुम्हाला कसं सुचला?
आम्ही संगमनेर तालुक्यामध्ये विज्ञानाध्यापक संघाचे कार्यकारिणी आहे. त्यांच्याबरोबर ज्यावेळेस मी चर्चा केली, मित्रांनी मला सांगितलं की आयसर पुणे यांनी एक विज्ञान 28 तारखेला डॉक्टर सी.व्ही. रमन यांच्या जयंतीनिमित्त आयसर पुणे यांनी एक क्विज अरेंज केलेली आहे, तिच्यामध्ये पार्टिसिपेट व्हा असं त्यांनी व्हिडिओ तयार.
थोडंसं तुम्हाला इंटरप्ट करू, आपल्याकडे काही अंग्रेजी ऐकणारे पण ऑडियन्स आहेत. सो लेट मी ब्रीफ यू अबाउट मिस्टर वसंत रामजी नेहे. सो ही इज फ्रॉम देवगड विद्यालय हिरगाव, पासावा, तालुका संगमनेर, district Ahmednagar, and he has participated in the category called Educational Aid Model Teachers, and the title of the project is Krutiyug Adhyapan Shaikshanik Sahitya. So he has made a very interesting toy, and you can also see his toy. We have a Toy Fest gallery. Soon we'll share the link with all the participants, and also we'll have the link in the description box. So he basically have many mathematics activities, and also you can contact him if you want to know more interesting ideas about him. Thank you. So may I request Inara to present her model. Hello, Irana. And what we'll do, we have your video, we'll play that.
My name is Inara Shajnavas. I am a student of Mukundapuram Public School, Thrissur District, Kerala State. My project is called a toy rocket.
How you came to this interesting idea, and what are the story behind this. So our audience would like to know about more details. Though you have submitted your video, we have a video in our Toy Fest gallery, but we would like to know behind the scene what is actually happening, how you came to this interesting idea, and the whole story. Can I request you to please start with that?
Yes, sir. My name is Inara Shajnavas and I'm a student of 8th standard at Mukundapuram Public School, Thrissur District, Kerala State. During this pandemic period, I was actually very bored sitting at home. So one day I got a call from my teacher saying that there is this a national level competition, and I was selected from my class to represent our school.
Oh.
And behind the rocket, like we tried many materials for the rocket. We tried increasing the height of the rocket, decreasing the size of the rocket.
Yes.
And we tried many things, and it was a real hard work for us.
Inara, you have mentioned in your write-up that you want to become a rocket scientist. So how you are inspired about that? Means.
2 years ago, a sir came to our school talking about the space, and he demonstrated many rockets, launching many rockets. And while I saw that video, I got very interested in all those, and I thought, why not do it?
Nice. It was a really nice idea. Any more interesting idea would you like to say, or any message to our small? The audience we have here are also small children studying in 9th standard, 10th standard. So any message for them from your side and from your team side to our audience?
Failure is a stepping stone to success. That is the main thing that I studied while doing this project, because I tried many materials and it took a lot of patience for me to do all these.
Okay, so that hearing directly from the student, this quote really makes an efforts. Thank you very much. Thank you very much, Inara.
Thank you, sir.
We'll continue this session with our third participants. May I call Shaurya Gupta on the floor to present his model. Shaurya.
Hello everyone, my name is Shaurya Gupta. I am from 5th grade. Today I have made a project. The name of my project is the lever transportation. As you can see here that it is now automatically working.
More interested to hear from you behind the scene stories, because we have the Zoom call to have some discussion with you how you came to this idea.
Recently I have learned a lesson about simple machines in my 5th grade.
Okay.
So after my science teacher taught me about my lesson of simple machines, so I got inspired, like I should make a toy so that I can play with it.
Nice.
After the final exams in the holidays. So then I got a notification in which my teacher has told me that there's a competition of toy fest in which we can make our own science project and show it to everyone. So
Okay.
I got really happy, and I
Nice.
got an opportunity to make my toy that I was thinking to make after the final exams.
Okay.
So this is the story that how I got
Fine.
inspired to make this project.
Uh,
Sir, I did it by myself. I just took the measurements and just thought,
Okay.
what do I need to make, and then I just I had a box. As you
To be very honest, have you ever visited ISER Pune website? Means we have also have some such type of activities, so I can.
No, sir, I've never visited the.
Okay. So this is a very good chance to visit ISER Pune Science Activity Center webpage. So there also we have documented nearly more than 100 activities similar to what you have made. And these are also approach to the hands-on activity. The very inspiring story from Shaurya, how he made it. I hope you have enjoyed this session, and we have 2 more participants to go. So thank you very much, Shaurya, for sharing this platform and going behind the story of this toy. Because many times we have competitions, but how the participant make a huge effort to come up with this idea. So we would like to request you, if you try to further increase this model to beyond say some data collection point of view or statistics. So can you just measure something about this device, how much weight we add and what could be the angle, and it could be an extension of your project.
Yes, sir.
Thank you very much. Thank you very much for going beyond this. Thank you. So
thank you, sir.
yeah. So this was our third participant who has made this beautiful liver transportation machine. And going for our fourth participant, we have here Parth Depura. He has participated in a science project in a students category. The title of his project is Catapult Golf. So welcome Parth to this interactive session of ToyFest 2021.
Hello everyone, my name is Parth and this is a project I've made which is known as Catapult Golf. Golf is a sport which is known worldwide, in which players hit the ball with their clubs and aim it in the holes. Similarly, Catapult Golf is also used in a similar manner, in which the ball is thrown from the catapult into the cups. The cups are placed at different heights and different distances, using a lighter ball which goes into the glass. And
so let's start. Your model name is very interesting. Means you have prepared a catapult golf. So what it means and how you came to this means.
Sir, so basically golf is a worldwide sport and in which we use the clubs to hit the balls inside the holes. And here I have just used a catapult over there to throw the balls inside the utensils over here using different mathematical and scientific principles.
Okay. So means how you got the idea means while studying means many times it happens we have some classes, a maths class or science class, and suddenly we say okay आज हमने तो center of mass पढ़ा या moment of inertia पढ़ा. So is that a story behind it or you certainly come? How you came to this?
Basically, when we are playing games such as basketball or movies, when we see many armies throwing bombs into another. Similarly, the catapult goes down and throws the ball into the target, and can be seen in everyday life, like many examples.
And thank you very much, Parth, for this submitting this interesting toy to this ToyFest. And one last question means, how about when you got selected to this ToyFest 2021? How it's going? Means, are you inspired and are you trying? Are willing to make more such toys?
Yes, sir. It's actually pretty fun to make toys, and with like helping and all, the family helps, and it's fun to.
Correct. So behind, I'm able to see some of the calculations you did. So can you just go quickly with that?
Yeah. So basically, there are two formulas which I have used.
Okay.
One is the m1gh is equal to half m2v square. So in the second term, we have the mass of the ball and the velocity.
So last question, any references you have used?
Basically, I've just used some physics formula and the model actually, as I told, the basketball example and the movie example, and also I referred to some YouTube videos which explained the concept so that it was easy to understand it very well.
Thanks. Thank you very much.
Okay, sir.
So may I call Mr. Balasaheb Shivram Wagmare from Sri Shivaji Rao Adhirao Patil Vidyalaya, and he has participated in the category called Educational Ed Model in Teachers category, and the title of the project is very interesting, the Persistence of Vision. Welcome, sir, to ToyFest Interactive.
Namaskar.
Namaskar, sir.
नमस्कार सर, आवाज येतोय माझा?
हो.
मी पहिल्यांदा आयसर मध्ये आलो होतो सर.
अच्छा.
इंद्राणी बालन सभागृहामध्ये सकाळ NIE तर्फे विज्ञान शिक्षकांसाठी कार्यशाळा ठेवली होती. त्यावेळेस मी आयसर मध्ये आलो होतो आणि त्यावेळेस आम्हाला वेगवेगळे मॉडेल कसे बनवायचे या संदर्भामध्ये अशोक रुपनर सर होते, सर आहेत बघा. अशोक रुपनर हो, आणि मॅडम होत्या. त्यांनी आम्हाला खूप मार्गदर्शन केलं. आम्ही स्वतः शिक्षकांनी मॉडेल बनवलं आणि मग मी आमच्या शाळेत आल्यानंतर गणिताचे काही मॉडेल बनवले, विज्ञानाचे काही मॉडेल बनवले. तर गणितामध्ये मी सापशिडी बनवली सर, बेरीज वजाबाकी गुणाकार वर्ग वर्गमूळ ह्या संकल्पना समजून देण्यासाठी सापशिडी बनवलेली आहे. त्याच्यानंतर पूर्णांकाची बेरीज वजाबाकी करण्यासाठी सुद्धा एक व्हील बनवलेलं आहे. हे गणिताचे मॉडेल ठेवणार होतो, परंतु हे मी याच्यासाठी ठेवलं मॉडेल की थोडस युनिक आहे आणि अगदी कमी खर्चामध्ये हे तयार केलेलं आहे. आणि फिरणाऱ्या वस्तू नंतर विद्यार्थी तर त्याच्याकडे अट्रॅक्ट होतो. म्हणून हे मॉडेल मी आपल्यासाठी सिलेक्ट केलेलं आहे. आता याचं वर्किंग तर तुम्हाला माहिती आहे की दृष्टी
एकदा फक्त आमच्या प्रेक्षकांसाठी एकदा फक्त सुरू करून दाखवून का तुम्ही ते कसं काम करतोय. आता तुम्ही आहेच तुमच्याकडे तर.
हो हो चालेल. ओके. आता इथं काय केलेलं आहे की बघा की वेगवेगळे अक्षर त्याच्यावरती लिहिलेले आहेत. डब्ल्यू लिहिलेला आहे, तर ई ह्या बाजूला लिहिलेला आहे, त्यानंतर एल या बाजूला आहे, त्यानंतर सी या बाजूला आहे, त्यानंतर ओ इकडं आहे, त्याच्यानंतर एम इकडं आहे आणि ई इकडं आहे. आता दृष्टी सातत्य म्हणजे आपल्याला माहितीये की कोणतीही वस्तू जेव्हा आपण डोळ्यासमोर ठेवतो तेव्हा तिची प्रतिमा लेन्सद्वारे किंवा नेत्रभिंगाद्वारे दृष्टीपटलावर निर्माण होते. ती वस्तू बाहेर बाजूला काढल्यानंतर सुद्धा त्या प्रतिमेची संवेदना 1/16 सेकंदापर्यंत आपल्या दृष्टीपटलावर कायम राहते त्या प्रतिमेची संवेदना. यालाच आपण दृष्टी सातत्य किंवा पर्सिस्टन्स ऑफ फ्युजन म्हणतो. त्याच कालावधीमध्ये जर दुसरी वस्तू डोळ्यासमोर आली तर पहिली वस्तू आणि दुसरी वस्तू यांची प्रतिमा सलग निर्माण होते. आपलं चलत चित्रपट, मोशन पिक्चर किंवा दूरदर्शन संच याचं कार्य ह्या तत्वावरती चालतं. आणि अगदी सोपं आहे आपलं बघा सर की आपल्याला वेलकमी जी अक्षर आहेत ती आपल्याला तर पाहायला मिळतात.
अप्रतिम. खूपच छान मॉडेल बनवलंय सर तुम्ही. अजून हे जे मॉडेल आहे सर तुम्ही शिकवताना वापरताय का? मीन्स क्लासमध्ये कसं तुमचं मीन्स स्टुडंट्स
आता कसं आहे 10वीच्या विज्ञानामध्ये मी 10वीचं विज्ञान भाग 1 शिकवतो. त्याच्यामध्ये प्रकाशाचं परावर्तन अपवर्तन आहे, त्याच्यामध्ये हा एक मुद्दा दिलेला आहे. तर सुरुवातीला कसं होतं की ते अगरबत्तीचं दाखवायचे की अशी अगरबत्ती गोल गोल फिरणार किंवा ते पिंजऱ्यामध्ये एका बाजूला पोपट दुसऱ्या बाजूला पिंजरा.
ते तर रेग्युलर आहेच ते रेग्युलर, पण हे काहीतरी नवीन केलंय तुम्ही.
हो, आणि हे थोडस पुल्ली वगैरे लावल्यानंतर त्यानंतर आपली साधी मोटार आणि ही जी हा जो रॉड आहे सर हा याचा वेल्डिंगचा रॉड आहे. वेल्डिंगचा रॉड कसा एक समान असतो आणि एल अँगल आहे. साधारण 100 ते 150 रुपयापर्यंत खर्च आलेला आहे. आणि विद्यार्थ्यांना दाखवलं की ते खुश होऊन जातात आणि मग त्यांना सांगता येतं की डब्ल्यूची प्रतिमा आपल्या डोळ्यात निर्माण झाली, ती गेली का तिच्या नंतर लगेच ईची प्रतिमा निर्माण होते. विद्यार्थ्यांना तो कन्सेप्ट अगदी इझिली समजून जात.
अगदी हँड्स ऑन मॉडेलनी तुम्ही सगळं मीन्स कॉन्सेप्ट ऑफ लाईट, अजून हे रिफ्लेक्शन, अजून पर्सिस्टन्स ऑफ विजन, हे तुम्ही खूपच सोप्या पद्धतीत आपले विचार मांडलेले आहेत सर. अजून या सायन्स डेच्या निमित्ताने तुम्ही आमच्या जे लहान आपण छोटे सायंटिस्ट म्हणून जे आपले प्रेक्षक आहेत, अजून खूपसे बरेच टीचर्स तुम्हाला बघतायत आता, तर तुम्हाला काही बोलायचं असेल किंवा काही निरोप द्यायचा असेल तर काय तुम्ही सांगणार? कधी हे जे टीचर्स जेव्हा हे असे हँड्स ऑन ऍक्टिव्हिटीज बनवतात तर खूपशे प्रयत्न ते करतात, अजून खूप अडचणी पण येतात, तर तुम्ही काय सांगणार त्यांना?
सगळ्यात अगोदर आहे ना सर, अरविंद गुप्ता टॉईज
बरोबर
ना, ती जी वेबसाईट आहे, आम्ही ज्या वेळेस आयसर मध्ये आलो होतो त्यावेळेस आम्हाला सांगितलं होतं की अरविंद गुप्ता यांची तुम्ही फक्त अरविंद गुप्ता जरी युट्यूबला सर्च केलं तर भरपूर प्रयोग येतात. त्याच्यावरून जर आपण सर्च केलं, आपल्या विद्यार्थ्यांना कोणता घटक समजणं जर अवघड जाते हे जर आपण पाहिलं, आणि पण तुमच्याकडून जे साहित्य मिळतं नाही त्याच्यातून आपण बरेचसे काही मॉडेल बनवू शकतो. त्यामुळे विज्ञान शिक्षकांना एक विनंती आहे की कधीही तुम्हाला समजा आयसर कडून जर तुम्हाला की तुम्ही आयसर मध्ये जर गेलात तर तुम्हाला खूप काही शिकायला मिळणार आहे. खूप साहित्य त्यांच्याकडे आहे, ते साहित्य सुद्धा अगदी ते फ्री मध्ये देतात. आता मला बरंचसं साहित्य सर फ्री मध्ये मिळालं होतं, त्याचा मी आमच्या विद्यालयामध्ये विद्यार्थ्यांसाठी उपयोग केलेला आहे.
बरं, फ्री मध्ये तर नाही, पण खूपशे असे इन्स्टिट्यूट असतात सर जे ह्यांना स्पॉन्सर्स करतात किंवा तुम्हाला मदत करतात.
हो हो, म्हणजे आता ते सकाळी नाही तर ते होतं त्यामुळे ते फ्री मिळालं.
करेक्ट. पण ऍक्च्युअल मध्ये आम्हाला हे सांगायचं आहे की जे असे साहित्य किंवा हे जे मॉडेल्स तुम्ही बनवता हे जरी सोपे नसले पण त्याच्यात जे एंगेजिंग फॅक्टर असतो, मीन्स जे बनवता जे तुम्ही शिकता ते खूप महत्वपूर्ण असते. तर हे एक लहान गोष्ट आहे, ते खूपच महत्वपूर्ण आहे हे सगळं ऍक्टिव्हिटी मध्ये.
आमच्या शाळेमध्ये आता तुम्हाला तर मी सांगितलं की आमच्या शाळेतली काही विद्यार्थ्यांनी विद्यार्थी गटातून सुद्धा सहभाग घेतलेला आहे.
बरं.
म्हणजे तुमच्या टॉय फेस्ट मध्ये पण सहभाग घेतलेला आहे. आमच्या इकडे आमच्या आंबेगाव तालुक्यामध्ये सर GMRT आहे.
ओके. येस.
जायंट मीटर खोडदला.
हो.
त्यांनी सुद्धा ऑनलाईन प्रोजेक्ट विद्यार्थ्यांकडून मागवले होते. बरोबर. त्यानंतर आयुकांनी सुद्धा काय केलं होतं की ऑनलाईन प्रोजेक्ट मागवले होते.
करेक्ट.
बरोबर. म्हणजे आयसर, आयुका आणि GMRT
हो,
या तिन्ही संस्थांनी काय ऑनलाईन एक्झिबिशन आयोजित केलं होतं.
बरोबर.
आहे की नाही. मग मी विद्यार्थ्यांना सूचना सांगितली की आपल्याला प्रोजेक्ट तयार करायचे आहेत. तर जवळजवळ 7 ते 8 विद्यार्थ्यांनी प्रोजेक्ट तयार केलेला आहे.
खूप धन्यवाद तुमचा ह्या टॉय फेस्ट मध्ये पार्टिसिपेट करण्यासाठी. थँक्यू व्हेरी मच सर. थँक्यू.
धन्यवाद.
Thank you. So we have the second session of this interactive session, and we have another participant, Mr. Jeevan Mangesh Ayare.
नमस्कार, माझे नाव जीवन मंगेश आहे. मी पाटण, सातारा, महाराष्ट्र इथला रहिवासी आहे. मी रयत शिक्षण संस्थेच्या देवदीप्य विजय कन्या विद्यालय जिंती येथे विज्ञान शिक्षक म्हणून कार्यरत आहे. विज्ञान दिनानिमित्त आयसर पुणे यांनी आयोजित केलेल्या टॉय फेस्ट या इव्हेंटमध्ये मी माझे संगणकाचे बायनरी डिजिट हे उपकरण सादर करत आहे. हे अंक घेतले आहेत कॅलेंडरवरचे. हे अंक मी याच्यावर चिकटवले आणि हे त्यांचा जो काही सिक्वेन्स आहे हा वेडावाकडा सिक्वेन्स आहे. आता याच्यात मी काय केलंय की बायनरी डिजिट कॉम्प्युटर संगणक कसं काम करतो त्यानुसार याला मी पंचिंग मशीनने कट केले. काही जणांना छिद्र ठेवले तर काही जणांना पूर्णपणे कट केले. पूर्ण झाले त्यांनी त्याचं काम पूर्ण केले. हा सिक्वेन्स येतो 0 1 2 3 4 5 13 14.
तर ही आयडिया तुम्हाला कशी सुचली, मीन्स कुठून तुम्हाला प्रेरणा मिळाली की हा मॉडेल तुम्ही बनवायचं?
कसं आहे सर, हे जे वर्कशॉप चालू होतं आयसरचं 3 ऑक्टोबर पासूनचं, त्याच्यात जे छोटे छोटे प्रयोग करून दिले. मला वाटलं प्रयोग एखादं उपकरण सादर करायचं म्हणजे काहीतरी मोठं लागतं. तिथून मी बघितले की आपण छोट्या छोट्या घरगुती रोजच्या वापरातल्या काही गोष्टीतून पण करू शकतो. ते इन्स्पिरेशन म्हणून आपण जुन्या फाईल पुट्टे यांच्या मदतीने, पंचिंग मशीन याच्या मदतीने ते करू शकतो, असं मला ती आयडिया आहे. आणि त्या दृष्टीने मी ते केलं की मुलांना सहज समजेल आणि ते त्याच्यामध्ये पण स्वतः काहीतरी करण्याचा प्रयत्न करतील अशा पद्धतीने.
तर शाळेत पण सुद्धा तुम्ही शिकवताना हे मॉडेल्स वापरता?
हा. आमचं 10वीला 9वा आणि 10वा धडा आहे संप्रेषण शास्त्र किंवा माहिती तंत्रज्ञान. त्यामध्ये मी मुलांना आयडिया दिली होती किंवा कशा पद्धतीने संगणक वर्क करतो. आपण त्याला कमांड दिली की तो कशा पद्धतीने आपल्याला काम करून देतो. आता हे कार्डावर करताना थोडा वेळ जातो, पण संगणक ते मशीन असल्यामुळे पटकन विदिन अ सेकंद ते करून देतं.
हो. तर तुम्हाला असं वाटतं की हँड्स ऑन ऍक्टिव्हिटीनी जर आपण शिकवलं तर ते थोडासा सप्लिमेंट होतो किंवा चांगल्याने आपण आयडिया कन्वे करू शकतो. खूपच आवडला सर आम्हाला तुमचा हा जो कॉन्सेप्ट होता. हा नवीन आहे, अजून खूपदा आम्ही बघितलं पण आहे, पण असं खरड्यानी किंवा हे असं करून जे माहिती तुम्ही दिली आहे या टॉय फेस्ट मध्ये खूपच आम्हाला आवडली. अजून फार फार धन्यवाद ह्या टॉय फेस्ट मध्ये पार्टिसिपेट करण्यासाठी. Thank you sir, and for our viewers, if you want to know more about this, you can check the description box for more details and for the video information. Thank you. So this was an interesting fact about one of the participants who have made a very interesting, engaging hands-on activity which explains the computational thinking. So now we'll move to the next participant. His name is Shripad from Sri Satya Sai Vidya Vihar High School, and he has participated in the category science project student submitted by students category, and the title of the project is very interesting, the bipedal robot.
Hello everyone, I am Sai Shripad Varanasi, and today I am going to show you a toy based on the concept center of mass. This is the point in which the center of mass is present. So even if we tilt it left side or even right side, it comes to the same position and it stabilizes. And just tilted it for some time, it tends to move forward. Thank you.
Hello, Shripad, how are you?
Fine.
I welcome you on this platform of this interactive session of the Toy Fair second session. And we would like to know how you came to this idea, means how it works. Means it is really fascinating to see such an interesting and low cost and approach to the green energy. So can you just explain about the model?
So what happened is, first I used to see many sports programs, something like skating, skating, gymnastics, and many more. So I always wonder. So I used to wonder how they used to how they balanced themselves from not falling down. Something like for the gymnastics, they walked on the rope, just with catching a stick in their hand. So like this, when I browsed in the net, they just told something about balancing, but not much. But after some days in my physics class, I came across my physics teacher told me about the lesson gravitation.
Okay.
In that lesson, I came across the word center of mass. This became my this was my most favorite topic in that. So what happened is, I liked that very much, and I started looking for more of it. After I browsed in the net, there were many projects based on this. Something like they balanced a butterfly. So what they did is,
very nice, very interesting. So on this Science Day, we have so many exciting toys, and also you can check this interesting video in a Toy Fest gallery. The link will be in description box in short time. And thank you very much, Rupert, for joining us to this interactive session. And we wish you all the very best in your future to make more such interesting toys and share with us. So IISER Pune also has an interesting repository of many hands-on activity. You can check it whenever you have after this interactive session. I'm very much sure that you will like it. Thank you very much for joining us. Thank you. So we have a next participant. Her name is Geeta Ganpat Dhanavade from MES Rani Lakshmibai Mulinchi Sainik Shala, Pune, and she has participated in the students category, and the project title is Natural Giant Wheel Balanced on a Single Point. I would like to know how you come to this interesting idea that you have submitted in the Toy Fest. Can you just brief us about on that?
मैं जब मेरे गांव में गई थी तब वहाँ पे खेत में हम खेल रहे थे ना, तब मेरे भाई और मैंने ये प्रोजेक्ट करके देखा था.
Okay.
तो फिर फर्स्ट जो हम काउज होते हैं ना, उन्हें जो खाने के लिए देते हैं हम घास, उसकी वो हमने एक झाड़ी काट ली और उस स्टिक को हमने जो पपुल का ट्री होता है ना, उसके जो होते उससे लगाते हैं, और फिर वो आगे का जो शार्प सब्सटेंस होता है ना,
अच्छा,
वो घुमाते हैं. फिर उस पर हमने ये पूरा, मतलब वो जो सिंगल पॉइंट होता है उस पर पूरा वो टॉय
बैलेंस किया. बहुत ही सुंदर टॉय आपने बनाया है. और इस मतलब ये जो कॉन्सेप्ट है, ये आपने कहीं टेक्स्ट बुक में भी पढ़ा है? मतलब आपको आइडिया कैसे आया ये कि एक सिंगल पॉइंट पे जो आपने बैलेंस किया है? सो आपने ऐसा कहीं टेक्स्ट बुक में भी देखा है इसी टाइप की एक्टिविटीज, या ये जो प्रिंसिपल है जो सेंटर ऑफ मास? नहीं, लेकिन ये है टेक्स्ट बुक में भी, तो आपने ऑलरेडी जो किया है तो आप उसको टेक्स्ट बुक से भी मैच कर सकते हैं. सो थैंक यू वेरी मच फॉर पार्टिसिपेटिंग इन द टॉय फेस्ट इवेंट, एंड आई विश यू ऑल द वेरी बेस्ट for making more such interesting toys and sharing with us. Thank you. So we are on the conclusion of this interactive session. So before going, I would like to propose a vote of thanks to entire outreach team who worked behind the scene to make this event happen. Last but not the least, a big thank you to each one of you to make this Science Day celebration memorable day for us. So stay tuned for coming up next event, that is a panel discussion on the topic Inculcating Scientific Temperament Going Beyond the Curriculum. I hope you have enjoyed this session, and if you have any comments, please type it in the description box. Surely we'll try to answer that. Thank you very much.
evening to all. Very interesting session designed by that. You saw the project designed by the students and the teachers from all over the actually country. We got many entries. Now, thank you very much for all the students and the teachers. Now, very interesting activity I would like to show you. Just we thought few weeks back, I have here bottle. And this bottle is filled with the marbles. This is normal marble. जो बच्चे खेलते हैं ना, कंचे खेलते हैं ना, these are the marbles. अभी देखिए, this is a completely filled. Let me drop. देखिए पूरा bottle मेरा ये marble से भरा है. Now I have filled the bottle completely with the marbles. Now my question. देखिए आपके लिए एक ट्रिकी क्वेश्चन है. अब जरा ध्यान से सुनो. अभी ये पूरा भर दिया मैंने. And of course, if you see the shape of the marbles, it's actually spherical. गोला है ना बिल्कुल वो. तो ऑफकोर्स देयर मस्ट बी सम गैप बिटवीन द मार्बल्स. तो वो गैप जो है वो हमें मेजर करना है. व्हाट इज द वॉल्यूम ऑफ दैट गैप एज कंपेयर टू दिस बॉटल. अभी कैसे करोगे? आप बोलोगे कि अरे एक मार्बल ले लो, उसका आप वॉल्यूम निकाल दो, बाद में बॉटल का वॉल्यूम निकाल दो, कितने मार्बल है उतना माइनस कर दो बॉटल के वॉल्यूम से, तो वो आ जाएगा. ऑफकोर्स फॉर दैट यू नीड कैलकुलेशंस. बट विदाउट डूइंग इन द कैलकुलेशन, जस्ट फॉर एस्टिमेशन, यू कैन actually find the volume of the air what is inside the bottle या between the marbles. मार्बल तो है ही है, लेकिन उसके बीच में जो जगह है उसका वॉल्यूम कितना है. तो उसके लिए क्या करना है आपको? you have to take the similar kind of the bottle. अभी देखिए मेरे हाथ में दो बॉटल है, इसमें पानी है. just I have added the color, just color is there. और ये अपना पूरा भर दिया है मार्बल से, ये पानी से, कलर वाला पानी. अभी देखिए यदि इसमें मैं पानी डालूंगा, समझ लो कि 10% पानी मैंने डाल दिया, तो आप क्या करो, क्या एस्टिमेट कर सकते हैं? तो वॉल्यूम जो इनका अंदर का है, बॉटल का एयर है अभी, वो है 10%. तो अभी देखिए आप एस्टिमेट कर दो, वो वॉल्यूम 10% हो सकता है, 20 हो सकता है, 25 हो सकता है, 50 हो सकता है, और मोर देन दैट हो सकता है. 100% तो नहीं हो सकता, क्योंकि मार्बल इज देयर आर मार्बल्स. अभी देखिए क्या मैं अभी आपके सामने करता हूं, देखिए आपको पता चलेगा. अभी मैं इसमें पानी डालता हूं और ये पूरा भरा है, दोनों में देखो पूरा भरा है ये. तो अभी इसके अंदर मैं ये पानी डालता हूं, अभी पानी डालता हूं, अभी जा रहा है, ये पानी जा रहा है अंदर, और एक भी बूंद मैं वेस्ट नहीं करूंगा. अभी देखिए यहां, अभी देखिए यहां, अभी यहां तक, यहां तक, यहां तक, यहां तक, यहां तक. अभी देखिए, आहा, कितना पानी डाल दिया है अंदर. यू गॉट द आइडिया कितना है? अभी साइड में देखो, लगभग 50%, लगभग 50% उसमें गैप था. मतलब वॉल्यूम ऑफ द एयर बिटवीन द मार्बल्स वो कितना हो गया? 50%. और हमेशा बच्चे, टीचर्स हमें आंसर देते हैं, दिस इज ट्रिकी. वो क्या बोलते हैं? नहीं कितना जगह होगा? 10% होगा, 20% होगा. कोई भी 25% से ज्यादा नहीं बोलता. लेकिन इफ यू सी एक्चुअली कितना है? अबाउट द 50%. और आपको ये भी पता चलेगा, इफ यू चेंज द साइज ऑफ द मार्बल, बड़ा मार्बल इस्तेमाल किया तो ये वॉल्यूम बढ़ेगा या पानी का, मतलब अंदर का जो स्पेस है वहां हवा है, वो वॉल्यूम बढ़ेगा. इफ यू यूज द बिगर मार्बल या इफ यू यूज द स्मॉलर मार्बल, उसका वॉल्यूम क्या होगा? आपको बिल्कुल के देखो, आपको पता चलेगा. जितना मार्बल का साइज बढ़ा, उतना अंदर का वॉल्यूम जो है बढ़ता जाएगा, और जितना कम साइज है मार्बल का, उतना अंदर का वॉल्यूम कम होता जाएगा. ये आपको पता चलेगा. एंड अनदर इंटरेस्टिंग एक्टिविटी आई वुड लाइक टू शो यू हियर. अभी देखिए मेरे हाथ में स्ट्रॉज है. लेट मी टेक फ्यू स्ट्रॉज. और मेरे हाथ में देखिए ये स्ट्रॉज है, और स्ट्रॉज से आप क्या क्या पॉसिबिलिटी है? If you have the paper straws, whatever straws you have, you can make very nice activity just with help of these kind of the straws. Now let me cut this straw into 2 pieces. Purposefully मैं उसे 2 pieces बनाता हूँ, एक छोटा है, एक बड़ा है. और आपको क्या करना है? दोनों भी पीसेस जो है ना, एक साइड से फ्लैट करना है, बिल्कुल ऐसा फ्लैट करना है. दोनों साइड से फ्लैट कर दो, और आपको काटना है. कैसा काटना है? देखिए ये ऐसा स्लांट कट है. देयर इज अ स्लांट कट ओवर हियर and there is another slant cut over here. अभी बिल्कुल ये शार्पन हो गया, शार्पन पेंसिल जैसा. और साइड से देखोगे ना, इट्स लुक्स लाइक अ बेबी क्रोकोडाइल माउथ. ओके, बेबी क्रोकोडाइल माउथ. और यहाँ भी इससे भी वैसा ही काटना है. लेट मी मेक अनदर 2 slant cuts with a smaller piece of the straw। और अभी देखिए मेरे पास बिल्कुल 2 straws हैं, एक छोटा एक लंबा, इनर डायमीटर तो सेम है। अभी मैं क्या करूंगा, इसे फ्लैट करके जोर से ब्लो करूंगा। एंड यू हैव टू कंपेयर, क्या कंपेयर करना है, एक मजा के लिए मैं बोलूंगा तुम्हारे घर में हमारे डैडी या फादर है, बाबा है और हमारी मदर है, तो ये जो साउंड आ जाएगा इस स्ट्रॉ से, तो आपको उसमें साउंड बनाने वाला हूं, तैयार करने वाला हूं, तो कौन सा साउंड किसका है, यू हैव टू कंपेयर दीज साउंड्स विथ योर पेरेंट्स। अभी ये बड़ा लेता हूं, सबसे पहला बड़ा लेता हूं। अभी देखिए अभी ध्यान में रखो ये साउंड, एंड लेट मी यूज द स्मॉलर पीस। आपको अभी आप कंपेयर करो दिस टाइप ऑफ द साउंड, जहां मैं बिगर लॉन्गर स्ट्रॉ इस्तेमाल कर रहा हूं ना, दिस टाइप ऑफ द साउंड इज कॉल्ड एज अ वेरी वेरी लो पिच एज कंपेयर टू दिस वन। ये हम बोलेंगे कि ये निचला सूर है, ये जो है ना हाई पिच मींस सूर ऊपर का है। तो बेसिकली हमारा जो घर में जो साउंड है, समझ लो कि फादर का साउंड जो है लाइक दिस, एंड मदर का है वो वेरी वेरी हाई पिच। अरे पिच डिपेंड अपॉन द फ्रीक्वेंसी, नंबर ऑफ वाइब्रेशंस कितने होते हैं पर सेकंड, ऑफकोर्स दैट डिसाइड, और कितना लंबाई, कितने जगह पे हवा कंप हो रही है। अभी देखिए यहां जो है ना 2 एंड्स, देखो मैं अभी क्या कर रहा हूं, खींच रहा हूं यहां, यहां बन रहा है मेरा वाइब्रेशंस, आई एम क्रिएटिंग द वाइब्रेशंस ओवर हियर। और इंटरेस्टिंग चीज आप क्या देख सकते हो इसके, देखिए यहां मैं 2 होल बनाता हूं, आपको 2 होल बना के दिखाता हूं मैं। एक होल यहां हो गया और दूसरा होल जो है मैं यहां करता हूं। आई हैव मेड 2 होल्स, 1 2, और ये तो है नेचुरली। अभी 2 होल के बाद हमें कितने टाइप के, 2 या 3 या 4 कितने टाइप के साउंड आ जाते हैं, जस्ट वी आर कंपेयरिंग। अभी लेट मी क्लोज बोथ द होल्स। अभी देखिए एक टाइप का हो गया, बाद में सुनो दूसरे कितने टाइप्स के हैं। तो बेसिकली 3 टाइप के साउंड हो गए, क्योंकि इफ आई क्लोज बोथ द होल्स मींस आई एम यूजिंग द फुल स्ट्रॉ, if I open this one means I am using the smaller part, if I open this one I am using the smallest part of the straw। तो basically I am changing the length of the straw। अभी देखिए, और आपको क्या पता चला, लेंथ के ऊपर डिपेंड होता है कि क्या सुर मिलेगा या क्या पिच मिलेगा। और यहां क्या हो रहा है, वाइब्रेशंस, वाइब्रेशन इज अ बेस एंड द पिच डिपेंड अपॉन द लेंथ ऑफ द वाइब्रेटिंग ईयर कॉलम। और एक इंटरेस्टिंग चीज जो है मैं आपको दिखाऊंगा, जो है वो ऐसा है, लेट मी कट दिस स्ट्रॉ अगेन, एंड while blowing let me cut it now। अभी मैं इसे काटूंगा, जस्ट बिल्कुल मैं काटते काटते जाऊंगा। अभी देखो, ध्यान से सुनो, दिस एक्सपेरिमेंट यू नेवर फॉरगेट इन योर लाइफ। एंड व्हाट इज दैट, so this is very very interesting activity you can do with help of the straw। basically I am changing the length, and बिल्कुल सप्त सुरों का दर्शन आपको कुछ बट देखिए कुछ सेकंड में हो जाता है कि जस्ट बाय कटिंग द स्ट्रॉज। एंड सपोज यू डोंट हैव दिस काइंड ऑफ द स्ट्रॉ, यू कैन मेक द पेपर स्ट्रॉ, जस्ट न्यूज़पेपर रोलिंग। आपको एक लंबा ऐसा एक पाइप चाहिए, यू कैन मेक विथ हेल्प ऑफ द न्यूज़पेपर आल्सो, या कोई भी पेपर हो। और ये होने के बाद और एक फनी साउंड है, और ये हमारा सभी का साउंड है बचपन का। एंड व्हाट इज दैट, अभी देखिए मैं क्या करूंगा यहां, ये क्या साउंड है, ये सभी का हमारा बचपन का साउंड है। एंड दैट आई वुड लाइक टू मेंशन यू कि बच्चों का जो साउंड होता है, छोटे बच्चों का जो बोल भी नहीं सकते, इतने छोटे बच्चों का साउंड बहुत बहुत हाई पिच होता है। ये नेचर की देन है। देखिए सबसे ज्यादा पिच वाला साउंड बच्चों का, बाद में हमारा मदर का, बाद में फादर का, और सबसे लोवेस्ट पिच जो होता है ना, और मैं आपको दिखाता हूं, सबसे लंबा मैं स्ट्रॉ लेता हूं आपको, ये जो है ना, ये हमारे ग्रैंडफादर का पिच है, क्योंकि आई एम यूजिंग द लॉन्गेस्ट स्ट्रॉ ओवर हियर। अभी मेरा पास लॉन्गेस्ट स्ट्रॉ है, इज वेरी वेरी लो पिच, एंड इफ आई यूज द शॉर्टेस्ट वन, अभी देखिए, वेरी वेरी हाई पिच, लो पिच, हाई पिच। तो स्ट्रॉ से क्या क्या मजा कर सकते हैं ना, ये हमें पता चलता है। देखिए, ऐसे बहुत एक्सपेरिमेंट हमने डिजाइन किए हैं और हमारे डिस्क्रिप्शन बॉक्स में उसके लिंक भी हमने दिए हैं। तो बिल्कुल, व्हेन यू गेट द टाइम, मे बी टुमारो, डे आफ्टर टुमारो, यू सी देयर इज अ लॉट ऑफ एक्सपेरिमेंट डिजाइन वी एट द आईसर पुणे साइंस एक्टिविटी सेंटर। और एक मजे की चीज आप कर सकते हैं आज, क्या कर सकते हैं, देखिए ना, पहले तो मैं आपको दिखाता हूं कि ये इजीली अवेलेबल मटेरियल क्या है। अभी देखिए, कोरोना वायरस के पीरियड में बहुत जगह से हम देखते कि डॉक्टर हो, नर्सेस हो, इस टाइप का हैंड ग्लोव्स इस्तेमाल करते हैं। वो चाहे व्हाइट हो सकता है, अलग कलर का हो सकता है, तो बेसिकली रबर हैंड ग्लोव्स हैं। और ये हमने बॉटल लिया है, दिस इज द बॉटल, और यहाँ का बेस हमने काट दिया है, जस्ट वी कट द बेस ऑफ द बेसिकली ये बॉटल। अभी मैं क्या करूंगा, दूसरे एक कोई कैन में मैं पानी लेता हूं। देखिए, मैं पानी लेता हूं, यहाँ मेरे पास पानी है, और बाकी यहाँ एक बॉटल को हमने हैंड ग्लोव्स रख दिया है। अभी मैं क्या करूंगा, देखिए, ये जो हिस्सा है इसमें डालूंगा। देखिए अभी क्या हो रहा है, हैंड ग्लोव्स का पोजीशन देखो, जैसा ही ये नीचे डालता हूं, देखिए अभी देखिए, आहा, देखा अपने, देखिए ऐसा ही डाल दिया। तो और क्या कर सकते हैं हम, बाय बाय भी बोल सकते हैं इसे। देखिए कितना अच्छा मतलब ये नजारा है। देखिए अभी कुछ नहीं, हवा अंदर, क्योंकि यहाँ जो हवा ट्रैप हो रही है, नीचे से पानी बॉटल के अंदर जा रहा है, दैट कंप्रेस द एयर, दैट क्रिएट द प्रेशर, एंड प्रेशर कहाँ दिखाई पड़ रहा है, वो आपका अपना जो हैंड ग्लोव्स है वो बिल्कुल स्टैंड अप जैसा हो रहा है, बिल्कुल बिल्कुल ऐसा वो खड़ा हो रहा है, ये आपको यहाँ दिखाई पड़ रहा है। ओके, नाउ अनदर एक्टिविटी आई वुड लाइक टू शो यू हियर। जस्ट आपको देखिए ना, ये एक चीज मैं आपको बिल्कुल मेंशन करता हूं, और व्हाट इज दैट, देखिए ये मेरे पास ये चीज है, देखो, और वो क्या चीज है, ये हमें रेडीमेड मिला था, लेकिन उसका नेक्स्ट वर्जन देखिए, पूरे देश में अभी टॉय कैथॉन का, टॉय फेस का माहौल बन रहा है। ये क्यों माहौल बन रहा है कि हमारे जो चीजें हैं, बहुत से बच्चों के खिलौने होते हैं, ये बाहर के देश से आते हैं, तो हमें ऐसा लगता है कि अरे हमारा इतना कल्चरली स्ट्रांग रिच ट्रेडिशन है कि हमारे बच्चे बहुत खिलौने बनाते हैं, हमारे लोग बहुत खिलौने बनाते हैं, तो क्यों नहीं हमारे खुद के खिलौने बनाएं। तो वी सॉ दिस एक्टिविटी, ये जो एक्टिविटी है ना मेरी, तो देखिए हमने देखा था पहला, लेकिन अभी देखिए ये बैलेंस जो हो रहा है ना, ये बैलेंसिंग, तो उसका नेक्स्ट वर्जन हमने इतना इजी बना दिया है, बस वो लास्ट में आपको दिखाता हूं, एंड देन विल मूव टू अनदर सेशन। अभी देखिए इसका वही, जस्ट विथ हेल्प ऑफ द मैग्नेट्स, कैन यू सी द मैग्नेट्स ओवर हियर। तो ये बेसिकली यहाँ रिपल्शन है, यहाँ अट्रैक्शन है, और बेसिकली मेरा ये जो पेन है वो हवा में फ्लोट हो रहा है, the pen is in the air. It's very very interesting actually. Now thank you very much, and let's move for the another very very interesting panel discussion. So we'll move to our panel discussion.
हाँ ठीक है,
2 मिनट म्यूट करते
हो ठीक है। A very good afternoon to all our viewers and happy Science Day to everyone. I am Aparna, physics faculty and the faculty in charge of Science Activity Center at IISER Pune. I hope you have enjoyed the programs that we have been streaming all day. We now have for you a panel discussion on inculcating scientific temperament going beyond the curriculum. And what an eclectic set of members we have. I will begin by introducing them. But let me tell you that each one of them has such a stellar personality that it is really a challenge to introduce them in a few lines. So, in the interest of time, what I will do is I will highlight their most prominent associations. And the links to their detailed profiles will be there in the chat box and later added to the description box. So, we start with Dr. Basant Rajan, CEO of Coriolis Technologies. Basant has a PhD in computer science from TIFR Mumbai. A very warm welcome to you, Basant.
Thank you.
Our second guest is Dr. Naveen Kabra, the founder and CTO of RallyScore.com. Naveen has a PhD in computer science from University of Wisconsin, USA. He is also an instructor at GenWise, where they teach high school students courses on diverse topics like cryptography, game theory, blockchain technologies, and so on. Welcome, Naveen. Also joining us is Vinita Khaladkar. Vinita has over 25 years of experience in the field of education. Currently, she is the principal of Educon International School. Welcome, Vinita. We look forward to our chat. Also with us is Pawan Iyengar. Pawan is the co-founder of DLRC, Drive Change Learning and Resource Center. This is an alternate education space. There are around 150 students currently enrolled in various grades and programs at DLRC. The class size is not more than 30 students with 2 facilitators to facilitate their learning journeys. Welcome, Pawan. Also with us is Vipul Shah. Vipul is the head of education and skilling, Global CSR, Tata Consultancy Services, TCS. He also heads CS Pathshala, an initiative launched to promote computational thinking in India. Welcome, Vipul. Now, before we begin the session, we had asked, earlier we had asked our viewers for questions, what kind of questions they would have around this topic. And we have a set of questions, and we will start with our first question for Basant. And what I will try and do is I will translate the question in Marathi also, and then based on the answers, I also translate the answer in Marathi. Okay. So the first question, Basant, is from a student, Ayush Singh. And Ayush says, if we don't want to be in the field of science in future, then why do we have to study science so deeply? म्हणजे आयुषला विचारायचं आहे की आपल्याला जर विज्ञानाशी संबंधित काही पुढे शिकायचं नसेल शाळेनंतर तर मग इतका विज्ञानाचा अभ्यास करण्यामध्ये कशाला वेळ द्यावा? Yeah.
Ayush, science is a way of exploring, understanding, and explaining our environment. The process helps build a broader behavior we refer to loosely as scientific temperament. Although inquiry and the scientific method are integral to science education and practice, many of our everyday decisions are based on these processes. Natural human curiosity and necessity lead to asking questions, coming up with a proposal, testing it with evidence and evaluating the outcome, and making future decisions based on that result. Even marketing pitches based on observing that people have biases and are susceptible to suggestion is an outcome of scientific temperament being explored, just as much as objectively evaluating claims made in a health drink promo. So when talking about studying science, think of it as preparing oneself to observe, analyze, propose, justify, verify, improve, and then decide on a course of action, where an already thought through SOP doesn't exist, as opposed to following the next guy without knowing why. Does that cover you?
Yeah, it makes a lot of sense. And yes, so now the kind of approach that we have in science is there in other spheres also. That's the essence of what you want to say, right, Basant?
Yeah.
So Ayush,
that here is used everywhere.
Yes. तर असं आहे की विज्ञानाची जी प्रक्रिया आहे की प्रश्न विचारणे, त्यांची उत्तरं शोधणे, ते कुठे कुठे लागू होतात हे पाहणे, ही गोष्ट आपण फक्त विज्ञानात वापरत नाही. म्हणजे एखादी मार्केटिंगचं जे बसंत सरांनी उदाहरण दिलं की तिथे सुद्धा कुठली वस्तू लोकांना आवडते आहे, कुठली ते जास्त विकत घेतात, कुठली कमी विकत घेतात. तर प्रश्न विचारणं, त्याच्यातनं उत्तरं शोधणं आणि त्या उत्तरांमधून आपण नवीन मार्ग काढणं, ही आपल्या जीवनातल्या बऱ्याच गोष्टींची प्रक्रिया आहे. तर ती फक्त विज्ञानापुरती मर्यादित नाही आहे. त्यामुळे ही प्रक्रिया आपण शिकतो जेव्हा आपण विज्ञानाचा अभ्यास करतो आणि म्हणून आपल्याला विज्ञान शिकणं गरजेचं आहे. जरी ते पुढे अगदी विज्ञान शाखेतच तुम्ही अभ्यास नाही केलात तरी सुद्धा. हां, ठीक. मग आपला we'll go on to the next question. The next question is for Naveen. And the question is, what in-depth efforts are required to enhance scientific outlook in the students, and what changes are expected in education for that? This question has been asked by Chetan Patil, who is a teacher. तर विद्यार्थ्यांमध्ये वैज्ञानिक दृष्टिकोन निर्माण करण्यासाठी काय केलं पाहिजे, आपल्या शैक्षणिक माध्यमातून ते कसं होऊ शकतं, असा प्रश्न आहे. चेतन पाटील हे एक शिक्षक आहेत त्यांचा. ओव्हर टू यू नवीन. Yeah.
So actually, I think that what is needed isn't more depth. What we need is more breadth. And the same thing is what our national education policy also says, which says that, we need to have less content and more critical thinking. That is one. So we have to encourage the students to look closely at whatever they are learning, to ask questions about that, be curious about why something happens. More than that, there has to be breadth also, as in, it has to go past just science. Science is not just about this one subject which you do in a lab. Like Basant said, science is there in everything. And what you have to do is bring science to all the other subjects, right? Does sports involve science? Jasprit Bumrah, when he bowls a swing ball, right? What is happening with the ball? Why does it swing? How can it turn in the air? This is science, right? When you are cooking and you do a tadka, right? Which masalas do you put in the beginning? Which masalas do you put in the end of the tadka? Is there chemistry involved in that, right? Or if you do experiments, put some change when you put the masalas and see how the taste changes. You are doing experiments, right? So all of these are listed in our NEP, that reduce the content, increase the amount of exploration you do around that content, remove the boundaries between science and literature and humanities and games and sports, and let science be involved in all of those. So I think those are the two most important things.
Okay. So like Naveen has rightly said that there is science everywhere, and चेतन, तुमच्या प्रश्नाचं उत्तर द्यायचं अगदी कमी थोडक्यात द्यायचं झालं तर विद्यार्थ्यांना भरपूर मजकूर देऊन किंवा भरपूर गोष्टी शिकवण्यापेक्षा त्यांना आपण जे शिकवतो त्यात त्यांना आपण विचार करायला लावला पाहिजे. आणि आसपास प्रत्येक गोष्टीत जे विज्ञान आहे, जसं सरांनी म्हटलं की एका स्पिन फास्ट बॉलरच्या बॉलिंगमध्ये किंवा स्वयंपाकघरात मध्ये पण इतकं विज्ञान आहे की आपण विद्यार्थ्यांना विचार करायला शिकवलं पाहिजे, भरपूर नुसती माहिती देण्यापेक्षा. ठीक. So let's go on to the third question. The third question is for Vinita. How can we teach the subjects like English or Hindi, I guess these are the languages, using more practical ways? And the question has been asked by Monica, who says she's a science enthusiast.
There are many ways to implement practical ways in teaching Hindi or English. Suppose there is an autobiography of some eminent personality. You can have a declamation. You can have suppose history related topic. You can have role play for that. There will be group discussion. In fact, what I can say that if suppose there is in fact, I have an experience like when I was a teacher in the school. One of the English teacher had a light chapter in her literature. So she called me as a science teacher, and we have combined this thing, teaching learning process, which happened in the classroom. So we always can plan, the syllabus where the subjects are interlinked. Suppose बगीचे की सैर है तो हम excursion कर सकते हैं. Suppose there is an adjective which we have to teach in English. So we can have a story weaving, like I'll just give you one example. I have a big house. My house has a lovely garden. The garden has many trees, or I have a red roses in my garden, and so on. So this is how we can interweave, and we can have lots of activities based teaching learning processes. Even suppose there is a chapter, some trees are related to trees. So we can always have the tree speaking, like suppose a coconut tree. So मैं terrestrial plant हूँ, I'm in the category of big trees, and this is how you can have the own story of a tree. So there are many things, we can implement in English and Hindi, and especially I request the teachers to interview the subjects so that the learning outcome is achieved very nicely, and understanding of the subject will be properly done. So this is what I can suggest.
Okay, so making it having more activities and making it
Yeah,
more
it's
creative
possible.
outside the textbook.
Yeah,
Okay.
it's possible.
ओके. तर विनिता मॅडमचं असं म्हणणं आहे की आपण इंग्रजी, हिंदी असे सगळे शब्द जरी शिकतो तर शक्यतो खूपदा कसं होतं की आपण धडा वाचायला सुरू केला आणि मग त्याच्यातनंच त्याच्याच अवतीभोवती आपण सगळं शिकवलं जातं खूपदा. पण त्याच्याऐवजी एखादा म्हणजे जसा बगीच्यावरती, बागेवरती एखादा धडा असेल तर आपण ऍक्च्युली बाहेर जाऊ शकतो. वर्गातल्या मुलांना कुठेतरी बाहेर नेऊन काहीतरी त्याच्यावरनं आपण अजून संवाद घडवू शकतो मुलांमध्ये, किंवा असं लाईट सारखा एखादा टॉपिक जो तुम्ही सांगितला की याच्यावरती एक आपण कविता करू शकतो. काहीतरी असं दोन्ही गोष्टींना आपण एकत्र आणू शकतो. म्हणजे जसं भाषा आहे, विज्ञान आहे, हे आपण दरवेळेला वेगळं वेगळं धरून नाही चाललं पाहिजे. त्यांना आपण एकमेकात तुम्ही म्हणालात तसं गुंफवू शकतो. बरोबर आहे ना मॅडम? ओके. Let's move on to the next question. This question is for Pawan. So how do we make sure scientific curiosity among students doesn't get washed off under grade focused education system and race for good marks? So the question has been sent by Snigdha Karadkar, who is a student.
Yeah, it's a wonderful question by Snigdha. And I would say first up, the teachers and parents need to be curious themselves. They need to compete for curiosity, really, in the class and at home. And they can also reduce the need and sense of control and perfection. So they should actually collaborate to perform with the students. And there is a difference also between hygiene and cleanliness. I think what's important, for example, if you look at soap or these synthetic soaps that we have, now they help to clean, but are they hygienic completely? So these are some of these questions that they should really think about, whether they are giving more precedence to just aesthetic values, or I would say having something clean. Like I've seen a lot of I would say drive towards not using mud too much, or not using mud in experiments, or not experimenting too much, because it will make things look dirty. But you can actually take care, and you can be organized. You can also be more thoughtful, and you can lay out a newspaper and make an experiment so that it does not dirty the room, as well as it can let the child do the experiment also. So I think that's where more thoughtfulness and more organization needs to go in. And in school, we can definitely aim to do lesser and experience more. So we should cooperate to have fun in learning. And fun in learning is a very important thing. We don't need to separate out fun and learning. And that's why even in school at DLRC, we say that it's about fun in learning. I would say last but not the least, it has to be about immersing in the science, or as we can call it, the experiences of phenomena for the love of it, for the sake of it. And I'll just like to give an example, is that while doing an experiment which involves boiling, we can actually spend more time observing the water and observing how the bubbles are moving around, how the bubbles are forming, and think about, hey, why are these bubbles being formed? Is it because of some imperfection in the surface of the vessel? And why are the bubbles not actually rising up? So these are the kind of questions we can immerse ourselves in through in a simple act like boiling. So when the students see that even a simple activity like this can be immersive, they start understanding how to go in depth. And also, as Naveen shared, we can go in breadth. So science is actually about exploring in all different directions without really putting these constraints of the curriculum. In fact, we can use the curriculum as a guideline, and it doesn't need to be a bad word in the classroom. It doesn't need to be a bad word for the teacher or the parent. We can actually use it as a great tool and look at the kind of abundance that is there in the curriculum.
Right. And Pawan, so a small part of the question about the race for good marks, would you want to say something about that?
Definitely. In fact, the other way around, I would say that let us put marks for curiosity also. And let us actually look at how do we measure curiosity in the class. So I'll give you an example that there can be certain behavioral traits, and there can be certain observations that a teacher can have in the class that can be observed about the students, and they can say, how much curiosity have you shown last week? Okay, and can the students assess themselves? Can there be peer assessments on curiosity? And I think it's best to put it formally into systems, and that is what we have observed. Even at DLRC, that we have something called as habits of work and learning, where we have perseverance, we have mindfulness as parts of the curriculum, and they get graded on that, they get marked on that. So what we've seen is, if you really want to give it importance, give time for it. If you want to give it importance, give I would say weightage to it in your daily lives. And why not curiosity? And I would say teachers and parents being curious, that is the real driver. And kids are born curious. There is a natural curiosity that the kids have. And there are some amazing questions kids have asked till now. I'll just give you an example. Is that we were planning for an exhibition, parent exhibition. And the next week it was going to happen. And the first standard students who had an MSc in physics and an engineer as their classroom teachers, he came up with an idea saying that, hey, I want to make a seed for the presentation next week. I said that, wow, okay. So we are not in the business as teachers to say that, hey, you know what, there are a lot of people who have tried to make a seed and they have not really succeeded so much in it. On the other way around, I just asked him, hey, do you know how to make a seed? He said that, sure, let's go in the chemistry lab and let's just, put some chemicals and try, So kids have that innate curiosity, and it is our, it should be our purpose to compete with the curiosity and collaborate with them and also cooperate with them.
Okay. Vinita, would you like to add something to, since this overlaps with education, would you want to add something to this?
Right. What he said is rightly, it is actually right. Curiosity has, imagination. They are imagining something, like he rightly said, that seed can be prepared in the laboratory. It is the imagination, and imagination leads to innovation, and innovation can in future maybe invention, So this is how I think we should promote what he rightly said, that curiosity quotient also. Like we have EQ, we should have CQ now. That is what I can say.
Okay. Okay, thank you. So I'll just quickly summarize this in Marathi. तर वैज्ञानिक म्हणजे कुतूहल इन जनरल म्हणजे कुतूहल निर्माण करायचं असेल जर विद्यार्थ्यांमध्ये, तर त्याच्यासाठी खरं तर म्हणजे शिक्षकांकडून, पालकांकडून पण असं असलं पाहिजे, की ते स्वतः त्यांच्यामध्ये कुतूहल असलं पाहिजे. त्यांनी मुलांना प्रश्न विचारले पाहिजेत. शिक्षकांनी विद्यार्थ्यांना प्रश्न विचारले पाहिजेत. आणि जिथे मार्कांचा संबंध आहे किंवा शिक्षण पद्धतीचा संबंध आहे, तर ह्या दोघांचंही असं म्हणणं आहे, की कुतूहलासाठी पण मार्क्स असले पाहिजेत, की कोण खरं किती कुतूहल दाखवतंय, किती रस घेतोय कुठल्यातरी कुठला विषय शिकण्यामध्ये. म्हणजे फक्त दिलेली प्रश्न जे आहेत त्यांची उत्तरं लिहा, मार्क मिळवा असं करण्याच्या ऐवजी काही शिक्षक असं नक्कीच करू शकतील, की म्हणजे शिकवताना की किती विद्यार्थ्यांमध्ये कुतूहल आहे, कोण किती प्रश्न विचारतंय, त्यालाही जर मार्क ठेवले तर आपोआप विद्यार्थ्यांमध्ये कुतूहल नक्कीच वाढू शकतं, जागृत होऊ शकतं. जे अगदी शांत बसणारे विद्यार्थी आहेत तेही खरं तर रस घेऊ शकतील जास्त म्हणजे शिक्षक जेव्हा शिकवतील वर्गात तेव्हा. ठीक. Thank you very much. That was a very interesting question and a very interesting answer also to this. So let's move on to the next question. The next question is for Vipul. And the question is how to develop mindset to observe science in day-to-day activities. So in Marathi, दैनंदिन आजूबाजूला घडणाऱ्या घटनांमध्ये दिवसातल्या आपण वैज्ञानिक दृष्टिकोन कसा निर्माण करू शकतो किंवा कसं वैज्ञानिक दृष्टिकोनाने पाहू शकतो गोष्टींकडे.
Thank you, Aparna. So, I would like to share an anecdote with you on this question. So, when my son many years ago was in a play school in the United States, his teacher in the classroom asked all the children a question: if I mix red and yellow, what color would I get? And believe me, the children gave all kinds of possible answers. Somebody said black, somebody said green, blue, brown. Now, I'd like to ask each and every one of us, what would have been our instinct to this answer, right? We would have very likely told the child that he was wrong and the correct answer was so and so, right? The teacher did not do that. She did not correct the child. What she said was, let's try and find out. And we may think it's a very silly way of doing it, but I think because she did not want to tell the students what the answer was, so that we don't take it for granted. Now, how many of us would have discovered in this fashion? How many would have learned this? All of us knew if you mix these two colors, what the answer is going to be, right? But how many of us would have learned it through discovery rather than somebody telling us to do it? Now, they actually did it, and not only did the children feel good about it because this was something they had discovered. I think that there is a lot of joy that they can have through this, and the joy can be priceless. It can help them with their confidence. It can empower the student, right? And so, how can we change the learning to learning through discovery? In this journey of discovery, we are very likely that a lot of analytical skills, critical thinking, logical reasoning skills may develop. As parents and teachers and society in general, we often discourage students from asking questions because we think questions are silly or the answers are already known to us, right? Let the students experiment. Let them find out the answers, right? They will fail, but it's okay to fail, right? Let's tell them it's okay to fail. In fact, failure is a great way to learn. And if we can make learning through discovery a way of life, I think we would have achieved the objective of setting the right mindset.
Mm-hmm.
Thank you.
Yeah. Naveen, you have something to add?
Yeah, sorry. Just because Vipul said this, I have an anecdote from my own life. Because in physics, we are taught, right? When all colors of light mix, you get white. And we have that lovely diagram and the prism and all of that. And then I took all colors and I mixed them and I got some ugly dark color. I did not get anything close to white. And I just lost trust in my teachers and the textbook. If there were teachers like what Vipul said, they would have seen that. They might have made me ask questions that why is this not happening? And then that might have led to a discussion about the difference between subtractive light and additive light and so on, right? So this kind of exploration needs to happen in day-to-day life.
Yeah.
Aparna, one more thing to that. Just
sure.
On Pawan's. Sometimes mixing subjects creates trouble. Just an anecdote from my life.
Okay.
I'm bad with languages, and I was studying poetry, and there was a description of light filtering through a thatched roof, crisscrossing to form cobwebs. the teacher goes on and on about how beautiful the imagery is, and I have a doubt. We are taught that sun's rays are parallel. When they come through the thatched roof, they're going to be parallel beams. They're not going to crisscross.
Mm-hmm.
I asked that, and the teacher was stunned for a while. And at the end of it, the conclusion was, this is a poem. So sometimes it cuts both ways.
Yeah. No. So yeah, that's the very interesting responses from all of you. But the point is that yes, where to observe science in everyday life, and a big part of a big chunk, at least of the childhood, is about teachers and going to school. And I agree that this whole discovery process of learning would be really nice. And I'm sure all of us have had teachers who've just asked us to shut up and not ask any questions. And I really hope that, things are changing with these alternate education spaces like Pawan has, or, the different ways in which Vinita School does things. And and that is exactly, not telling a kid to shut up is I think the best thing that one can do. Okay. And this question actually came from Amit Maheshwari, who is a science enthusiast. And so I'll convey a bit of this in Marathi. That म्हणजे जेव्हा कुठलाही लहान मुलं जेव्हा प्रश्न विचारतात, तेव्हा बऱ्याचदा असं होतं की शिक्षक त्यांना ना त्याचं उत्तर व्यवस्थित देतात किंवा म्हणतात की हे उत्तर चूक आहे किंवा हे उत्तर बरोबर आहे. तर हे करणं ना आपण कटाक्षाने टाळलं पाहिजे, एक पालक म्हणून पण आणि एक विद्यार्थी, एक शिक्षक म्हणून पण. आपण असं म्हणू शकतो आपल्या मुली किंवा मुलाला की चल अरे हे मलाही माहित नाही, मी कधी याचा विचार केला नाही, आपण दोघं मिळून शोधूया. किंवा शिक्षकही असं म्हणू शकतो, अरे हा छान प्रश्न आहे, आपण ह्याचं उत्तर शोधूया. ठीक आहे. किंवा अरे हे पुस्तकात असंच दिलंय, किंवा हे विज्ञानाचा धडा आहे, ही कविता आहे, हे कशाला तुम्ही मिक्स करताय, असं नाही म्हटलं पाहिजे थोडक्यात. ठीक आहे. तर now there are a few more questions, but what instead of having more questions, I also think that maybe I'll take one question which could be a common question for everybody. I guess everybody could pitch in. We could start with Pawan, and then I have one question for everybody. Okay, so looking at the time, let's take this one question. Inculcating science. So Pawan can start the answering this question. Inculcating science has always been hard theoretically, and this pandemic has restrained us to virtual labs. How can practical experience be enhanced and be made available to each and every kid? Okay. So, and this is from Sejal Shivarkar, who is a student. तर आता ह्या पॅन्डेमिक मध्ये, कोरोनाच्या ह्या काळामध्ये आपल्याला काही शाळेत जाता येत नाहीये, लॅबमध्ये जाऊन काम करता येत नाहीये. तर अशा परिस्थितीमध्ये खरं आपण जेव्हा हँड्स ऑन म्हणतो किंवा प्रॅक्टिकली गोष्टी करायच्या, करून पाहायच्या गोष्टी आपण असं जेव्हा म्हणतो, तर मग अशा परिस्थितीमध्ये हे आपण कसं घडवून आणू शकतो. ठीक आहे. सो पवन, यू कॅन स्टार्ट अँड देन अदर्स कॅन ऑल्सो मेबी शेअर देअर व्ह्यूज ऑन दिस क्वेश्चन.
This is a remarkable question, and thanks, Sejal, for really asking this. And they have the best labs available at homes right now, which are filled with fuels, which are filled with Newtonian fluids, and different species of bacteria, or even ants. And those are the kitchens, and those are the gardens. So I think that is really to use these life labs, as we all teachers kind of look at them, and to utilize the power of this. And we can use the present situation and ask what's possible and what's best to be done using this. For example, a series could be done as follows, where students can actually make some Play-Doh at home using the normal dough available. And if you're concerned about it remaining for a long time, you can actually add some haldi. So students learn a lot of chemistry by doing that, and you can learn about how to weigh the Play-Doh, and you can learn about the volume. You can learn about the density, and you can make a weighing scale at home using standardized weights that you have. So all our kitchen kind of grocery that we get, they all have standardized weights. So we can use the technology and the techniques and the information that is available at home, and we can actually make a lab at home itself. And you can also look at honing the curiosity by utilizing technology available with the kids right now, that is their mobile phones. where they can actually try doing some animation using the Play-Doh, and they come up with some wonderful animations using the normal mobile phones that they have, and stopgap animations which can talk about storytelling. So this goes into, if a student like Basant would be there in the class, they'll be able to learn these things in a hands-on way and learn about cobwebs as well as the light, and learn how about weight and volume and measuring things also.
Yeah.
Okay, that's very interesting. Yeah, please
So
go
can I
ahead.
add?
Yeah. Please,
Yeah.
please do.
So, in fact, this pandemic has taught us many things. Even our children have become a, young budding scientist. So, to share with you, one of my child, he said, I have made the stand for me, for my mobile, with the material available at home, and I have made it for my brother too. So this is one of the thing. One of the child had, he is working from his grandparents' house. He said, let me, there is a plants topic going on, and he had taken us to the, garden, and told us this is how the tomatoes are grown, or this is the guava tree, and this is a mango tree. So I think labs are available everywhere, and I think home is a sweet home and a sweet lab. I must say that. Right.
Yeah. Vipul or Naveen or Basant, you would
Yeah.
like to add something?
I would like to share another anecdote, Parna.
Yeah.
So, most of us have domestic help at home. And during the pandemic, during when it started, a lot of us were without domestic help at home, right? And so a lot of our children got an opportunity to help us in our work, in the daily work at home. A lot of them had to clean their plates. A lot of them had to do a lot of other work as well. So here's something that is shared from a very young child. And when he was asked to clean his dishes and the dishes of everybody in the home, he did not really like it, right? Because there was now all this dirty plates, every food that was left over. And so that led him to think as to why do we waste so much food? And if we are wasting so much food, can we make food available to those who are needy? And so he went ahead and discussed this and developed this idea. Can we supply leftover food? And can we find the people? Can we come up with a channel to distribute food to the needy? How do you get to know where food is to be supplied, etc.? So I think what I'm trying to say here is that the pandemic has also provided us with a lot of us and our students with a lot of opportunities, which otherwise they would not have been exposed to. Right? They've now got into situations where they have to think laterally, and I think this has helped them quite a bit. This has helped them grow in terms of their character. This has helped them to think beyond what they would have normally done.
Okay, that's very interesting.
I'd like to add one thing to this. Given that we actually have a lot of labs experiments recorded, I think one way to improve the situation, given that people can't try it out themselves, is to show failed experiments. When experts do experiments, they always succeed. But when kids do them, oftentimes they fail. And every failure leads us to actually analyze why it failed. And we get to learn a lot more from that failure than actually seeing a video of a successful experiment. So we could probably try that too.
Yes, that's a very good point actually, and a very big point, especially in the domain of science where nothing works, and sort of we find out our way through failed experiments. Yes, that's a very interesting suggestion for sure. Naveen, do you have something to say?
Well, I'll just like to add that it is not necessary that everybody has to be doing experiments all the time to do science, right? If you're not the kind who enjoys experiments, sure, just go ahead and watch YouTube channels which talk about science, which show you the experiments. There are a lot of really good ones. Veritasium, The Physics Girl, Wendover Productions, 3 Blue, 1 Brown, Kurzgesagt, Cold Fusion, the Crash Course, right? Everything is there. I mean, if you are stuck at home virtual without any access to scientific materials that you think, just watch these, right? These are a great way to learn science. I don't think I did much experimentation growing up, but I still managed to learn a lot of science by reading books and watching such shows.
Okay, all right. That's very interesting. And so to summarize this, we have had a spectrum of responses where Pawan and Vinita, they have said that the home is a lab in its own right, and we can look around and learn a lot of things at home. Then there was a very interesting perspective from Vipul, who said that we can, so from whatever we've been doing at home can lead to newer ideas in terms of reaching out to people in very positive ways. We're wasting food and distributing them to other needy people. And failed experiments, that's a very good point that Basant said, that we can take a fresh look at failed experiments and see why they fail and learn from them. Whereas Naveen has a very different take, and a very welcome take indeed, a different perspective too, that you don't have to do experiments. Fair enough, you can look at others' experiments and then learn many things just by looking at the content that is there on YouTube. So in short, there is no need to be constrained, to feel terribly constrained by this pandemic, and we can explore sources in creative ways so that we can learn, right? And just to translate this main message in Marathi, की ह्या कोरोनामुळे आपण जरी घरी अडकून पडलेलो असलो तरी आपल्या घरामध्ये कितीतरी गोष्टी आपण करून पाहू शकतो, त्याच्यातून विज्ञान शिकू शकतो. किंवा आता युट्यूबवरती इतका सगळा साठा आहे, जो माहितीचा साठा आहे, माहिती वेगळी, ज्ञान वेगळं, त्याच्यातनं आपण काहीतरी शिकू शकतो दुसऱ्या व्हिडिओज कडे बघून, दुसऱ्या लोकांनी केलेल्या प्रयोगांकडे बघून. आणि अशा प्रकारे आपण म्हणजे जरी घरी बसलेलो असलो तरी त्यातनं आपलं मूळ कुतूहल जागृत ठेवून आपण नवीन गोष्टी निर्माण करू शकतो या सगळ्यामध्ये. ठीक आहे. सो आय थिंक ऑल ऑफ यू पॅनलिस्ट, in the interest of time, I'll stop the question answer session now. And I have a common question for everybody, and I would really like to hear from you. And this is very important for us also. Now, all of you come from diverse backgrounds, right? And I guess all of you, even if you've not followed very closely, you have some idea of what activities we've been doing at the activity center at IISER Pune, at the Science Activity Center. Now, based on your background, what kind of activities would you want the activity center to sort of branch into, or diversify and sort of create more interesting activities? So I welcome your suggestions from every one of you, and then I guess one of you can start. And yeah, maybe we can start with the way things are laid out on my screen. We can start with Naveen first, and then yeah, move on.
So, I think one of the things I would like to point out is, again, similar to this, you don't have to do experiments all the time. Along those lines, the activities don't have to be about you taking something and doing an experiment. They can be virtual activities which are about scientific temperament and critical thinking. I'll give an example. One of the courses I teach is called Defense Against the Dark Arts, which is basically trying to detect fake news, differentiate fake news from real news, and non-scientific stuff from scientific stuff. And in that, I give the students an activity where I give them 5 or 6 ads with claims, right? Like Bournvita makes your kid taller, stronger, and healthier, or something like that, right? 5, 6 different ads, and I put them in groups and I give them 10 minutes. And I tell them, for each ad, you have to tell me whether those claims are true or not true, and whether those claims are misleading or not misleading, right? No other instruction, I don't teach them anything, but in 10 minutes, all of them, with the use of the internet, of course, are able to tell me exactly what is wrong with each ad, exactly how the advertiser is trying to mislead the students, right? So this is an activity, and this teaches the scientific temperament better than if I were to list out a bunch of rules of critical thinking and so on, right? So that would be my suggestion.
Yeah, this is very interesting. So maybe I will translate with each speaker, otherwise it will be a big summary at the end. So नवीन ह्यांचं म्हणणं असं आहे की दरवेळेला प्रयोग करून ओके. प्रश्न हा होता सगळ्यांना, की आम्ही ऍक्टिव्हिटी सेंटरमधनं जे काही उपक्रम करतो, त्याच्यामध्ये इकडे प्रत्येक जण वेगळ्या-वेगळ्या पार्श्वभूमीमधून आलेला आहे आणि प्रत्येकाला काय वाटतं, की आम्ही ऍक्टिव्हिटी सेंटरमधून अजून काय वेगळ्या प्रकारे करू शकतो. तर नवीन यांचं असं म्हणणं आहे, की दरवेळेला काही प्रयोग करायचीच गरज नाहीये आणि त्यांनी उदाहरण दिलंय, की एक 5-6 जाहिराती जर घेतल्यात हां आणि त्यातली खरी जाहिरात कुठली आहे आणि खोटी आणि फेक न्यूज जसं आपण आपल्या सगळ्यांना हा शब्द माहिती आहे आजकाल रिअल न्यूज आणि फेक न्यूज. तर कुठली जाहिरात खरं काहीतरी सांगते, कुठली जाहिरात खोटी आहे, ह्याचा हे आपण जर निरीक्षण करून पाहिलं, ह्याची माहिती जर घेऊन बघितली, तर हे पण अगदी वैज्ञानिकच आहे. हा वैज्ञानिक दृष्टिकोनच आहे, जो तुम्ही एका वेगळ्या घटनेसाठी किंवा वेगळ्या गोष्टीसाठी वापरत आहात. ठीक आहे. तर अशा प्रकारचं काहीतरी सुद्धा आम्ही आमच्या चॅनलमधनं करू शकतो असं त्यांचं असं ते सुचवायचा प्रयत्न करतात. ठीक आहे. Okay, over to you, Vipul. What would you like us to do?
I would like to talk about two things. One is the first one echoes with what Naveen said, and this is something that we do a lot in CS Pathshala activities that we do. And one of them I'd like to share is we have young children, very, very young children play tic-tac-toe, which all of us have played, right? But we don't tell them how it is to be played. We let them play it for a while. Let them play for several games, maybe 10, 15 games. And then finally we say, okay, now let's observe the games. Now you observe the games that you have played. Find out which were the games that led to win, led to a lose, led to a draw. And now see what would be the strategies that you would want to make to win these games, right? So discovering again through the process of exploration here. So that's the kind of activities I think which could be taken up, where the children are led through the path of discovery. The other thing which I would like to suggest is, how can we extend the science center to home, so that it is not something where children come and do their activities or come and carry out science experiments, but it is something that is omnipresent, right? It is something that is around them, something that they observe in their daily life, something that they record, they observe, then they come and share. So the science center is more about sharing their insights, more about them coming and others coming and commenting on them as to what they think about it.
Okay. Okay, that's also very, very interesting and something very doable. Yes, extension to home is definitely. तर विपुल यांचं असं म्हणणं आहे, की आपण आपल्या आजूबाजूला होणाऱ्या गोष्टी किंवा हे जे प्रयोग आहेत ते आपण करतो. पण ते अशा प्रकारे आपण करू शकतो ज्याच्यामध्ये आपण हा प्रश्न विचारू, की एक्सप्लोरेशन म्हणजे ह्याच्यातून पुढे काय होणार? हां. किंवा ह्या सगळ्या गोष्टी ज्या आहेत एखाद्या प्रयोगातून पुढे काय होणार किंवा ह्यातला आपण काय घरी करू शकतो. ठीक आहे. तर म्हणजे ऍक्टिव्हिटी सेंटर मधून आपण काही एक अशी विचारांची देवाणघेवाण, प्रयोगांची देवाणघेवाण करू शकतो ज्याच्याने आपण गोष्टी शिकण्यासाठी आपल्याला मदत होईल. असं ह्याची आवश्यकता नाही की दरवेळेला आपल्याकडे काही एक निश्चित उत्तर असेल की हे केल्यावरती काय होतं. ठीक आहे. काहीतरी आपण नवीन घेऊन ते आपण घरी करून पाहू शकतो किंवा अजून वेगळ्या प्रकारे करू शकतो असं त्यांचं म्हणणं आहे. विनीता, तुम्ही काय म्हणता?
Actually, I want to congratulate entire ICER team of their outreach program first, because we have been witnessing various programs which you have scheduled for us, and even the YouTube videos, science, learning science with fun, excellent. I just would request to you, if you can, your scientists can come and approach us and talk to our children. That will be great. So we wish to have that collaboration with you, so that we can have teachers coming and doing workshops with your science, and we can explore many new things. That is what I request to all of you.
Okay.
Otherwise, hats off to you.
Okay.
Great work.
Thank you so much, Vinita. It is really motivating and encouraging, and the whole team has been, I have been supervising, not doing much, but the whole team has been really working very hard for this. And as regards your point of collaboration, yes, some of us would definitely love to be engaged with the kids, and we'll definitely, once things settle down even more, we can also come to your school and do something for the children. We will surely
What is the request?
Yes, definitely. तर विनीता यांचं म्हणणं असं आहे की आमच्याकडचे जे शिक्षक आहेत ते त्यांच्या शाळेत जाऊ शकले, काही मुलांसोबत गप्पा मारून त्यांना काही गोष्टी दाखवू शकले, तर त्याचाही नक्कीच फायदा होईल आणि त्यांना फार आवडला आहे आजचा जो कार्यक्रम जसा ऍक्टिव्हिटी सेंटरने केला आहे तो. आणि माझी अख्खी टीम आहे जी रात्रंदिवस काम करते ह्यासाठी, आणि खरंच त्यांचं कौतुक मीही म्हणेन की करावं तेवढं कमीच आहे. ओव्हर टू यू, बसंत.
I'd like to see you guys just continue what you're doing. It's just lovely. It's great to see when our institutes do these things too. Something I wanted to say before, but probably didn't get an opportunity. Just like there are many solutions to a problem, perhaps some of them are better than others. Similarly, there is no correct way to learn things. Some learn best when told how something works. Some like seeing how it is done. Some like it being tried out themselves. So find out what's best for you and go with that. So it goes to what Naveen said. You don't really have to go and experiment. Some of us are quite happy just reading about it.
Right.
So, and one last thing, learning any of these things is useless unless we actually practice it. The scientific temperament is actually a way of life. And every time we do something that we can't justify, we are breaking it.
Yes. That's a very good point. Yes, I completely agree with you in terms of exploring what every child is different and exploring what suits best for each child. तर बसंत यांचं म्हणणं असं आहे की आम्ही प्रत्येक विद्यार्थी, प्रत्येक शिकणारा जो आहे विद्यार्थी, तो लहान असतो ते मोठा असू दे, तो वेगळा असतो, तो वेगळ्या प्रकारे शिकतो. त्यामुळे कोण कसं शिकतं हे बघणं पण गरजेचं आहे आणि आम्ही जे करतो आहे ते आम्ही करत राहू शकतो. आणि अजून महत्वाचं ते म्हणाले की वैज्ञानिक दृष्टिकोन, जसा आपण कोणतीही गोष्ट जर केली ज्याचा आपण फार विचार नाही केला आणि त्याचे 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 काय परिणाम होतील हेही बघितलं नाही कुठली गोष्ट करताना, तर मग आपण हा वैज्ञानिक दृष्टिकोन नाही. मग तो कुठलाही भाग असू दे आयुष्यातला, तर कुठलीही गोष्ट करताना आपण वैज्ञानिक दृष्टिकोनाने केली पाहिजे, त्या गोष्टींचा विचार केला पाहिजे, परिणामांचा विचार केला पाहिजे आणि मग गोष्टी केल्या पाहिजेत. असा एक म्हणजे एक संदेशही त्यांनी ह्याच्यासोबत दिला आहे, ज्याच्याकरता खरंच आम्ही त्यांचे आभारी आहोत. आणि नाउ ओव्हर टू यू पवन, व्हॉट वुड यू वांट टू से टू दिस?
Yeah, just like others have also shared that we've been actually the benefactors of the activities of the Science Center at ICER, and I would really congratulate you for really holding that throughout so many years, and especially this year also. I as a science teacher, as a person who is connected with kids, I would really wish that the lovely science labs that are there at ICER, they can have more exposure through online and even better in this time. And I've been I would say even there, I've had the pleasure of being working in one of the labs at ICER, because I was a project fellow there at ICER. Yes. And it's beautiful. It's really empowering to see the kind of science equipment that a country like ours has, a city like Pune has, and the kind of scientific power prowess that is already there. So, like the other panelists have said, even if I'm not interested in science, even if I don't want to be a scientist, at least having exposure to these science equipment or techniques gives me an awareness that this is what our country is doing right now. This is what our people are doing right now, and I can be part of that just by being aware of it. That's what I would wish, to see more of the science, beautiful science.
Okay. Sure. We will definitely look into this. We've been also planning something like this in the days to come. And all of us would really like to open our labs to the students and give them a flavor for the real experiments, at least to those who are interested, right? So पवनचं असं म्हणणं आहे की आमच्याकडे विविध प्रयोगशाळा आहेत आणि वेगळ्या वेगळ्या लॅब्स मध्ये जे होतं, जे संशोधन होतं, अशा सगळ्या लॅब्स पण मुलांना पाहता याव्या, शाळेतल्या मुलांना, कॉलेजमधल्या मुलांना, ज्यांना इंटरेस्ट असेल त्यांना. आणि असे उपक्रम आम्ही नक्कीच सुरू करू येणाऱ्या दिवसांमध्ये. And so to summarize, I really want to thank all of you for investing. I will not even say sharing, spending, investing. This is really an investment for us, for the Activity Center, and for all our viewers, that you came here, you discussed with us, and you shared your views. And I wish to thank you on behalf of ICER Activity Center, on behalf of ICER, and on behalf of our viewers. मी तुमचे सर्वांचे मनपूर्वक आभार मानते. आम्हाला वेळ दिलात, आपली मतं मांडलीत त्याबद्दल. आणि आम्ही we will try to reach to you all the time, and we will expand our activities based on the suggestions that you have had. And the last thing of the science activity program is a film which is being screened on our Science Media Center channel. And I once again thank all the panelists, and I request all our viewers to log on to the Science Media Center channel, and where the movie is being screened. Okay. Again, thank you so much, panelists, and we look forward to interacting with all of you in the near future. Okay, and the description box has a link to this Science Media Center where the movie screening is being done. Okay. Okay. Thank you so much, and we will definitely see you again in different ways, and we will collaborate. Thank you. Thank you so much.
Thank you so much. It's been a pleasure.
It's been a pleasure. Thank you.
Yes. Bye.
Bye.
I try.
For all the panelists,